Welcome to Software Engineering. Are you interested in learning about software engineering? Does finding out more about the software building process appeal to you? Would you like to get more information about software development? Does learning about the basics of programming interest you? Would you like to know more about software architecture and design? Or have you ever wondered what the job prospects are like for a software engineer? If so, this course is for you. According to the most recent U.S. Bureau of Labor Statistics report, about 1,850,000 software engineer-type jobs are posted annually in the U.S. alone, and job growth in the industry is projected to increase 22% through 2030. At the time of this course publication, the median U.S. software developer specialist salary is $110,140 US dollars annually, and per hour pay is almost $53 US dollars. Software engineering jobs are also a great way to start on your path to a high-paying career in information technology. This course has 3 instructors: Rav Ahuja, Bethany Hudnut, and Lynn Joyner. Rav is a global program director at IBM and the architect for several IBM professional certificates. Bethany is an instructional designer at Skillsets Technologies, and Lynn is also an instructional designer at Skillsets Technologies. So, what's in this course? It's divided into 5 modules: the Software Development Lifecycle, Introduction to Software Development, Basics of Programming, Software Architecture, Design, and Patterns, and Job Opportunities and Skill Sets in Software Engineering. When you complete this course, you'll be able to describe software engineering and approaches to software development, identify software development tools and technologies, compare different types of programming languages and recognize basic programming constructs, outline approaches to application and deployment architectures, and review the skills required in software engineering and describe the career options it provides. During this course, you will learn through guided instructional videos that walk you through key concepts with essential need-to-know facts, interactive exercises to reinforce what you've learned in videos, insider viewpoints that enrich your understanding of IT support work, practice assessments to help you gauge your knowledge, and finally, graded assessments to prove what you've learned. Upon successful completion of this course, you'll earn a shareable badge and certificate that you can show to prospective employers. We're here to support your success. If you have any questions for the course staff, or if you want to connect with your peers in this course, please feel free to post on the course discussion forums. We're excited you're here, so let's get started. Welcome to Meet the Experts. In this course, you will learn from several experts in various roles who will provide their insights and perspectives about software engineering. Let's meet these experts and learn about where they work and what they do.
Hi, my name is Kadesha, and I currently work as a developer advocate at GitHub.
Hey, well, my name is Liseli Bueno. I'm a software engineer, and I work at Blend, also known as Blend Labs.
My name is Tommy Young. I'm a software engineer at Google. My role is Uber technical lead, overseeing publisher video ads.
My name is Diane Panagiotopoulos. I am a research and development engineer at Bandwidth, and I work directly through Bandwidth. I am not self-employed as like a contractor with them.
Hi, my name is Zubin Pratap. I'm a software engineer, and currently I'm a developer advocate at a Web3 startup.
My name is Daniel Rudnitsky, and I'm a full-stack software engineer at IBM.
My name is James Reeve, and I'm a full-stack software engineer at IBM.
Hi, my name is Rupinder, and I work as a Chief Solutions Architect at Skillsets Technologies.
Hello everyone, my name is Upkar Litter, and I'm a developer advocate with IBM.
Hi, I'm Jan Stoneman. I'm a solution architect at Smartronix.
Now, let's listen to some of these experts describe a little more in detail about what they do.
Yes, so a developer advocate is a software engineer who enables developer to be successful with a product. That was a mouthful, so essentially what that means is, for example, at GitHub, I create a lot of content. So I will do blog posts, workshops, go to conferences to speak about GitHub, the product. I'll also showcase developers in the open source community and to like give publicity to the projects that they're working on. And being an advocate means that I'm able to communicate deeply about technical concepts in a way that's digestible for engineers across experience level to understand. Before I was an advocate, I worked as a software engineer in the finance sector for 2 years. I spent a majority of my time coding. I primarily worked on the front end of the application using tools such as Git, Docker, GraphQL, React, JavaScript, and the very few times I would go into the backend, we use Node.js on our backend to make changes and updates. My experience as a software engineer and also as a technical content creator paved the way for me to become a developer advocate at GitHub today.
I'm a software engineer right now. I'm still pretty junior, so most of my tasks involve creating new features, fixing bugs, and addressing any customer concerns that we have that they have with the current software.
Yeah, so I work on a suite of products that are they're targeted to large content creators, video publishers, customers such as ESPN, Disney, etc. And we basically have suites of tools to help them monetize their video content, help them distribute it, help them target it appropriately, report on it, troubleshoot it for across all devices, all surfaces. So it's kind of a full suite of products. It starts with the user interfaces that their sales teams and trafficking teams use to sell the ad space, upload the creatives, the advertisements, and target them to their audiences and contextually to the content that that they create. We offer reporting on that, so a lot of it's performance and various other analytics, reach analytics, and so forth.
Previously, before this, I was a software engineer at Google, and before that, I was a software engineer at a small startup. But before that, for about over 15 years, I was a corporate lawyer and then a business executive for a while, and I even had my own startup in the middle. So yeah, very diverse background. And I taught myself to code in my very late 30s when my startup started to fail, and I really needed to keep it going, and my tech co-founder quit. So that's what I do, that's who I am. Today, as a developer advocate, I not only write code, I also produce a lot of educational content and material that is useful for people to onboard onto Web3 and other technologies. And my role is really to help connect the product team with the actual developer ecosystem, bring the two together through code, content, education, and community.
Welcome to What is Software Engineering? After watching this video, you will be able to define software engineering, list the responsibilities of a software engineer, and compare and contrast software developers and software engineers. Software engineering is the application of scientific principles to the design and creation of software. The field uses a systematic approach to collect and analyze business requirements in order to design, build, and test software applications to satisfy those business requirements. When computing began in the late 1950s, software engineering was a relatively undefined discipline, but over time it transformed into a modernized engineering field. The software engineering field became a discipline in the 1960s and evolved as new technologies were developed and the approach to software development became more scientific. Trends in software engineering transformed from ad hoc programming towards more formal and standardized methods. Initially, the creation of software lacked a formal development process. As the world widely adopted computers, software became increasingly integral to more aspects of life. The inefficiencies in the software development process made it difficult to meet the rapidly increasing demand for computing resources and complex software. This led to what is known as the software crisis, which began in the mid-1960s and lasted until the mid-1980s. During this period, software development often ran over budget, behind schedule, and consisted of unmanageable, buggy code. By the time older software solutions came to fruition, newer, better, and faster technologies had already been developed, causing software engineers to have to refactor their code or completely redesign their system. Often software development solutions that worked for small software systems did not scale to large complex projects. Now, some of these issues still exist today, although to a much lesser extent, due to the consistent application of engineering principles to the software development process. Computing resources have become more widely available, and standardized methodologies for software development allow for large complex solutions that scale. The solution to the software crisis involved transforming unorganized coding efforts into an established engineering discipline. The mid-1980s also saw a rise in the growth of computer-aided software engineering, or CASE, which also helped to relieve the software crisis. CASE tools can be divided into 6 categories: business analysis and modeling, development tools such as debugging environments, verification and validation tools, configuration management, metrics and measurement, and project management. Now, the term software engineer is often used interchangeably with software developer, but there are subtle differences. Software engineers are also developers, but the term software developer is usually deemed narrower in scope than that of a software engineer. A software engineer's knowledge is usually broader. Software engineers take a systematic big picture approach in their thinking to software development, whereas developers may have more creative approaches. And both software engineers and software developers have specialized knowledge, but software engineers use that knowledge to build entire systems, whereas software developers use their knowledge to write code to implement specific functionality within a system. Software engineers are often employed on larger scale projects, and they are focused on the broad structure rather than solving an immediate problem. Software engineers are tasked with designing, building, and maintaining software systems. Their responsibilities include writing and testing code and consulting with stakeholders such as clients, third-party software vendors, security specialists, and other team members. The adoption of a measured scientific approach to software development has influenced the way software is created and designed. Today, the development process is typically guided by the Software Development Lifecycle, or SDLC. The SDLC identifies the steps needed to develop high-quality software. Later in this module, we will discuss the SDLC, the traits of high-quality software, and roles common in the field of software engineering. In this video, you learned that software engineering is the systematic approach to design and development of software. Responsibilities of a software engineer include designing, building, and maintaining software systems, writing and testing code, and consulting with stakeholders, third-party vendors, security specialists, and other team members. And finally, software engineers build systems while software developers implement specific functionalities. Welcome to Insider's Viewpoints. What is software engineering? In this video, we will hear from experts discussing software engineering.
I think software engineering is the process of using programming languages and engineering principles to build products. These products could look like web apps, mobile apps, desktop apps, operating systems, or even networking systems. It is a skill that's integral to the success of our modern society because without technology, we couldn't get a lot of things done today. Within software engineering, it's a very broad term. And so within software engineering, you have roles such as front-end, back-end, security, mobile, test, full stack, DevOps, cloud, data, and machine learning. And these are all different types of engineers within software engineering.
I would define software engineering as building and improving software from anywhere from design and architecture to the user interface to fixing small bugs. So anything that falls in that range, that's what software engineers do.
So software engineering to me, I think really has to do with, I consider it a creative process, and it fundamentally is the practice of designing, envisioning, implementing, and then supporting and maintaining software through the full life cycle of it. So not just writing code, but in thinking about the software you're building before you've even written a line of code, the journey from idea inception to actual implementation and launching of said software, and then maintaining it, improving it, supporting it, and potentially evolving it to something else. So it's very much a sort of creative and full life cycle end-to-end engineering process.
I know in the United States, at least, software engineering, software development, programming, they all have, depending on who you ask, they mean very specific things or very hazy things or very contradictory things, or it's like, why do we even have 3 different titles for the same thing? I think of those titles as kind of all meaning the same thing.
What's the difference between a software engineer and a developer?
I think the difference for me, I consider engineering to be a little bit sort of broader, software engineering to be broader than development. I think development to me means is sort of one part of the process. So I think one fundamental difference for me is I think software engineering is beyond just writing code, which I think a developer often is handed a task to write a piece of code, create a module, piece of software, whatever term you want to use. And I think engineering involves sort of starting a very long time before you would even get to the development process, and continues on beyond the time you would actually take your code, deploy it. So this kind of goes into the full life cycle.
In my opinion, there isn't a difference really. So for example, I was trained as a full stack engineer or a full stack developer, but I was hired as a software engineer to work on the front end of the company's application. So I think it's a matter of semantics, and a lot of it I think is a lot of gatekeeping to keep people who don't know anything about the industry out. Somebody who has studied CS may argue differently from I do, but as a person with a non-traditional path into the world of software engineering, I only see it as like title changes and title differences, and I think it depends on what company you work in and what company you work for, because at the end of the day, we're all using the same tools and technology to get the product shipped to production.
I think that they are pretty similar roles. They are used interchangeably a lot, I think. But I think the main difference is that software engineers are also responsible for the system design and architecture, as well as data, how it's received, used, and how it's disseminated, whereas software developers, I think, focus more on the building of apps and features.
So in Canada, being a computer programmer or a software developer is incredibly different than being a computer engineer or a software engineer, where to be an engineer, it means you've taken specific classes in like codes of ethics, and you're held to the same ethical standards as a civil engineer or a mechanical engineer. And so depending on where you are, the titles can mean very different things. And I know for like purposes of immigration, the titles also can mean very specific things, and you have to be careful about like what it is that you put down. But in job descriptions, I kind of see them all used interchangeably, and I tend to just kind of think of them all as the same thing.
It's much of more of a longer time horizon, I think, in terms of engineering versus development. And I think there's a lot more considerations and hats you need to put on throughout the software engineering life cycle versus the kind of more narrowly scoped development cycle.
Welcome to the introduction to the software development lifecycle. After watching this video, you will be able to describe what the software development lifecycle is, explain its history, and discuss some key advantages of using it. The software development lifecycle, known as the SDLC, is a systematic process to develop high-quality software in a predictable timeframe and budget. The goal of the SDLC is to produce software that meets a client's business requirements. The SDLC defines phases of the software development process that encompass their own process and deliverables. It's a cycle of planning, design, and development that can be implemented as an iterative approach to software development. Adherence to the SDLC minimizes risks and costs to the development of high-quality, deployable software. The software development lifecycle began to take shape in the mid-1960s as software development began to necessitate a more detailed approach because of its growing complexity. The SDLC led to a more deliberate approach as large corporations needed to manage complex business systems requiring heavy computational resources. In its initial conception, it used what is called the waterfall method to manage projects where the development of software follows a linear pattern through discrete stages. The SDLC has since been adapted, however, to more iterative methods in response to addressing customer needs and shifting requirements. Waterfall and other approaches to software development will be discussed in another lesson. There are some key advantages for businesses in following the SDLC. The first advantage is that it gives development teams a process to follow rather than using an ad hoc approach to improve efficiency and reduce risks. Secondly, there are discrete phases to the SDLC. Each phase is well defined so that team members know what they should be working on and when. The phases of the SDLC will be discussed in another video. Because of the well-defined phases, it facilitates communication between the customer, other stakeholders, and the development team. The SDLC offers an overview of the process so stakeholders know where they fit into that process. Also, since each phase is discrete, cross-domain teams know when they have completed their tasks and when development can move to the next phase. The SDLC provides room for iteration, where, at the end of a cycle, the process can circle back to incorporate additional requirements as needed. Problem solving is incorporated early in the cycle, so problems are addressed in a timely fashion and can be addressed in the design phase rather than during coding. Finally, each team member has a well-defined role which reduces conflict and overlapping responsibilities. In this video, you learned that the SDLC provides a systematic process for software development. Its initial development in the 60s and 70s was driven by the need for a systematic approach because of the growing complexity of software. And key advantages of the SDLC include a roadmap to the software development process helping to reduce risk and improve efficiency, increased communication between the team and stakeholders, clearly defined and understood responsibilities for each team member, and the ability to be used iteratively, allowing for changing requirements. Welcome to the phases of the software development lifecycle. After watching this video, you will be able to name the phases involved in the SDLC, describe each phase, and identify several tasks associated with each phase. There are generally 6 phases in the SDLC process: planning, design, development, testing, deployment, and maintenance. Each phase is discrete, meaning that tasks from a previous phase do not overlap with tasks in the next phase. The original SDLC was conceived as a traditional waterfall method, where the phases are linear, but have since been adapted to introduce iteration so that shifting requirements can be accommodated. Waterfall and other approaches to software development will be discussed in another video. Note that some organizations may have different names for each stage. For example, planning may be called requirements or strategy or analysis. Also, some organizations may have additional or fewer stages. In the first stage of the SDLC, the planning phase, requirements are gathered, analyzed, documented, and prioritized. When planning a software solution, the following factors must be considered: users of the solution, the overall purpose of the solution, data inputs and outputs, legal and regulatory compliance, risk identification, quality assurance requirements, allocation of human and financial resources, and project scheduling. As part of the planning process, labor and material costs are estimated and weighed against time constraints. Also, project teams are identified and roles of each team member are proposed. If stakeholders are struggling to define requirements, often the development team may produce prototypes during the planning stage to tease out those requirements. A prototype is a small-scale replica of the end product used to get stakeholder feedback and establish requirements. A prototype is used to test basic design ideas. Though prototyping usually occurs during the planning stage, prototyping can occur at various phases of the SDLC whenever requirements need to be reconsidered or clarified as the project develops. After requirements have been gathered, they are combined into a document called a Software Requirements Specification, or SRS document. The SRS needs to be clearly understood and approved by all stakeholders. The developers are also involved at this stage so they can gain a clear understanding of these requirements. Requirements and the SRS will be discussed in more detail in a later video. In the design phase, the requirements gathered from the SRS are used to develop the software architecture. Several team members work together at this stage to design the architecture. The architecture is reviewed by the stakeholders and team, and during this phase, prototypes can be designed. A prototype is a preliminary mock-up of the system or parts of the system used for demonstration purposes. The document created in this phase is called a design document and is used by developers during the next phase, which is the development phase. The development phase, sometimes called the building phase or the implementation phase, is when the developers start the coding process once the design document is completed. The project planners use the design document to determine and assign coding tasks. This phase often requires the use of programming tools, different programming languages, and software stacks. Organizations may also have standards or guidelines that need to be followed. The testing phase is next in the process once the coding is complete, and some large projects have dedicated testing teams. Code needs to be thoroughly tested to ensure it is stable, secure, and meets the requirements outlined in the SRS. Testing can be manual, automated, or a hybrid of both. Product bugs are reported, tracked, and fixed, and the code is retested until the software is stable. Some common levels of testing include unit testing, integration testing, system testing, and acceptance testing. Each of these testing levels will be described in further detail in another video. Next, the deployment phase is where the application is released into the production environment and made available to users. This can also happen in stages. First, it is released onto a user acceptance testing, also called UAT, platform, and once the customer signs off on the functionality, it is released to production. This approach can be used for making software available on a website, mobile device app store, or a software distribution server on a corporate network. Finally, the maintenance phase happens once the code has been deployed into a production environment. This phase helps to find any other bugs, identify user interface issues, or UI for short, and identify other requirements that may not have been listed in the SRS. Code enhancements can also be identified at this stage. If bugs are discovered in this phase that were missed during testing, these errors may need to be fixed for high-priority issues or incorporated into the requirements as part of a future software release, and the process can start over again. In this video, you learned that the SDLC can be divided into 6 phases. Planning involves requirement gathering and development of the SRS. The architecture is developed during the design phase, and the design document is created. The development phase is when coding takes place, and then during the testing phase, issues with the code are found and fixed if possible. Deployment is when the code is released to the production environment. And finally, in the maintenance stage, feedback is collected from stakeholders, other UI issues may be identified, and code enhancements suggested. And this information can be fed into another software development cycle if necessary. Welcome to Building Quality Software. After watching this video, you will be able to list common software engineering processes and describe the common software engineering processes required for building high-quality software. There are numerous processes that are common to software engineering projects. In this video, we will discuss 6 of them: requirements gathering, design, coding for quality, testing, releases, and documenting. The Software Requirements Specification, or SRS, encompasses the process of collecting and documenting the set of requirements that the software needs to adhere to. It may include a set of use cases that describe the business needs and user flows that the software must implement. Software requirements can be classified into 4 broad categories: functional, external and user interface, or UI, system features, and non-functional. These categories are discussed in more detail in another video. Software design is the process of transforming the requirements into a structure that is implementable using code. The software design process translates the requirements into a language the developers can use to write the code. It transforms the requirements into a software solution. The technical lead breaks down requirements into sets of related components with clearly defined behaviors, boundaries, and interactions. These components define the system architecture. The system design incorporates guidance on system functions, performance, security, and platform characteristics. The design communicates business rules and application logic. Application programming interface design, which is how apps talk to each other or communicate with the database, user interfaces, and database design. Code quality refers to the characteristics of the code, including attributes such as maintainability, readability, testability, and security. Quality code must fulfill the intended requirements of the software without defects. Additionally, it should be clean and consistent, easy to read and maintain, well documented, and efficient. Coding for quality entails following a set of coding practices during development. These include following common coding standards, conventions, patterns, and styles, using automated tools known as linters to detect pragmatic and stylistic errors, and commenting in the code itself to make it easy for others to understand and modify. Software testing is the process of verifying that the software matches established requirements and is free of bugs. Its purpose is to identify errors, gaps, or missing requirements when compared with stated requirements. Properly tested software ensures reliability, security, performance, and efficiency. Software testing can often be automated or done manually. Levels of testing include unit, integration, system, and user acceptance. Unit testing is often done by the developer and tests the smallest component of code that can be isolated from the rest of the system. Once components are integrated into the larger product, integration testing occurs. Then, after the larger product is deemed completed, system testing can take place. User acceptance testing, or UAT for short, and sometimes called beta testing, is when the software is tested by the intended end user. Types of testing can broadly be divided into 3 categories: functional, non-functional, and regression. Testing levels and types will be further explained in an upcoming video. When the newest version of the software is distributed, it is referred to as a release. Different types of releases are intended for different audiences. There is generally an alpha, a beta, and a GA release. GA stands for General Availability. The alpha release is the first functioning version of the system released to a select group of stakeholders. The alpha release likely contains errors and may not contain the full feature set, but does contain most of the desired functionality. Design changes may still occur during this release stage. The beta release, also called a limited release, is given to the stakeholders outside of the developing organization. One of the intents of the beta release is to try out the software under real conditions, test the functionality, and identify any outstanding bugs or errors. The beta release should meet all the functional requirements. Then, after beta release, changes are agreed upon, made, and tested, and a stable version is released. The audience for the GA release is all users. Software documentation should be provided to both non-technical end users and technical users. System documentation is geared toward the technical user. Technical users may be other engineers, developers, or architects. System documentation explains how the software operates or how to use it. It consists of README files, inline comments, architecture and design documents, verification information, and maintenance guides. User documentation is provided to the non-technical end users to assist them in the use of the product. Generally, user documentation is provided in the form of user guides, instructional videos and manuals, online help, and inline help. More details about documentation will be discussed in another video. In this video, you learned that requirement gathering is collecting and documenting the set of requirements that the software needs to adhere to. Designing transforms requirements into a structure that developers can use. Coding for quality entails following a set of coding practices during development. Testing is the process of verifying that the software matches established requirements and is free of bugs. There are 3 types of releases, including alpha, beta, and general availability. And finally, documenting requires text or video that explains the software to technical and non-technical users. Welcome to Requirements. After watching this video, you will be able to describe the steps of the requirement gathering process, explain the purpose of a user requirement specification or URS document, explain the purpose of a software requirement specification or SRS document, and explain the purpose of a system requirement specification or SysRS document. Requirement gathering is a 6-step process of defining a problem to be solved and documenting how to go about solving that problem. These steps include identifying stakeholders, establishing goals and objectives, eliciting requirements from the stakeholders, documenting the requirements, analyzing and confirming the requirements, and prioritizing. Generally, the stakeholders work for the organization that requests the development of the software product. Key personnel from the organization may include decision makers, end users, system administrators, engineering, marketing, sales, and customer support personnel. It is good to have a representative from every group that the product affects. The goals of the product should be clearly defined. Goals are broad, long-term achievable outcomes. Goals can include customer outcomes and business goals. Next, objectives should be identified. Objectives are more specific than goals, and they are actionable and measurable actions that achieve the stated goals. The next 3 steps, eliciting, documenting, and requirement confirmation, are usually completed iteratively. Elicitation can be accomplished through surveys, questionnaires, and interviews. As the requirements emerge, they should be documented and checked to ensure they align with the goals and objectives. Documented requirements should be easily understood by stakeholders and the project team. In order to confirm the requirements, they should be analyzed to ensure consistency, clarity, and completeness. And after analysis, the requirements should be shared with and approved by the stakeholders. After confirmation, requirements should be prioritized. Labels such as must-have, highly desired, and nice-to-have are helpful. If possible, order the requirements within those categories. Typically, there may be 3 documents that result from the requirements gathering process: Software Requirement Specification or SRS, User Requirement Specification or URS, and System Requirement Specification or SysRS. The most common of these is the Software Requirement Specification. The Software Requirement Specification, or SRS, is a document that captures the functionalities that the software should perform and also establishes benchmarks or service levels for its performance. Parts of an SRS include a purpose statement that contains the intended use of the SRS, its audience and scope, constraints, assumptions, and dependencies, and requirements which can be sorted into 4 categories: functional requirements, external interface requirements, system features, and non-functional requirements. The product's purpose describes who will have access to the SRS and how they should use it. The scope describes the benefits of the software, its goals, and objectives. And the second part of the SRS should detail constraints, assumptions, and dependencies. Constraints describe how the product must operate under given conditions that may limit options in the design phase, such as conformation to standards or hardware limitations. Assumptions may include things like a required operating system or hardware that is needed by the software to function. Dependencies on other software products should also be noted. Requirements can be classified into 4 categories. Functional requirements are those that cover the functionalities of the software. External requirements are the requirements that address the behavior of the software in relation to external entities, such as users and interactions with other hardware or software. System features are a subset of functional requirements. These are required features for the system to function. There are also non-functional requirements, such as specifying performance, safety, security, and quality standards. User requirements describe the business need and expectations of the end users from the software system. The user requirements are written as user stories or use cases that answer 3 questions. Who is the user? What is the function that needs to be performed? And why does the user want this functionality? User acceptance testing determines if these requirements have been met. Often, though, the user requirements and software requirements are combined into a single SRS document. The SRS details the expectations of the software system. The System Requirement Specification Document, or SysRS, to differentiate it from the SRS, clearly outlines the requirements of an entire system. The System Requirement Specification is often used interchangeably with Software Requirement Specification, but the SysRS is actually broader in scope than the SRS. Many software projects develop an SRS rather than a SysRS. The SysRS contains system capabilities, interfaces, and user characteristics. It also may include policy requirements, regulation requirements, personnel requirements, performance requirements, security requirements, and system acceptance criteria. It also outlines expectations of the hardware needed for the system in addition to software requirements. In this video, you learned that the requirement gathering process entails identifying stakeholders, establishing goals and objectives, and eliciting, documenting, confirming, and then prioritizing requirements. The SRS documents functional, external, system, and non-functional requirements. The URS documents user stories. And finally, the SysRS documents system capabilities and acceptance criteria, and policy, regulation, personnel, performance, security, and hardware requirements. Welcome to Software Development Methodologies. After watching this video, you will be able to list several commonly used approaches to the software development lifecycle, explain waterfall, V-shape model, and agile methods, and compare the pros and cons of each of these 3 methods. There are many ways to approach software development. A specific methodology for developing software is commonly used in order to assist the development team to clarify communication among team members and determine how and when the information is shared. In this video, we will discuss 3 of these approaches: waterfall, V-shape model, and agile. In the beginning, when the SDLC was conceived, it implemented what is known as the waterfall method. Waterfall is a sequential method of software development where the output of one phase is the input for the next phase of the cycle. Development and work on the next phase start only after the completion of the previous phase. All planning, such as defining requirements and architectural design, is done up front. The customer usually does not see the product until it is in the testing phase. For a major version release of the product, the same process is repeated, resulting in long intervals, such as years, between releases. The V-shape model is named as such because the phases form the shape of a V. The phases going down the left side of the V are called verification. Then, going up the right side of the V, those phases are called validation. The V-shape model is like waterfall in that it is also sequential. Each phase in verification corresponds with a validation phase. There are 4 stages that occur on each side of the V. Going down the V are planning, system design, architecture design, and then module design. The bottom of the V is the coding phase. And going back up the V are the 4 phases that correspond to the phases going down the V: unit testing, integration testing, system testing, and acceptance testing. The tests are written during the verification phases on the left and executed during the validation stages on the right. Now, the Agile model is different. It focuses on a collaborative software development process over multiple short cycles rather than a strictly top-down linear process. Agile is what is called an iterative approach to development. It still aligns with the SDLC, but each phase is short. Teams work in cycles, or sprints, which are usually 1 to 4 weeks long. Unit testing happens in each sprint to minimize the risk of failure. Rather than the maintenance stage of the SDLC, the final stage of the sprint is a feedback stage. At the end of each sprint, a chunk of working code is released at a meeting called the sprint demo, where stakeholders can see the new functionality and provide feedback. After the sprint demo, the entire process is repeated for every sprint cycle. After several sprint cycles, a minimum viable product, or MVP, is developed so stakeholders can provide feedback on the basic feature set. The MVP contains a feature set to validate assumptions about the software. The 4 core values of Agile development outlined in what is known as the Agile Manifesto are individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. The main difference between traditional SDLC methods, such as waterfall and the V-shape model, compared to the Agile method of software development, is the former are sequential, whereas Agile is cyclical. Traditional SDLC methods, such as waterfall and V-shape, center around the whole product being developed before soliciting customer feedback, whereas Agile focuses on quick, short bursts of development. There are pros and cons to each method, though Agile is probably the most popular method used in modern software development. Regarding the pros of the waterfall method, it is easy to understand and follow. Each stage is discrete and well-defined, making it easy for all team members to understand their roles. Also, since planning is done up front, it is easier than iterative methods to estimate a budget and allocate resources. That said, waterfall lacks flexibility. Since all planning is done up front, if a requirement is changed or overlooked, that change can be hard to incorporate at a later date. Inevitably, unforeseen complications happen or agreed-upon functionality shifts from what was initially envisioned. Like waterfall, the V-shape model is simple and easy to use. It is even more rigid than waterfall, but designing test plans during the verification phase saves considerable time during coding and validation phases. Drawbacks are also similar to waterfall because it does not readily accommodate changing requirements. Once an application is in the testing phase, it is extremely difficult to go back and change functionality. Agile development is different, relying on ongoing research, planning, and testing during product development. When adding new features to a product, development still goes through the same phases as in traditional SDLC, but with Agile, new and changing requirements are handled quickly and easily because planning is initiated at the beginning of each sprint cycle. Most resources are spent on the building phase. At the end of each cycle, the QA team, stakeholders, and the customer have some piece of working code to test against requirements and are encouraged to provide feedback. As coding languages and technologies have developed in recent years, they now allow for modular design where developers can focus on smaller chunks of code that are readily integrated into the larger product. These small chunks can be released to provide the MVP. Cons of Agile are that upfront planning, such as budgeting and scheduling, can be challenging because the overall scope of the product is not clearly defined. In this video, you learned that 3 of the common approaches to software development include waterfall, V-shape model, and Agile. Waterfall and V-shape are sequential, whereas Agile is iterative. Both waterfall and V-shape models are easy to implement, but neither accommodates changing requirements well. And Agile allows for changing requirements, but resource allocation can be challenging. Welcome to Software Versions. After watching this video, you will be able to discuss software versions on computing platforms and identify software versions and numbering. Software versions tell us a lot about programs and applications. Users can determine what software version they are using, and developers can provide useful information with version numbers. Software version numbers vary in length and meaning. However, most version numbers follow a similar format and represent similar information. Version numbers indicate when the software was released, when it was updated, and if any minor changes or patches were made to the software. Software versioning is how software developers keep track of new software, updates, and patches for programs and applications. Version numbers can be displayed in several ways. Version numbers can be short or long depending on the software and the preference of the developer with 2, 3, or 4 number sets. Each number set is divided by a period. The first release of an application or program might have a 1.0 as the version number to indicate no updates, patches, or fixes to the software. Note, a version still in beta or testing could have a version number lower than 1, such as 0.9. A program or application with many releases and updates will have a longer number, sometimes 4 different number sets within the version number. Some software developers may use dates for their versioning. For example, Ubuntu Linux version 18.04.2 was released in 2018 April. The third number set, .2, designates an additional change or update. What do these numbers mean? Some version numbers follow the semantic numbering system and have 4 parts separated by a period, but not all numbering systems follow this 4-part example. In semantic numbering, the first number indicates major changes to the software, such as a new release. The second number indicates that minor changes were made to the software. The third number in the version number indicates patches or minor bug fixes. And finally, the fourth number indicates a build number or build date, and it can indicate less significant changes made. Software version numbers are identified in the About or Help section of software. You can practice identifying your version number in a web browser. This example illustrates how to view the version number in the Google Chrome desktop web browser. However, if you are using a different web browser, you should be able to follow the same or similar steps. To view the web browser version, first select the 3 dots or 3 lines in the top right corner of your browser. Next, select the menu item, Help, then select About to view the version information. The version of your web browser will display. Are newer versions of software compatible with older versions? Lack of compatibility between old and new versions of software is a common problem. You can troubleshoot compatibility issues by viewing the software version to determine if you are using an outdated version of the software. Sometimes updating software to a newer version will resolve compatibility issues. Some software is backwards compatible. If a program or application is backwards compatible, then the older versions of files, programs, and systems will work properly with newer versions. In this video, you learned that version numbers indicate the history of changes, updates, and patches to software. Some version numbers follow the semantic numbering system and have 4 parts separated by a period. Compatibility with old and new versions of software is a common problem, and you should view the version of the software you are using to determine software compatibility. Welcome to software testing. After watching this video, you will be able to define the terms functional testing, non-functional testing, and regression testing, and compare and contrast typical testing levels. Software testing is the practice of integrating quality checks throughout the software development cycle. The purpose of testing is to check whether the software matches expected requirements and ensure error-free software. In order to test software, the team writes test cases. These test cases are written to verify the functionality of a software application and ensure requirements have been satisfied. Test cases can be written in different stages of the SDLC and may vary depending on the type of test or the method used to develop the software, such as Agile or Waterfall. A test case contains steps, inputs, data, and the expected corresponding outputs. Regardless of the test type or development method, test cases should always be written after requirements are finalized. Software testing helps evaluate the software to identify whether or not the software product meets requirements and is error-free. Types of testing can be broadly classified into 3 categories: functional testing, non-functional testing, and regression testing. Functional testing usually involves black box testing, which is a method of testing without looking at source code or internal structure. Functional testing is only concerned with inputs and corresponding outputs of the system under test, also called the SUT. It is entirely based on testing functional requirements, and functional testing can be carried out manually or using automated tools. The goal is to test the functionality of the application, making sure the application is usable and accessible. Functional testing tests the SUT to make sure it meets functional requirements. Functional testing makes sure that when user errors or input edge cases do occur, the software handles those exceptions seamlessly by displaying appropriate error messages. Non-functional testing includes testing the application for attributes like performance, security, scalability, and availability. Non-functional testing checks to see if the SUT's non-functional behavior is performing properly. Non-functional testing should answer questions like the following: how does the application behave under stress? What happens when many users log in at the same time? Are the instructions in documents and user manuals consistent with the application's behavior? Does the application behave similarly under different operating systems? How does the application handle disaster recovery? And how secure is the application? Regression testing, also called maintenance testing, confirms that a recent change to the application, such as a bug fix, does not adversely affect already existing functionality. Regression testing should occur when there has been a change in requirements or when defects have been fixed. In order to conduct regression testing, all or some of the test cases should be selected to test against the application. Regression test case selection and prioritization can be challenging and can depend on several factors. Common reasons for regression test case selection include cases that have frequent defects, contain frequently used functionality, contain features with recent changes, or are complex test cases, edge cases, and randomly successful or failed test cases. Now that we have discussed different types of testing, let's discuss testing levels. There are 4 testing levels: unit, integration, system, and acceptance. Each level occurs at a different time in the SDLC. There are 4 different levels in order to reduce the amount of time spent on testing by preventing overlap. We will discuss each of these testing levels next. Unit testing refers to the tests that verify the functionality of a specific section of code, usually at the function level. It is performed by the software developer or engineer during the development phase of the software development lifecycle. Unit testing aims to eliminate construction errors before code is integrated with other modules. Unit testing is intended to increase the quality of the resulting software, as well as the efficiency of the overall development process. Integration testing seeks to identify errors when two or more smaller independent code modules are combined. Integration testing is another type of black box testing. Prior to integration testing, smaller independent code modules that passed unit testing are incorporated into the larger software application. After modules are integrated together, then integration testing can occur. Integration testing exposes bugs that occur when those smaller units of code interact with each other. Integration testing uncovers deficiencies in communication with a new module in conjunction with other existing modules, databases, or external hardware. Integration testing uncovers situations where bugs develop due to differing programming logic between modules, for instance. Also, sometimes during module development, requirements change, and the module isn't fully unit tested. Poor exception handling can cause problems when modules are integrated together. System testing occurs after integration testing and is conducted on a complete integrated system to evaluate the system's compliance with its specified requirements. It validates the system as a fully completed software product. System testing is both functional and non-functional. And system testing is done in a staging environment, which should be similar to the production environment. And finally, acceptance testing is formal testing with respect to user needs, requirements, and business processes. It determines whether a system satisfies the needs of the users, customers, and other stakeholders. Acceptance testing is usually done by the customer or the stakeholders during the maintenance stage of the SDLC. In this video, you learned that there are 3 categories of testing: functional, non-functional, and regression. Unit testing verifies small, independent chunks of code. Integration testing looks for errors when 2 or more small chunks of code are combined. System testing validates the system as a fully completed software product. And acceptance testing verifies correct implementation of user requirements and business processes. Hello and welcome to Software Documentation. After watching this video, you will be able to list documentation formats, compare and contrast product documentation to process documentation, describe the categories and types of documentation, and explain the purpose of standard operating procedures. Software documentation is information about the software that describes what the product is and how to use it. These can be written, video, or graphical assets associated with a software product's development and use. Documentation can be in any of these 3 formats. Documentation is an essential aspect of software engineering applicable across all the phases of SDLC. Software documentation can be written for different types of audiences, such as end users, software developers, QA engineers, system administrators, and other stakeholders. Documentation can be divided into 2 categories: product and process. Product documentation relates to the product's functionality, whereas process documentation describes how to complete a task. Process documentation should provide the requirements for the quality implementation of a business process. Okay, now let's discuss some specific types of product documentation. There are many types of documentation, and we will discuss 5 categories, including requirements, design, technical, quality assurance, and user documentation. Requirements documentation is written during the planning phase of the SDLC and is intended for the development team, including the developers, architects, and QA personnel. Requirements documentation describes the expected features and functionality of the software system. It includes the software requirements specifications, system requirement specifications, and user acceptance specifications. Design documentation is written by the software architects and the development team to explain how the software will be built to meet the requirements. It consists of both conceptual and technical design documents. Technical documentation includes comments written in the code to help other developers read the code to understand its behavior. It also may include working papers that explain how the code works, and documents that record engineers' ideas and thoughts during project implementation. Quality assurance documentation includes all documents that pertain to a testing team's strategy, progress, and metrics. Types of test documentation include test plans, test data, test scenarios, test cases, test strategies, and traceability matrices. Traceability matrices map test cases to their requirements. User documentation is intended for end users and explains how to operate the software or help them to install or troubleshoot the system. End user documentation includes frequently asked questions, installation and help guides, tutorials, and user manuals. Standard operating procedures, called SOPs, often accompany process documentation. Process documentation provides an overview of a process, but SOPs go through much greater detail. The SOP is written documentation that explains step by step how to accomplish a common yet complex task that is organization specific. For example, checking in code using a code repository is common knowledge for a software engineer. However, an organization might have specific steps to follow for that organization in order to get code merged into the main branch. The SOP documentation explains those steps in detail. SOPs can be in the form of a flowchart, a hierarchical outline, or step-by-step instructions. Documentation in any form must be kept up to date. Take, for instance, online user manuals. If a cloud-based application user interface changes, then the accompanying online documentation must be updated accordingly. Businesses need to ensure they allot resources for this step. With regards to the software development in the SDLC, updating documentation happens during the maintenance phase. Ideally, documentation should also be reviewed periodically to ensure its accuracy. In this video, you learned that documentation comes in 3 formats: written, video, or graphical. Process documentation describes how to complete a task. Product documentation relates to how a product functions. The types of product documentation include requirements, design, technical, QA, and user. And SOPs are written instructions detailing an organization-specific procedure. Welcome to Roles in Software Engineering Projects. After watching this video, you will be able to list the common roles on a software engineering project, describe each role, and explain the responsibilities of each role. There are several common roles on a software development project, and these roles can have different names depending on the approach being used, such as Agile or Waterfall. Sometimes different companies have different names for similar jobs, but not all projects will have all these roles. The roles we will discuss in this video are Project Manager or Scrum Master, Stakeholder, System or Software Architect, UX Designer, Software Developer, Tester or QA Engineer, Site Reliability or Ops Engineer, Product Manager or Owner, and Technical Writer or Information Developer. Now let's describe each role and some of the responsibilities for each job. Traditional SDLC methods have project managers, but in Agile, the equivalent role is called a Scrum Master. A project manager makes sure the project runs smoothly and facilitates communication about the project. The project manager often deals with bigger picture issues such as planning, scheduling, and budgeting, allocating personnel and resources, executing the software plan, and team communication. In Agile, there is a Scrum Master. Rather than focusing on planning, the Scrum Master is focused on ensuring team and individual success. Remember that the 4 core Agile values prioritize people and communication over processes, and the Scrum Master is responsible for facilitating that communication. The stakeholders are the people for whom the product is being designed. They include individuals such as the customer, end users, decision makers, system administrators, and other key personnel. The stakeholder is mainly responsible for defining project requirements and providing feedback if the team members need clarification on requirements or if a proposed solution cannot be solved as planned. The stakeholders may also sometimes participate in beta testing and acceptance testing before the software is released. The system architect designs and describes the architecture of a project as well as communicates that architecture to team members. They are sometimes also called a software architect or a solution architect. They are responsible for designing the essential characteristics of the inner structure and technical aspects of the software. The architect provides technical support across the different stages of the SDLC. Note, software architecture will be discussed in further detail in another module. UX means user experience. The goal of a UX designer is to balance making the software intuitive, but also as robust as it needs to be to address requirements. They define how the software behaves from the user's perspective. The UX designer determines how the software communicates its functionality to the end user and how the end user interacts with it. Next, the developers write the code that powers the software. Responsibilities include implementing the architecture laid out in the design document, incorporating the requirements laid out in the software requirements specification, and employing the UX requirements determined by the UX designers. Testers, or QA engineers, are in charge of ensuring the quality of the product and that the software solution meets customer requirements. They are responsible for writing and executing test cases to identify bugs or deficiencies and provide this feedback to the development teams. A site reliability engineer, sometimes called an SRE or ops engineer, bridges development and operations by combining software engineering expertise with IT systems management. They track incidents and facilitate meetings to discuss them. They also automate systems, procedures, and processes, assist with troubleshooting, and ensure reliability for the customer. The product manager or product owner has the vision of what the product should look like. They have an intimate understanding of the client's requirements and the end user's needs. They are responsible for leading development efforts to create the software and for ensuring the product provides the value stakeholders are looking for. Finally, the technical writer or information developer writes documentation for the end user. They write documentation on technical material geared towards a non-technical audience. Not only does this documentation help the end user to use the software, but it also helps the customer so they can provide timely feedback to the development teams. Technical writers may be asked to write user manuals, reports, white papers, and press releases. In this video, you learned that there are a variety of job roles on a software development project, and each occupation has responsibilities unique to each role. Welcome to Insider's Viewpoints, job roles in software engineering teams. In this video, we will hear from experts discussing the various job roles you can expect to work with on your software engineering team.
Yeah, so on the engineering team I worked with, we had a product manager, we had a tech lead, we had a few QA analysts or test engineers, and we also had access to UX designers. And so the product manager ensured that we were on task and on track to deliver the features that we said we were going to build according to the business needs. That way we're not left behind.
Yeah, I think in my experience, the roles that software engineers would interact with the most, I think would in no particular order, product managers. So the folks who are actually sort of working with the sales teams, the marketing teams, figuring out what actually needs to be built, what are customer needs, what are innovations and ideas that looking forward that you might want to invest in and build out.
We asked our experts to describe these job roles in software engineering teams in further detail.
I think software engineering these days, as it becomes more and more, it's more and more large scale, more complex, more systems at play, more considerations. There's just a lot of things to consider in today's world as a software engineer. So you often work with a project or program manager who helps you set up your timelines, helps you ensure you're meeting your goals, helps you unblock yourself, helps you keep your stakeholders up to date with what is happening with your project. So there's just a lot of pieces involved, and I think project and program managers really are there to help tie it all together.
So the product manager would always act somewhat like a scrum master. So like we would have stand-ups and we would talk about the tickets that we had in Jira, and it was like, okay, so what are you working on? What do you need help with? And are there any issues? And during that process, the product manager does ensure that we were on task and on track, and if we had any issues, he would help us to resolve it.
You'll have a software engineer who's more focused on the architecture, and they can keep the big picture in their brain more easily. And then some software engineers who are more the nitty gritty, I'm sitting down and I am writing code, and my job is to like turn business logic into computer logic. And some companies have those all split out as different roles.
I think software engineers and these roles, the more they're embedded and work closely together and actually collaborate as part of a single team versus handing off things in a more waterfall approach, I think that's generally the best way, or one of the most effective ways, is to actually work together as much as possible. Regular check-ins, actually having brainstorming sessions, group chats that involve all the various folks from all the roles. I think close collaboration there is super key.
And at some companies, all the different hats have their own titles. So you might be talking to a software engineer who's actually doing more kind of DevOps, infrastructure building, monitoring and alerting kinds of work. And then there's a software engineer who's also doing QA work, and they're the ones who are focusing on pipelines and continuous development, continuous integration type projects, working on getting test suites and automation all set up.
In terms of working with the UX designer or the UX engineer, they would give me like specific specs from Figma in order to meet the certain specifications of the business. And let's say we're building a checkout page, so the UX designer would design the spec out page in Figma and then deliver that spec to me, and then I would code it according to the design.
UX designers who actually come up with if you are working on and engineering a user interface, you'll work with UX designers to essentially from the moment of sketching out sort of a draft on paper or a whiteboard of an idea, all the way down to working with them on mocks, then implementing the mocks and iterating on those. UX researchers often are worked with when you actually need to go out and do research in market and interview your partners or customers to get sort of as real time as possible and just real feedback from real users of your software.
So once I code something, I get it reviewed by my tech lead or my senior engineer. It would go to QA for them to test the application to ensure that whatever I did or implemented didn't break anything. If something is broken that I didn't catch, the QA tester would write up like a test plan or would do like a detailed testing document. That way I understood exactly what needed to be resolved, and I would resolve it and then go back to the QA person and say, hey, this is fixed, can you take a look at it again? And they would tell me whether or not it's fixed and whether or not something else was broken, which often happens with code.
So you generally work a lot with product managers because you need to know what to build. They generally give you a lot of guidance on on what they want to build, and you collaborate with them in terms of how to build it and discuss trade-offs and timelines and expectations. So it's a very much a collaborative process.
Typically, I have found that I interact most with product owners. So either at some places it's been a customer who works inside the company, and so I go to them quite frequently for questions on clarifying refinements, for getting test schedules up and running, for figuring out pain points and trying to optimize their workflows using technology to support them.
Software engineers work often with site reliability engineers, or sysadmins as maybe the role could be called, to actually maintain and help run the software and deploy it and actually get it running somewhere that's not on your desktop. You often work with more dedicated test engineers who are responsible for end-to-end testing, automated testing, integration testing at all points of the life cycle.
So as an engineer, you're never alone, you're never working alone. It's just a matter of like knowing how to communicate directly with the people on your team.
Hello, welcome to Overview of Web and Cloud Development. When you're starting out as a web developer, it can be difficult to determine what you need to learn and what order you should learn it in. Understanding how familiar websites are constructed and delivered to you is a good starting point. Let's review the basics of how you interact with a website. You launch an internet browser. There are lots available. Google Chrome, Microsoft Edge, Mozilla Firefox, and Apple Safari are some of the most popular. The browser has an address bar into which you enter a URL, like www.ibm.com. The browser then contacts the server with the name and requests the information that makes up the website. The server then sends a response, which contains the data that the client requires to display the website. For most websites, the server will return HTML, which defines the structure of the page but doesn't look very attractive, CSS, which adds style and flair to the page, and JavaScript, which adds interactivity and dynamic content. Content displayed by websites can contain elements that are either previously stored on the server, called static, or generated each time they are requested by the client, called dynamic. Dynamic elements can involve information coming from other systems and applications, such as databases. Most websites contain static and dynamic elements to provide the best user experience. Cloud applications are similar to websites in that they request content that a server returns. Cloud apps are built to work seamlessly with a cloud-based back-end infrastructure, cloud-based data storage and data processing, and other cloud services, making them very scalable and very resilient. The environment for building websites and cloud applications is divided into two primary areas, front-end and back-end. The front end deals with everything that happens at the client side, everything the user can see and interact with. You can choose to specialize in front-end coding using HTML, CSS, JavaScript, and related frameworks, libraries, and tools. The back end deals with everything that happens on the server before the code and data are sent to the client. The back-end coding usually handles the logic and functionality that make the website or app work, and the authentication processes that keep data secure. Back-end developers may also work with relational or NoSQL databases, even collaborating with database administrators in bigger projects. Full-stack developers have skills, knowledge, and experience in both front-end and back-end environments. Whichever way you choose to specialize, you will need the appropriate tools to help you work. The first tool most developers add to their resources is a code editor. Developers also need tools to integrate, build, compile, and debug code. Integrated Development Environments, or IDEs, incorporate some of these additional capabilities beyond just code editing and make it easier to build and manage your code. Good IDEs support multiple languages and integrate with management and storage tools like Git and GitHub. Other useful features are custom extensions and themes for supporting your working style and environment. Examples for code editors and IDEs include Sublime Text, Atom, Vim, VS Code, Visual Studio, Eclipse, and NetBeans. In this brief overview, you learned about the basic communication between client and servers, how websites are built and displayed. Front-end development is about what happens on the client side. Back-end development is about what happens on the server. Full-stack development includes both front-end and back-end development. IDEs will help you create and manage your code. Internet websites offer lots of different services, one of the most popular being online shopping. When you explore an online shopping website, navigating through pages, choosing different product categories, or comparing products, you are interacting with the front end of a website. Let us see how the front end of a website is developed by front-end developers. For this, we need to understand how a website is made. To create a website, web developers usually use hypertext markup language, HTML, cascading style sheets, CSS, and JavaScript. These languages are designed to work in conjunction with each other. HTML is used to create the physical structure of a website. The physical structure contains elements such as text, links, images and videos, page dividers, and buttons. The HTML code ensures a proper formatting of all text and image elements so that browsers display the page consistently. The back-end developer codes the structure of the website. A website is like a house which has only been constructed. Just like we need interior designers to add style to a space, we need front-end developers to add the necessary glamour and appeal to a website. When you order products from any website, you realize that the pages have a pleasing font, attractive colors, and are easy to navigate. Developers use CSS to create stylish websites. CSS provides front-end developers with a standard method to define, apply, and manage different sets of style characteristics for a website and each of its components. CSS ensures uniformity in look and feel, style, colors, fonts, designs, and layouts. So, HTML is used to create the structure, and CSS is used to design it and make it appealing. CSS is also used to create websites that have cross-browser compatibility, which means that they are compatible with multiple browsers and multiple devices, such as PC, mobile devices, iPads, etc. Online shopping websites are intuitive, interactive, and quick to load. This is where JavaScript comes into the picture. JavaScript is an object-oriented programming language that is used in conjunction with HTML and CSS to add interactivity to a website. For example, you use HTML to add a login button to a page and CSS to style that button. Then you use JavaScript to add login functionality to that button. A new front-end development language is Syntactically Awesome Style Sheets, SASS, called Sass. It is an extension of CSS that is compatible with all versions of CSS. Sass enables you to use things like variables, nested rules, and inline imports to keep things organized. Sass allows you to create style sheets faster and more easily. Another language that is being used now is Learner Style Sheets, LESS, or LESS. LESS enhances CSS, adding more styles and functions. It is backwards compatible with CSS. LESS.js is a JavaScript tool that converts the LESS styles to CSS styles. Using all these languages, websites are designed as reactive and responsive. Reactive Or adaptive websites display the version of the website designed for a specific screen size. For example, a website can provide more information if opened on a PC than when opened on a mobile device. Responsive design of a website means that it will automatically resize to the device it is being accessed from. For example, if you open up a product's website on your mobile device, it will adapt itself to the small size of the screen and still show you all the features. A JavaScript framework is an application framework that is written in JavaScript. Programmers can manipulate the different functions, use them wherever required, and can create device-responsive applications. A few examples of several frameworks being used are Angular Framework, an open-source framework being maintained by Google. Angular frameworks allow websites to render the HTML pages quickly and efficiently. It has built-in tools for routing and form validation. React.js has been developed and maintained by Facebook. It is a JavaScript library that builds and renders components for a web page. It is not a complete suite of tools. For example, routing is not a part of this framework and will need to be added using a third-party tool. React.js only helps build and drop components into a page. Vue.js is maintained by the community and its main focus is the view layer, which includes user interface, buttons, and visual components. It is flexible, scalable, and integrates well with other frameworks. It is very adaptable. It can be a library or it can be the framework. The task of a front-end developer evolves continuously. The technologies are upgraded constantly, and so front-end developers need to keep upgrading the websites that they create. The websites that they create should work in multiple browsers, multiple operating systems, and multiple devices. Welcome to the importance of back-end development. A front-end developer creates websites and cloud applications using HTML, CSS, and JavaScript to create what the user sees and interacts with in the client software. A back-end developer creates and manages all the resources that are needed to respond to the requests that the user makes through the client. The back-end developer's tasks focus on enabling the server infrastructure, or back-end, to process requests, supply data, and provide other services securely. Front-end and back-end developers must work together very closely. Each needs to understand the requirements of the solution and how their respective parts will interact before the development process can begin. Throughout the lifecycle of the website or cloud app, front-end and back-end developers collaborate to resolve issues and add functionality. How does the work of a back-end developer affect you as you are browsing the internet or using a cloud app? Think about it like this. When you're shopping online, what happens to the data you enter? Your login information, your product searches, your payment info. The back-end processes all of these things, and the back-end developers write and maintain the parts of the application that process the inputs. Let's think about your experience as you explore an online shopping site and make a purchase. As you search for products, your search request is submitted to a web application, which then retrieves the data from a separate database and serves it back to the client for display. To facilitate this, a back-end developer must understand the language that the web application uses, how to query the database for the correct data, and how to bring the two together. Even a simple task like navigating around the site can require the skills of a back-end developer. Many sites have restricted areas that are only available to users who have an account and have logged in. User account management, authentication, and authorization can be the responsibility of the back-end developer too. Once you've decided what you want to purchase, you must add it to your cart and make a payment. The purchase process requires you to submit sensitive information, such as your address and credit card number, and the back-end developer must ensure that this data is securely handled and stored. Front-end client interactions, whether a request for data like an image, accepting input from a user filling out a form, or securing sensitive information like a credit card number, all require different services from the back-end server. Each request needs to interact with the back-end in a different way. Back-end developers use APIs, routes, and endpoints to process incoming requests. An API is code that works with data, usually using JSON or XML. APIs have set rules and structure. A route is a path to a website or page that the user interacts with. Routes generally take user input and show results based on the input. An endpoint may be an API or may simply be a path. When a request from the front end arrives at the back end, it is routed to the correct service. If the back end has an endpoint defined for the request by using routing, the request will be addressed and replied to. If the endpoint is missing, the server returns a 404 error. Back-end developers must create and maintain this server-side routing. Along with back-end APIs, routes effectively allow the front-end client to plug into the correct socket at the back-end. APIs provide a mechanism for cloud apps, mobile apps, and other types of software to access resources from the back-end. To perform all this back-end development, you will need to be familiar with at least one back-end language and its associated frameworks. Among the most popular languages today is JavaScript, which was originally designed to run in web browsers, adding extra interactivity and dynamic content to web pages. JavaScript is also being used on the back end, with new releases adding server-side functionality. JavaScript has many frameworks, but two of the most well-known are Node.js and Express. Python is another popular language. It's very flexible and easy to learn. Python has wide functionality. It can be used for everything from creating web pages to connecting to a database to performing data analysis. Two well-known Python frameworks are Django and Flask. Back-end developers often work with data and databases, so you will also benefit from learning some SQL. To help handle requests from databases, back-end developers can use Object Relational Mapping Tools, or ORM, to connect to the databases and retrieve the correct data. Although an ORM can hide some of the complexity of querying databases, it's useful to understand the fundamentals of databases so that you can troubleshoot any issues that arise. The day-to-day tasks of a back-end developer focus on the behind-the-scenes functionality that keeps websites, cloud apps, and mobile apps up and running. Back-end development covers a wide range of technologies, from managing user accounts, authentication, and authorization, to ensuring that sensitive data is stored and transferred securely. Back-end developers also work with databases, retrieving, processing, and storing data as required. Life for a back-end developer is varied, challenging, and ever-changing. Welcome to Teamwork and Squads. After watching this video, you will be able to define teamwork and describe the advantages of collaboration in software engineering, and describe squads. By definition, a team is a group of people working together towards a common aim. Within a team, you'll find a range of different people with different skills, experience, and talents. Each person can give their attention and effort to the things that they are good at, and by working alongside others on tasks outside their current repertoire, they can expand their skill set. Working in a team promotes creativity. Collaborating with others gives you the opportunity to discuss ideas and challenge one another's thinking about a subject. Good teamwork is empowering. Positive attitudes and behaviors can impact the rest of the team and create positive results. Working well as a team doesn't always come naturally, but there are some things you can consider to help your team succeed. Each member needs to trust and respect the other members of the team. This generally comes with time, but depends on all of the members contributing equitably. Defining and agreeing on goals for a project is essential so that the whole team knows what they are working towards. And you also need to define and agree on roles to avoid any duplication of effort or missed tasks. Working with each member's strengths is important to make the most of the talent within your team, as is celebrating success and analyzing problems. Communication is vital in a team environment. Ensure that you choose a method that works for everyone so you know that the whole team is seeing and responding to information. So, what does teamwork look like in software engineering? Teams often start projects with a kickoff meeting where they plan how they will complete the project, assign tasks, and agree on goals. Throughout the lifetime of a project, you're likely to have a whole team and/or sub-team meetings to review progress and plans. Design and code reviews can be requested at the team level and undertaken by whoever has availability at that point in time. Also, team members might present walkthroughs of their sections of responsibility to the rest of the team so that the whole team has oversight of all parts of the project. And key team members will likely present walkthroughs to stakeholders at various times during the project. When a project is complete, retrospective meetings may be held to review what went well and what could be improved in future projects. You may have a mentor who may or may not be in your current project team. You might also be asked to be a mentor. Sometimes team mentoring is used so everyone can learn from each other. And some groups also have teams working on internal projects, such as defining code standards, maintaining or updating legacy cross-project code, or reviewing potential new software for usefulness to the team. Good teamwork can bring many benefits to a project. Working alongside others can encourage creativity and enable you to take advantage of each person's strengths, while also allowing them to gain knowledge and skills from other members of the team. When working as part of a team, software engineers are more likely to adhere to corporate coding standards and regularly document their code. The additional accountability that teamwork creates results in better quality code, fewer bugs, and more maintainable code. From a software engineer's point of view, working as a team can reduce stress because there's always someone to turn to and get help from. And having someone to discuss problems with can help you to increase your understanding and resolve more issues by yourself. By working in a team, each member has a greater idea of the bigger picture, resulting in a more coherent overall solution. Some organizations that follow agile development methodologies may call a team a squad. Typically, a squad is a small team of up to 10 developers. It is likely to consist of a squad leader, who acts as the anchor developer and coach for the squad, and a few software engineers who develop and implement the product features and test cases. It may also include 1 or 2 user experience developers or designers. In some squads, the developers may work together in pairs to practice pair programming. You'll learn more about pair programming in another video. In this video, you learned that software engineering teams meet regularly throughout the duration of a project. Good teamwork encourages creativity, shares knowledge, and results in better quality code. And squads are small teams used in agile development. Welcome to Insider's Viewpoints, Teamwork in Software Engineering. In this video, we will hear from experts discussing how teamwork is important in software development and how teams work together.
Yeah, so teamwork is very, very important in the world of software development. As a software engineer, you're not just going to be sitting at your desk coding all day. One of the most important aspects of working on a team or on an engineering team is communication and knowing how to collaborate and speak with your team members about the code you've written, especially if you're going to a UX designer and say, hey, here's what I can do, and your spec is a bit off. Can we massage your specs a bit just so we can meet the coding requirements?
Incredibly important. While I think it's possible for a single person to engineer and deploy and run software, I think doing it as a team is both more impactful and gives you more potential to do bigger and greater things. I think it's also just a more fulfilling process when you're building something with a group of individuals. I think without the support structure, it's hard to build something and support it and maintain it just by yourself.
So teamwork to me is essential because we're talking to each other all day, and we're not only talking to our tech leads or senior engineer, we're talking to product managers, we're talking to UX designers, we're talking to business analysts, we're talking to data analysts, and so on and so forth.
You have the support system, you have diversity of opinions and perspectives in terms of how you go about building it. It's more satisfying. You kind of can take larger risks because you're in it together and you're there to support each other. I think the celebration of a job well done is a lot more, it's a lot more fulfilling when you're doing that with someone else. But I think it just gives you both kind of a larger range of scope and a larger sort of risk portfolio, if you will, and you're able to, I think, just get a lot more done, have a lot more checks and balances, and really gives you, there's a less likely chance that you're going to miss something or you're going to make a mistake. There's a lot of support there.
And so every project I've worked on has had at least 3 other people that I have needed to communicate with and to support, to be a reliable resource for them, to go to them for questions. Like I always have to be talking to somebody about something. So teamwork is crucial. Like you can't work in an isolated silo forever. At some point, you have to talk to someone else.
Building a product takes a lot of people. A lot of us come together to make a whole and to get the product shipped to production so our users can use it. And so teamwork is imperative.
Welcome to Pair Programming. After watching this video, you will be able to describe pair programming and compare different styles, and list the benefits and challenges of pair programming. Pair programming is an extension of teamwork where 2 developers work side by side at one computer. They can either be physically at the same computer or work virtually via video link or shared screens. The former is the preferred option, but virtual pair programming can also be productive. Pair programming is a type of agile development where 2 developers can plan and discuss their ideas continually as they create a solution, generally resulting in a better end product. And there are various styles of pair programming. Driver-navigator style is the most common style, where one developer is the driver typing in the code, and the other is the navigator reviewing the code as it's written and giving directions where to go next. The navigator also keeps an eye on the bigger picture of the overall solution. When working in this way, it's important to regularly swap roles to keep both of the pair engaged across the whole task. Ping-pong style incorporates test-driven development. For each task, one developer writes a failing test, and then the second developer writes code to pass that test. For each new task, they swap roles, so regularly changing who writes the test and who writes the implementation. The 2 developers work together at the end of each task, refactoring the successful code to refine and improve it. Strong style pair programming is a good way for junior software engineers to learn from more experienced ones. The defining rule for this is that for an idea to go from your head to the computer, it must go through someone else's hands. So the more experienced of the pair is the navigator, and the driver learns from witnessing their implementation and thought processes. For this to work well, the driver shouldn't challenge any ideas until the full implementation is complete, so as not to interrupt the flow of ideas from the navigator. Now, pair programming has many benefits. It's a good way to share knowledge and skills from one developer to another, or between the two, and a great way for a new team member to get up to speed on a project. As well as enhancing the technical skill of the pair, it's also a good way of building soft skills, such as communication and problem solving. Having two sets of eyes on the code often results in fewer typos, logic errors, and bugs. And it enables code reviews to be done on the fly. While this doesn't replace formal code reviews, it does enable another layer of review. Now, having two people thinking about a problem can result in multiple initial ideas, but is likely to result in the optimal approach being chosen earlier in the process. And although pair programming can take longer than individuals writing the same solutions, it's likely to result in better code with less time spent reviewing, testing, and bug fixing. There are also a few challenges to overcome. Working in a pair requires long periods of focus, which can be exhausting for the two programmers, and personal or other work commitments can impact the pair schedule. Sometimes one of the pair can end up controlling the entire process, resulting in a more typist programmer pairing, which doesn't benefit from any of the positives of pair programming. At other times, individual personalities may not work well together. When multiple sets of pair programmers are present, their discussions can result in a noisy environment for the other workers in the room. In this video, you learned that pair programming is an agile development technique where two developers work alongside each other. There are multiple styles of pair programming. And pair programming builds technical and soft skills, results in better quality code and solutions, and increases overall efficiency. Welcome to Insider's Viewpoints, Pair Programming. In this video, software engineers will discuss their experiences with pair programming and share their thoughts about the benefits and potential challenges associated with this way of working. First, we will begin by asking about their experiences with pair programming and about the benefits they associate with it.
At every job I've ever had, there have come times where you pair up with someone else, you get someone else sitting next to you at a computer, or you're sitting next to them at their computer. You're looking at a problem together, you're thinking about it.
Yes, I have actually. Some of the benefits are definitely working with an engineer who might be more of a senior engineer because they have a lot of insight and they obviously have a lot of experience doing what you're probably trying to figure out how to do. And it's really great when it's someone who can both guide you, but also kind of take a step back and not take over at the same time.
I think pair programming can be very beneficial. I think when you're working with someone together, it's an opportunity to learn. I think pair programming can be very great in circumstances where someone is new to a team, new to a programming language, new to a set of tools, or a development environment that is new to them. Sitting next to someone who's an expert, I think, can both help you ramp up more quickly. It can help the team itself sort of understand where you are in terms of your own knowledge and journey, and help put you in a place to both succeed and utilize you and your skills as best as possible. It does help you get real-time feedback. You don't necessarily have to wait for code to be sent out to be reviewed, and you can kind of brainstorm together in real time on the actual implementation of it.
Ultimately, I try to keep in mind that the goal of pair programming is that everyone has inherent blind spots in the way that they think and the way that they approach a problem. And if you are talking to somebody else, they can point out what your blind spots are. And they're going to have different blind spots than you as well. So you can point out their blind spots.
What do you think are the drawbacks and challenges of pair programming?
I think that can be a con sometimes when you're working with another engineer and you're trying to pair program is someone who kind of like takes over and then doesn't allow you to do your part or to learn, especially if they kind of like already know how to do something. So it's kind of like a double-edged sword. On the one hand, you want to get that practical experience of pair programming and you want to get that experience from someone else. But at the same time, you want to make sure that you're learning.
I personally find pair programming to be a little frustrating because the ways I go about solving problems can be very different than the ways other people go about solving problems. And it's not that I have some special, unique, wonderful technique. It's just that everyone's brain works differently. And watching someone else go through their workflow of how to solve a problem, they're not clicking the exact same buttons that you are. And that can get very frustrating to me. And it's like, why are you using your mouse to click all of those things? There's keystrokes for it. Like, you could be doing this so much faster. And so I find it a challenge to do pair programming sometimes.
You actually need calendar time, so you need to be able to dedicate time to sit together and work together and have an aligned schedule. You can either be physical, you can do it virtually, but you need to make the time to do it. Pair programming can come with some overhead in terms of getting off the ground. So if you have a tight time crunch, competing priorities, maybe just not enough, there might be not enough time in the schedule to allow for it. That can be one of the cons, is that it can, while you can get long-term, I think, efficiency benefits from, writing the code together, because then support in the future will be easier because you have more people who know how the code was written and what the intent was. So there are definitely long-term benefits, but there could be, some short-term costs to it. So there are trade-offs in that sense.
Welcome to Introducing Application Development Tools. Getting your cloud app from the idea stage to fully formed, written, and deployed is a long process, but there are many tools which will help you along the way. A cloud application developer's workbench includes version control, libraries, and frameworks. When many developers are working on the same project, knowing what order changes were made, thereby creating a new version of the source code, becomes overridingly important. Version control systems keep track of what changes were made when and by whom, and resolve any conflicts between changes. For developing your code, version control can be useful even when you are the sole contributor on a project. Properly used, it can give you a way to revert to an older version of your code if something goes wrong, and gives you some basic information about how the code developed over time. Version control functionality is generally tied to the storage system you are using, which is why a code repository is recommended, even for beginners. Git and GitHub are extremely popular for source code storage and management. Git stores files in repositories where you can track changes, split code into different branches for more focused development, and then merge them back into the main body of code. Libraries are collections of code, like standard programs and subroutines that you can use within your code. For example, you might want to include a navigational feature, like a carousel. A code library can supply you with the code for that so that you don't have to spend the time and energy creating one from scratch. Being able to reuse code in this way makes developing your app much quicker and easier. Multiple code libraries can be integrated into your existing project. As you discover a need for a specific function or feature, you can research an appropriate library. You determine when to call the required method as needed. The control returns to the program flow once the subroutine is finished. When you use a code library, you are in control. Code libraries are generally used to solve a specific problem or add a specific feature set. Either way, there are lots for you to choose from, so do your research. Here are some examples of code libraries. jQuery is a JavaScript library that simplifies DOM manipulation. Email Validator is a small library that checks an email address is correctly constructed and valid. Apache Commons Proper is a repository of reusable Java components. Frameworks provide a standard way to build and deploy applications. You can think of a framework as being a skeleton that you can extend by adding your own code, providing a scaffold on which to build your apps. The framework you intend to use must be determined early in your development planning and used right from the beginning. New frameworks can't be incorporated into an existing project. Your chosen framework dictates the architecture of your program and controls the program flow. The framework determines which subroutines and methods will be called when. When working with a framework, there is a specific structure that you must follow. The framework calls on your code rather than you calling on the framework. Frameworks are less flexible than libraries, allowing you less control, but they do provide good standardization and can help you create efficient code. To use an analogy, if you are a carpenter building a house, the framework is the frame that you add to, bricks on the outside, plasterboard on the inside, and so on. The frame acts as a guide for how the house is constructed. Here are some examples of frameworks. AngularJS is a JavaScript-based framework for dynamic web applications. Vue.js is a JavaScript framework focused on the user interface. Django is a framework that uses Python for web development. Frameworks define the workflow that you must follow, unlike libraries, which allow you to call functions as and when required. When using a framework, it can sometimes feel like you, as a developer, are not in full control of the development process. This sense of the framework and its predefined workflow controlling the development process is referred to as inversion of control. Frameworks that have a lot of control are known as opinionated. They have opinions on how their workflow should be used and remove a lot of the decisions you would otherwise have to make about how code is written, the location of files, and even file names. Frameworks often include their own libraries, which they can call when needed. Inversion of control allows you to create standardized apps and takes away a lot of the tedious configuration work, so you can focus on the code for your app. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including version control, libraries, and frameworks. Welcome to more application development tools. Let's look at some tools which can help you get your app built and deployed. CI/CD, build tools, packages, and package managers. CI/CD refers to the practices of continuous integration and either continuous delivery or continuous deployment. CI/CD is a best practice for DevOps teams, enabling developers to deliver frequent changes reliably. Implemented through a build automation server, continuous integration, or CI, ensures that all the code components work together smoothly. A CI build environment enables you to integrate newly developed code frequently, at least every day, if not every hour, depending on how quickly the project changes. Continuous delivery, or CD, begins where CI ends. The CI process automatically builds and tests your code, then CD deploys all code changes in a build to a testing or staging environment. A build tool transforms your source code into the binaries needed for installation. Build tools organize your source code, set compile flags, and manage dependencies. They are most important in environments where there are many interconnected projects with multiple developers contributing to each project. In these environments, it can be very difficult to keep track of what changes were made, in what order, what dependencies exist, and what needs to be incorporated in the next build. So automation is key to keeping everything running smoothly. Build automation can automate a wide variety of tasks that developers do in their day-to-day activities, like downloading dependencies, compiling source code into binary code, packaging that binary code, running tests, and deployment to production systems. You can initiate a build from the command line or from an IDE. There are two categories of build tools widely in use. Build automation utilities, which generate build artifacts like executables by compiling and linking source code. Build automation servers, which execute build automation utilities on a scheduled or triggered basis. Some examples of build tools are Webpack, a module bundler for JavaScript, Babel, a JavaScript compiler, and WebAssembly, a binary instruction format that runs in your browser. Now that you have your app developed and tested, you're ready to deploy. But how does that happen? The app needs to be simple and trouble-free for the user to install. So a commonly used technique is to collect all the necessary files and bundle them together into a package. Packages are archive files that contain the app files, instructions for installation, and any metadata that you choose. They have their own metadata too, including the package description, package version, and any dependencies, like other packages that need to be installed beforehand. Once you have bundled your app into a package, you can use a package manager to distribute it. Package managers take care of the tasks of finding, installing, maintaining, or uninstalling software packages at the user's request. Package management systems coordinate with file archivers to extract package archives, verify checksums and digital certificates to ensure the integrity and authenticity of the package, locate, download, install, or update existing software from a software repository, and manage dependencies to ensure a package is installed with all packages it requires. Some commonly used package managers for each of the major platforms are listed here. On Linux, Debian Package Management System, or DPKG, Red Hat Package Manager, or RPM. On Windows, Chocolatey. On Android, Package Manager. On Mac OS, Homebrew and MacPorts. Any libraries or utility code that is developed as part of the application is managed with the Cloud Application Package Managers. Here are some examples of package managers for popular languages. For Node.js or JavaScript, NPM. For Java, Gradle and Maven. For Ruby, RubyGems. For Python, pip and conda. In this video, you've learned about some of the tools that you will utilize in your career as a developer, including CI/CD, build tools, packages, and package managers. Welcome to Introduction to Software Stacks. After watching this video, you will be able to describe software stack terminology, identify some commonly used software stacks, and list the benefits and challenges of different software stacks. A software stack is a combination of technologies that include software and programming languages. Developers use a software stack to create applications and solutions, such as web and mobile apps. The set of individual technologies is stacked in a hierarchy and work together to support the execution of an application. The higher levels in the stack provide tasks or services for the user, and the lower levels interact with the computer hardware. Software stacks typically include front-end technologies such as programming languages, frameworks, and user interface tools, and back-end technologies such as programming languages, frameworks, web servers, app servers, operating systems, messaging applications, and databases. You might hear the term technology stack used in place of software stack. However, a technology stack is a broader term that includes hardware and infrastructure, like virtual machines, containers, storage, and load balancers, as well as the software stack. The simplest implementation of a software stack consists of a presentation layer, a business logic layer, and a data layer. However, more complex applications use more complex stacks, which could include software for virtualization, scheduling and orchestration, runtime environments, database connectivity, networking, and security. The software and services that make up a stack can be from a variety of sources, from internal resources to third-party providers to cloud providers. There is no formal definition of the structure of a stack, the only rule being that the software and the services included must support an application's development, functionality, or deployment. When you're using a software stack, you don't have to use all of the available layers, you only need to use those which are relevant to your solution. There are many different examples of software stacks. The Python Django stack uses the popular Python programming language alongside the Django web framework. This combination is all open source and commonly used for large-scale, fast-changing web applications. The Ruby on Rails stack uses the Ruby programming language with a server-side web application framework. Ruby on Rails is great with JSON or XML for data transfer, and HTML, CSS, and JavaScript for front-end development. And the ASP.NET stack includes Microsoft technologies such as the ASP.NET MVC framework, the IIS web server, SQL Server, and Azure. You'll learn more about the LAMP, mean, MEVN, and MERN stacks next. The LAMP stack runs on the Linux operating system. It uses the Apache HTTP or web server, MySQL databases, and the PHP programming language. LAMP is an example of an early incarnation of a software stack designed for building websites and cloud applications. All its constituent parts are open source and loosely coupled, so it's easy to swap different options into the stack. For example, you could choose to use PostgreSQL instead of MySQL for your database server, changing the LAMP stack to be the LAPP stack. Similarly, you could use the Python programming language instead of PHP. The mean stack uses a MongoDB database with an Express.js web application server framework, the AngularJS framework for front-end JavaScript development, and the Node.js platform for server-side scripting. The mean software and services are platform agnostic, free, and open source. And there are other stacks related to the mean stack, including the MERN stack, which replaces AngularJS with React and is a flexible and high-performing framework for developing front ends, and the MEVN stack, which replaces AngularJS with Vue.js. Vue is a lighter-weight JavaScript framework with less capabilities, but it can provide better performance than AngularJS. Let's consider some advantages and disadvantages of three different software stacks: Mean, MEVN, and LAMP. Mean is a free and open-source JavaScript software stack used for building web applications. The biggest advantage of the mean stack is that all of the parts use JavaScript, so developers only need to know a single language. The stack is also open source, which means the cost is lucrative to businesses, and there is a lot of documentation and reusable code for developers to use. Development can happen quickly because Node.js has a huge collection of free, reusable module libraries. However, the mean stack may not be well suited for large-scale applications. When using Express.js, the business logic often resides on the server, preventing the reuse of some services, like batching operations. And MongoDB is great for unstructured data, but it doesn't provide the same level of functionality as a relational database. The MEVN stack is a web stack, like Mean, but it uses Vue.js instead of AngularJS for user interfaces. MEVN and Mean stacks have similar advantages, but Vue.js is a much newer technology and doesn't have as many reusable libraries as AngularJS. Like Mean and MEVN, the software and services in the LAMP stack are open source, meaning that there are lots of reusable chunks of code available to the developers. And because LAMP is one of the oldest software stacks, it's easy to find support and reusable solutions. However, because the Linux operating system is an integral part of the stack, it isn't as flexible as mean and MEVN, which are platform agnostic. MySQL is a relational database, so the stack cannot take advantage of unstructured data. The other disadvantage of the LAMP stack is that the back end runs on PHP, Perl, or Python, whereas the front end uses JavaScript and HTML, making it harder for developers to switch back and forth between the mean and MEVN stacks, which use JavaScript throughout. In this video, you learned that software stacks are a combination of technologies for creating applications and solutions. Software stacks can range from simple 3-layered systems to many layers. There are numerous types of software stacks for different developers and environments. The biggest advantage of the mean stack is that all of the parts use JavaScript, so developers only need to know a single language. And the LAMP stack on Linux works well for relational data. Welcome to Insider's Viewpoints, Tools and Technologies. In this video, we will hear from experts discussing their favorite tools and technologies for software engineering projects.
Our team uses Git and GitHub every single day for all of our projects. We use it for tracking code, we use it for collaboration, and we use it for tracking bugs, features, and tasks for all of our projects.
I believe most open source projects are now using Git. Every project I've contributed to, whether open source or closed, has used it. Git's true value is most apparent when you're working on a team with multiple people, at which point you'll be glad to have things like feature branches and pull requests. But even if you're working on a project where you're the sole committer, I recommend using Git, and in particular GitHub, for the community aspect.
So if you are a front-end developer, if you understand JavaScript, then picking up backend using a framework like Node.js is not that much of a stretch. I actually started building static websites, and then slowly learned how to put in dynamic content using JavaScript, and then I had to use Java or PHP to build my backend systems on the server.
For front-end development, you're primarily using HTML, CSS, and JavaScript. If you're very front-end focused, you might want to try out an IDE built for that specific purpose, such as brackets. If you want to keep things more general, I recommend VS Code. In either case, I recommend installing IDE extensions for automatic formatting and linting of your code using Prettier and ESLint. These will help you catch issues as early as possible. For backend development, the tools are quite a bit more varied, so it's hard to give specific recommendations, but if you choose Node.js, you'll be able to use some of the same tools that I mentioned for front-end development. Otherwise, I recommend just looking into what IDE extensions are available and what linters and auto-formatters are available.
JavaScript is a very powerful language. It lets you do pretty much anything you can imagine, including shooting yourself in the foot if you're not careful. The practices I typically follow with JavaScript include proper scoping of variables and functions, and writing unit and integration tests for my features.
React.js was developed at Facebook, very popular. Angular is a framework operated by Google that allows for development of single-page applications, SPAs. jQuery is possibly the most popular and oldest library out there, created by John Resig in 2006. And jQuery is frequently used with both Angular and React. Backbone is a lightweight JavaScript library that is very popular. In terms of backend languages and frameworks, Node.js is an open source server-side platform built on the Google Chrome JavaScript engine. It uses an asynchronous single-threaded architecture that allows it to serve a very large number of concurrent connections. Flask is a framework used on Python that is popular with Pythonistas. And the Spring framework based on Java has been around for years and remains popular.
We use React JavaScript framework. It is better than Angular in terms of speed and efficiency. React is easier to learn than other JavaScript frameworks, which makes its adoption in the team easy. It also resolves the problems related to cross-browser issues. Another great feature of React is the use of JSX. JSX is helpful when working with UI inside the JavaScript code. It helps React to show more useful error and warning messages.
My favorite front-end JavaScript framework would be React.js. I love the whole component-driven design and architecture that you have to follow when you create a React.js based application. I also like the idea of props and states to hold the state of your application.
By using Express.js for backend development, we are able to scale applications quickly. We can code both frontend and backend with the help of JavaScript easily by using Express.js. Express.js is supported with the Google V8 engine, with the help of which you would be able to get higher performance without any lag or error in processing. It also supports the caching features, so you would not have to re-execute the codes again and again. Moreover, it will help web pages to load faster than ever.
When working with Node.js, I'll give you two of my favorite packages that I use on a daily basis. So first is making requests to web services. I use a library like Axios that helps me create these requests with the right headers and also provide me with callback functions or promises to be able to handle the responses that come back. My second package would be when I'm working with databases. I'll use NPM packages more likely than not to talk to an external database, regardless of if it's a relational database or a NoSQL database.
So when writing JavaScript, I really like to take advantage of the features in ES6 because it can make my code look cleaner, easier to read, and just more beautiful, such as the arrow functions or the ... operator. And so I encourage you to, after learning JavaScript, dive into ES6 a bit and have fun with it.
Welcome to Interpreted and Compiled Programming Languages. After watching this video, you will be able to identify interpreted programming languages and identify compiled programming languages. What are programming languages? Programming languages help us tell computers what to do. Computers don't use human language, they use their own language called machine code. Machines understand binary code, that is, ones and zeros, so to make communicating with computers easier, we have human-readable programming languages. Two common categories for programming languages are interpreted and compiled. These are broad categories, and there are many programming languages that are classified under compiled languages and interpreted languages. The purpose of the project helps a developer determine which programming language is best. Interpreted language is also commonly referred to as scripted or scripting language. Programs written in interpreted or scripted language, like Python and HTML, run through the programming interpreter on your computer's operating system or in your web browser. Remember that programming languages are in human-readable code, so the interpreter takes the human-readable scripted code and then translates it into machine code, enabling the computer to complete the requested task. As computers and web pages have changed and advanced, some interpreted programming languages are outdated, and they are not as useful or relevant. Some other languages are more versatile and easier to learn, which means they are preferred over other scripting languages and are used more often. All interpreted programming languages need an interpreter to translate the source code. Translators are built into your web browser, or they require a program on your computer to translate the code. Several different interpreted programming languages exist. Some examples of common interpreted programming language types are JavaScript, a simpler scripting language that runs through the web browser interpreter; Python, a language that is popular because it is easy to learn and use for developers; Lua, a general-purpose, lightweight game scripting language that is easy to learn and use; and HTML, a markup language used for formatting web pages. Another category of programming languages is the compiled programming languages. Compiled programs are applications and programs, like your music app or your operating system, that you run on your computer or device. The programs are packaged or compiled into one executable file. They are usually larger programs. Compiled programs are used to help solve more challenging problems like interpreting source code. Compiled programming languages are often referred to more simply as programming languages. A compiler program creates a program file, which runs the software. Simply put, it piles the code into one file that runs when you double-click on the app on your device. The program runs faster, and it can be done repeatedly. The source code is converted from the programming language to machine code. Then it is compiled into one executable file. Finally, the program runs when you select the icon or file on your device. Some examples of compiled programming languages are C and its variations, C++ and C#, which are used in many operating systems like Microsoft Windows, Apple's Mac OS, and the open source operating system, Linux. Java is another compiled programming language. It shouldn't be confused with the interpreted language JavaScript. The Android OS is written in Java because it works well across computing platforms. Let's look at this process. When you update to a new version of your operating system, like Microsoft Windows, your device might download an installation program. That program is made up of many files. The files are written in a compiled programming language. These files give instructions to your device in machine code. The compiled program is running on your device. A compiled program that you commonly use is your device's operating system, such as Linux, Microsoft Windows, Apple's Mac OS, or Android. Your operating system is written in a compiled programming language, like C, C++, C#, or Java. In this video, you learned that interpreted programming languages run scripts that are repetitive and need to be run often. Interpreted programming languages are more versatile and can be used across platforms as long as there is the correct interpreter. Some examples of interpreted programming languages are JavaScript, Python, and HTML. Compiled programming languages are for more complex programs that complete larger tasks. Compiled programming languages are used for creating executable files that can run directly from your device. And some examples of compiled programming languages are C and Java. Welcome to Comparing Compiled and Interpreted Programming Languages. After watching this video, you will be able to compare interpreted and compiled programming languages and discuss interpreted and compiled programming languages. How do developers choose a programming language? Developers choose which programming language is best to use depending on what they have the most experience with and what they trust, what is best for their users, and what is the most efficient to use. What are interpreted and compiled programming languages? Interpreted programming languages are used to create a scripted source code for smaller tasks. The source code goes through an interpreter. The interpreter is built into the operating system on a computer or on a web browser. Compiled programming languages are used to create files. The files are executable files. They are then grouped in programs that you can run on a computer or device. Interpreted programming languages are also called script code or scripting because they are used to automate tasks. Interpreter programs read and execute the source code line by line like someone would read a script. Each time the program runs, the source code needs to be executed to receive the desired output. And source code written in one of the interpreted programming languages runs on almost any operating system with the right interpreter. For example, imagine you have a client requesting information about web page views for last month. Which type of programming language would be the most appropriate and efficient to create a program for this task? You would use one of the interpreted programming languages to write code for a script. The script would retrieve the web page views data and then put it into a table for the client to read. Compiled programming languages are also called programming languages for short. They are used for more complex programs that complete larger tasks like running a spreadsheet program on your computer. A compiled programming language is used to write a larger program, usually installed on your device as an executable file. Writing code in a compiled language does take longer, but the payoff is that the program's code runs faster because compiled programs are installed on the device. And once the program is coded, the compiled program is grouped into one downloadable file. Remember that client who wanted information about web page views? Now they want a spreadsheet program to view and manage the data. A programmer could use the C programming language to create a compiled program like Microsoft Excel. So, what are the major differences between interpreted programming languages and compiled programming languages? First, there's interpreted programming. These programs are available across multiple platforms or in the cloud. The scripting languages are easier to learn and use, and they're better for websites because they tackle smaller, repeated processes. Then there's compiled programming. These programs are available to users with the same operating system coded in the same language. However, compiled programming languages are more difficult to learn and use because they are larger programs with more parts. And they're better for larger tasks like running the operating system on your computer. To better understand more of the similarities and differences of programming languages, let's take a look at some examples. A few of the most common programming languages are C, C++, and C#. C is a compiled programming language. C is the original language, and C++ and C# are variations. C and its variations are case-sensitive languages. The C programming language is the basis for Windows and other common operating systems, and it takes more time to learn and use for coding, but requires less memory and the code runs faster. Another common programming language is Java. It is a compiled programming language. It is also a case-sensitive, object-oriented programming language. The Java Virtual Machine, or JVM, is required to run the code written in Java. It is the primary programming language for some operating systems, like the Android OS. And a benefit of Java is that it is a cross-platform language, which means it runs the same code on Mac OS, Windows, and Linux. Python is an example of an interpreted programming language. It is also referred to as a scripting language. Python is a popular general-use case-sensitive programming language. It is used with Windows, Mac OS, and Linux operating systems, and with server-side web app code. And it requires the Python engine to interpret code. JavaScript is another interpreted programming language. It is a scripting language that runs on the client side in web browsers. JavaScript is case-sensitive. Simple scripts are run with HTML. Complex scripts are run in separate files. And while it sounds similar, it shouldn't be confused with Java, the compiled programming language. Another example of a common programming language is HTML. It is an interpreted programming language. HTML stands for Hypertext Markup Language. HTML is mostly case-insensitive with some exceptions, and it uses tags to format web pages on client-side web browsers. In this video, you learned that Interpreted programming languages create source code that runs through an interpreter in your device's operating system or on your web browser. Compiled programming languages create executable files that are grouped in programs on your device. Compiled programming languages, like C and Java, are used to write larger programs like operating systems and other executable files. And interpreted programming languages, like Python and HTML, are used to write code that can complete repetitive tasks within a web browser or a computer. Welcome to Query and Assembly Programming Languages. After watching this video, you will be able to compare high-level and low-level programming languages, describe query languages, and describe assembly languages. Let's explore query and assembly programming languages. But first, we need to categorize programming languages into two levels, high-level and low-level. A high-level programming language is more sophisticated and uses the common English language to make its code more understandable and to increase the speed of coding and debugging programs. Examples of high-level programming languages include query languages, such as Structured Query Language or SQL, structured programming languages, such as Pascal, and object-oriented programming languages, such as Python. In contrast, a low-level programming language uses a set of symbols to represent machine code. Examples of low-level programming languages include assembly languages such as ARM, MIPS, and x86. A query is a request for information from a database. The database handles the query and searches its tables for the information requested and returns the results to the querying entity. When querying a database, it is important that both the user application making the query and the database handling the query are speaking the same language. In programming terms, writing a query means using predefined and understandable instructions to make the request to a database. This is achieved using programmatic code, and this is what we refer to as a query language. A query language may also be referred to as a database query language. By far the most prevalent query language for database queries and database management is SQL. However, there are other query languages available, such as AQL, CQL, Datalog, and DMX. In addition to SQL databases, there is another type of database called NoSQL, which stands for Not Only SQL. The key difference between these two types of databases is their data structures. While SQL databases are relational and use structured, predefined schemas, NoSQL databases are non-relational in nature and have dynamic schemas for unstructured data. A query language is predominantly used to request data from a database or to create, read, update, and delete data in a database. You will likely see the term CRUD used to refer to these last four key database operations. Typically, a user enters a command to either make a query or perform a CRUD operation using syntax that is understandable to the database management system hosting the database. And a database typically consists of structured tables made up of multiple rows and columns of data. When a user performs a query, the database retrieves the data from the relevant rows and columns in the table and arranges it into some sort of order ready to be returned and presented in the query results. Database queries are either a select command or an action command such as create, insert, update, or a mixture of both. The term statement is more commonly used to describe these commands. Select queries request data from a database, whereas action queries manipulate data in a database. Query statements can also be used to perform other administrative functions, such as creating users and modifying permissions. This table lists some of the most common SQL query statements. And here are some simple syntax examples of common SQL statements. As mentioned earlier, assembly languages are less sophisticated than query languages, structured programming languages, and object-oriented programming languages. As an assembly language uses a simple set of symbols to represent the zeros and ones of machine code, it is categorized as a low-level programming language. Assembly languages are closely tied to the processor architecture from hardware manufacturers, and therefore each CPU type will typically have its own assembly language. For this reason, there are a large number of assembly languages in use today, which vary among hardware manufacturers. Assembly languages use a simple, readable format for their statements, and they are entered one line at a time with one statement per line. Assembly language statements use the standard format shown here. In this syntax, all fields in curly brackets are optional, and the statement has two main parts. The first part is the instruction, or the mnemonic, and the second part includes the parameters, or the operands. There may also be optional useful comments added on the end of the statement. One other key difference with assembly languages is that they are translated using an assembler instead of a compiler or interpreter, and one statement translates into just one machine code instruction, as opposed to high-level languages where one statement can be translated into multiple machine code instructions. Assemblers translate assembly language into machine code using mnemonics such as input INP, output OUT, load LDA, store STA, and add ADD. The statements consist of opcodes that tell the processor what to do with the data and operands that tell the processor where to find the data. In this video, you learned that query languages, structured programming languages, and object-oriented programming languages are categorized as high-level programming languages. Assembly languages are categorized as low-level programming languages. A query language is predominantly used to request data from a database or to manipulate data in a database. The most prevalent query language for database queries and database management is structured query language, or SQL. Select queries request data from a database, whereas action queries manipulate data in a database. You also learned that assembly languages use a simple set of symbols to represent the zeros and ones of machine code. Assembly languages are closely tied to the processor architecture from hardware manufacturers. Assembly languages are translated using an assembler instead of a compiler or interpreter. And assembly language instructions have a one-to-one association with their machine code counterpart. Welcome to Understanding Code Organization Methods. After watching this video, you will be able to explain why code organization methods are important when programming, define the different code organization methods, and identify the benefits of using code organization methods. Organizing is very important when it comes to reading, maintaining, and configuring code. Well-planned out software design, usually using one of several methods, helps programmers write cleaner and more reliable code. Planning out code in a visual format helps improve the code base once it is written and reduces the chance of bugs and errors throughout the lifespan of a project. Organizing code before programming has a positive impact on the quality of the program and helps provide a consistent and logical format to use while coding. There are two main methods of organizing code: flowcharts and pseudocode. The main difference between pseudocode and a flowchart is that the former is a basic high-level description of an algorithm. An algorithm is a step-by-step sequence of solving a given problem. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various shapes and colors connected by arrows that indicate their order. Flowcharts are used in designing or documenting a process or program. Pseudocode provides a beneficial bridge to the project code because it closely follows the logic that the code will. Pseudocode also helps programmers share ideas without spending too much time creating code, and it provides a structure that is not dependent on any one programming language. Flowcharts are especially beneficial for smaller concepts and problems, while pseudocode is more efficient for larger programming projects. And flowcharts provide an easy method of communication about the logic and offer a good starting point for the project because they are easier to create than pseudocode in the beginning stages. A flowchart is the graphical or pictorial representation of an algorithm using different symbols, shapes, and arrows in different sizes and colors to demonstrate a process or a program. The main purpose of using a flowchart is to analyze different methods of solving a problem or completing a process. Several standard symbols are applied in a flowchart, and you can easily highlight certain elements and the relationships between each part in the process. Some traditional flowchart shapes used for programming concepts are start-end, a capsule, process, a rectangle, decision, a diamond, data, a parallelogram, and connectors as arrows. A simple flowchart to represent how to add two numbers is easy to create. The procedure starts with the capsule and has a connector or arrow progressing to the next step, the data input, the parallelogram, in this case, input N1 and input N2. Then another connector or arrow goes to the process, the rectangle of adding the two inputs, sum equals N1 plus N2. Another connector or arrow moves to the data, the parallelogram, showing the result, in this case, print sum. And the last connector or arrow moves to the end of the process, the end capsule. Flowchart software is an application that provides various functionalities to create flowcharts by providing the ability to drag shapes into the desired order using an easy-to-use editor. Flowchart software also provides team collaboration for creating flowcharts. Some of the well-known flowchart software programs include Microsoft Visio, Lucidchart, Draw.io, and Draw Anywhere. Pseudocode is an informal type of programming description that does not require any strict programming language syntax or underlying technology considerations. System designers write pseudocode to ensure that programmers understand a software project's requirements and align code accordingly. Pseudocode is used for creating an outline or a rough draft of a program that summarizes a program's flow but excludes underlying details. Pseudocode acts as the bridge between the programmer's brain and the computer's code executor that provides the ability to plan instructions that follow a logical pattern without including all the technical details. Pseudocode is a great way of getting started with software programming as a beginner without worrying about coding syntax. Pseudocode helps both programmers and non-programmers agree about the program's goal and the basics of how the task should be done. Here's one example of pseudocode written to check if the user entered an odd or even number. The next example displays the pseudocode written in C++. There are many advantages of using pseudocode over flowcharts. The main benefit of pseudocode is that it's simple and explains exactly what each line of an application should do. The coder can focus more on logic than on program language syntax. Removing the distractions of coding when using pseudocode makes the code development stage easier. Words and phrases in pseudocode represent lines of basic computer operations that simplify translation from the pseudocode algorithm to the specific programming language. Pseudocode allows programmers working in different computer languages to interact with each other. Pseudocode can be reviewed by different development groups, easier than real code. Pseudocode is easier for non-programmers to read and enables quick and easy translation to any computer language. Writing pseudocode is more concise and easier to modify, so changes to the design can be easily incorporated. And lastly, unlike some flowcharts, pseudocode is usually less than 1 page. In this video, you learned that organizing and planning out software design enables programmers to write cleaner and more reliable code. And organized code is very important from a readability, maintainability, and scalability standpoint. Two main methods of organizing and planning software code are by developing flowcharts or writing pseudocode. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various kinds, connected by arrows that indicate their order. And the main goal of pseudocode is to explain exactly what each line of a program should do, making the code construction phase easier for the programmer. Welcome to Insider's Viewpoints, Types of Languages. In this video, we will hear from experts discussing if they prefer developing in compiled or interpreted programming languages.
Most of the time, it doesn't really matter. It just comes down to personal preference, like what are you going to get moving on the fastest? There are certain situations where it will make a difference if you're compiling ahead of time versus interpreting on the fly. If you're trying to eke out like very small incremental performance benefit.
I prefer compiled code or a language that's compiled language, just because I have more of a guarantee that it will, well, maybe not necessarily work, but will do what I thought it will do, and at least will deploy properly when being rolled out.
But usually, no, it doesn't make that much of a difference to either the development process or the deployment and use process. They definitely have advantages and disadvantages to each of them, but most of the time doesn't make that much of a difference to what I'm doing. I
think interpreted languages can, there's a lot of flexibility there, and often you can do more creative things, and the compiler, it sort of stops, the buck stops with the compiler, and you can't really avoid compiler errors with the compiled language. With interpretive, there's more interesting runtime possibilities there. So I think it really depends on what environment you're developing for, or what your risk factor is when it comes to being okay with potentially buggy code being out in the wild.
What do you think are the benefits of object-oriented programming over procedural programming?
Anything can be an object, and object-oriented design puts hierarchies and patterns onto those things, and that structure can make it easy to keep designs in mind and keep in mind how the different objects interact with each other. It's also very easy in object-oriented programming to paint yourself into a wall where you have put too much structure around everything, and you now have this explosion of useless boilerplate code. So there's a bit of a, not catch-22, but just a balance that you need to find in between how much structure should your thing have, how much flexibility should it have, and how much should your intentions be imposed on that design and the way that people interact.
I think procedural programming can be, feels more mathematical and more sort of pure engineering in some sense, and I think that that also can lend itself well to someone who is really looking to not just build software, but really wants to sort of feel like they're engineering the code in some sense. It can feel like you're kind of in the machine, if you will. So I know maybe that's a weird answer, but I think it then, depending on how your brain works too, one can lend itself more easily than the other. So, but I think it's worth trying them both out.
If you get super object oriented, you can get a little too prescriptive with the designs, I think. So that's just, whenever you're using objects, it's just a thing to keep in mind, that you can go too far with it. But where that line of too far is kind of depends on exactly what it is that you're building. Sometimes the sky's the limit, just regulate everything. And sometimes the amount of flexibility that you require actually does mean that you can't really have an object of any sort. Both of those situations should be pretty weird. Those would be on the extremes. But most of the time, a few simple objects will do a lot of good, no matter what the rest of your system looks like.
Yeah, I think object-oriented programming to me is for me personally, I think it does lend itself well to like real-world mappings and data models, and the sort of classic examples of you might in your first object-oriented software like demo build something like a library that has books and it has a checkout. So like there's physical objects, and the way you learn it is very much sort of, you think about the software as something real world. So that helps you make the jump from building something physical with your hands to building something with bits and bytes.
Welcome to Branching and Looping Programming Logic. After watching this video, you will be able to describe the two types of programming logic, define Boolean expressions and variables, and list the differences between branching and looping. There are two major types of programming logic, branching and looping. Both types use Boolean expressions and variables. A Boolean expression is a type of programming statement with only two values, either true or false, and variables have assigned values that are passed into a function or subroutine within a more extensive program. Computers use Boolean logic to make decisions. The computer takes one action if a Boolean expression is true and a different action if the expression is false. Typically, a program consists of instructions that tell the computer what to do and data that the program uses when it is running. A variable has a value that can change depending on conditions or information passed to the program. Boolean logic, along with variables, form the basis of programming. Branching logic is where a computer makes a decision following a different set of instructions depending on whether certain conditions are met during the program's execution. Each possible code pathway creates another branch. The branch of code that runs depends on the values assigned to the parameters of the branching procedure, and there is no limit to the number of branches to implement complex logic. The values of these parameters may be input by the user or generated by the output from a previous procedure. Branching contains constructs that occur and are processed to determine the path a program takes when running. Branching statements, also known as constructs, allow the execution flow to jump to a different part of the program. The common branching statements used within other control structures include if then else, switch, and goto. The if statement is a decision-making construct that guides a program to make decisions based on specified criteria. The if statement executes one code set when a specific condition is met, true, or another code set if the condition is not met, false. The if-then-else is a conditional construct that executes its substatement, which follows the then keyword. This only occurs if the provided condition is true. The if-else statement extends the if statement by specifying an action if the if, or true-false expression, is false. With the if-else statement, the program will execute either the true code block or the false code block, so something is always performed with an if-else statement. In computer programming languages, a switch statement is a type of selection control mechanism used to allow the value of a variable or expression to change the control flow of program execution via search and map. Goto is a statement found in many computer programming languages that performs a one-way transfer of control to another line of code. In contrast, a function call typically returns control. Now, let's look at the logic of looping programming. A loop is a sequence of instructions that continually repeats until reaching a specific condition. Typically, a particular process is performed, such as retrieving and changing data, and then some conditions are checked, such as whether a counter has reached a prescribed number. If it has not, the next instruction in the sequence is to return to the first instruction in the series and repeat the sequence. If the condition is reached, the next instruction falls through to the next sequential instruction or branches outside the loop. A loop is a fundamental programming idea commonly used in writing programs. There are 3 basic loop statements: while, for, and do while. In a while loop, a condition is evaluated before processing the body of the loop. If a condition is true, then and only then the body of the loop is executed. In a for loop, the initial value is performed only once. Then the condition tests and compares the counter to a fixed value after each iteration, stopping the for loop when false is returned. And in a do-while loop, the condition is always executed after the body of a loop. It is also called an exit-controlled loop. In this video, you learned that there are 2 major types of programming logic, branching and looping. Both types of logic use Boolean expressions and variables. Boolean expressions have only 2 possible values, either true or false, and variables have assigned values that are passed onto a function or subroutine within a more extensive program. Variables have values that can change depending on conditions or information passed to the program. And branching is deciding what actions to take, while looping is deciding how many times to perform a certain action. Welcome to Introduction to Programming Concepts, Part 1. After watching this video, you will be able to describe the purpose and use of identifiers in programming, and describe the purpose and use of containers in programming. To fully understand software programming, there are some fundamental programming concepts you need to know first. The first concepts you will look at are identifiers. Software developers use an identifier to reference a program component, such as a stored value, a method, an interface, or a class, by assigning a custom named label to it. If the identifier stores data, then the data values in the program can be one of 2 types, either a constant or a variable. A constant is a data item whose value does not change within a program. This could be a numerical constant, such as the mathematical value of pi, or it could be a text string that remains constant, such as a player's name within a game. Constants are also referred to as named constants. You assign a value to a constant when you define it. For example, you might want it to refer to a numerical value within your program, such as pi, or a cost price, or a rate of tax, and then, rather than repeatedly retyping the same numerical value, you can just declare a constant for the value instead and name it something meaningful like pi_value, or cost_price, or tax_rate. There are a couple of major benefits to using constants in your programs. One is for ease of readability in your code, and the other is that if the specified value changes in the future, you only need to change it once on the constant, rather than finding every instance of that numerical value within your code and changing it. The other type of identifier used in programming is a variable. As the name suggests, this kind of identifier is not constant. Its value can change during the program's execution, such as a user entering their age in an application or a high score in a game. Variables can be strings of text, numerical values, or any other type of data. Using a variable as an identifier is a useful way to refer to program items that are unknown to you, such as a username, a service, or a file name, for instance. If you don't use a variable, then you will need to hard code all the names and values in your program, which is not considered best practice. Variables can be declared and assigned a data type and initial value as they are defined, or you can decide not to assign an initial value when you define a variable and instead have the value assigned later by instructions within the program. In addition to the identifier data structures already discussed, there are also special kinds of identifiers that can reference multiple elements in a program, and these are referred to as containers. Being able to specify multiple elements means that you don't have to create a variable for every individual element. This makes it faster and more efficient. For example, If you only want to store 6 numerical integers, then you could argue that you could just create 6 variables, one for each. But what if you need to store 1,000 integers or more? In such a case, defining 1,000 variables would obviously be an unwieldy and inefficient programming technique. So in this case, you would use a container. There are 2 types of containers to specify multiple elements: arrays and vectors. The simplest of these container types is an array. In an array, a fixed number of elements of the same type are stored in sequential order starting from index 0. When you declare an array, you specify the data type of the values it contains, such as an integer, or Boolean, or a string, and then the maximum number of elements it can contain. The syntax for declaring an array is to specify the data type first, then the name of the array, then the maximum size of the array in square braces. In contrast to arrays that have a fixed size, vectors have a dynamic size, and they will automatically resize themselves as you add elements to them or remove elements from them. For this reason, you may also see them referred to as dynamic arrays. Because they are dynamic in nature, vectors take up more memory space than arrays, and their elements also take a little longer to access than elements in an array, as they are not stored in sequential memory locations. The syntax for declaring a vector is to specify the container type of the vector first, then specify the data type in angle brackets, then the name of the array. Note that because it is a vector, you do not need to specify a maximum number of values it can contain because the size is not fixed, it is dynamic. In this video, you learned that software developers use an identifier to reference a program component. If an identifier stores data, then it can either be a constant or a variable. A constant is a data item whose value does not change within the program. A variable is not constant, it can change during the program's execution. In an array, a fixed number of elements of the same type are stored in sequential order, starting from 0. And vectors have a dynamic size, and they automatically resize themselves as elements are added or removed. Welcome to Introduction to Programming Concepts, Part 2. After watching this video, you will be able to describe the purpose and use of functions in programming, and describe the purpose and use of objects in programming. Next, let's look at the fundamental concept of functions. Functions are a consequence of the modular programming software development methodology that encourages the separation of a program into multiple modular components, where each performs a specific task within a program. So, a function is essentially a piece of structured, standalone, and reusable code that will perform a single specific action. This enables software developers to take a substantial, complex program and divide it into smaller, more manageable, and focused pieces. Although some programming languages may refer to them as something else, such as subroutines, procedures, methods, or modules, most modern programming languages refer to them as functions. Functions take in data as an input, then process the data, and then return the result as an output. There are essentially 2 types of functions. Standard library functions are the built-in functions provided by the programming language. Common examples include the if, else, while, and print functions. But programming languages also allow you to write your own functions. And once you've written a function, you can use it over and over again. The way that the blocks of code that make up a function are identified is different across programming languages. Some use braces, some use begin and end statements, and others use indentations, for example. There are a few steps to using functions. The first thing you need to do is define or create a function. When you define a function, you provide a function keyword, then give the function a unique name, and you provide the statements that make up the body of the function. Once a function has been defined, it then needs to be called or invoked. When you call a function, the specified actions within the function are performed using any specified parameters. While defining and calling functions are common to all programming languages, some programming languages, such as C and C++, also require you to declare a function. Next, let's look at the concept of objects. Understanding what objects are is key to understanding object-oriented programming. Object-oriented programming, or OOP, is a programming methodology that is focused on objects rather than functions, which is what procedure-oriented programming is focused on. The objects themselves will contain data in the form of properties or attributes, and code in the form of procedures or methods. The key distinction between the two methodologies is that where procedural programming uses methods to operate on separate data structures, OOP packages them both together so an object operates on its own data structure. Consider the real-world objects in your life, such as your car, bike, TV, or your washing machine, and ask yourself the following two questions. What states can the object be in, and what behaviors can the object perform? When you think about your answers to these questions, you will find that the answers to these questions vary across the objects. More complex objects will typically have more potential states they can be in and will be able to perform more behaviors. In programming, a software object is similar to a real-world object, conceptually speaking, in that they too consist of states or properties and behaviors or methods. Software objects can be anything, such as a Windows service, a user account, a database table, or a system folder. Objects store their properties in fields, referred to as variables in some programming languages, and expose their behaviors through methods, referred to as functions in some programming languages. In this video, you learned that a function is a piece of structured, standalone, and reusable code that will perform a single specific action. The defining and calling of functions is common to all programming languages. Object-oriented programming is a programming methodology that is focused on objects rather than functions. And software objects consist of properties and methods. Welcome to Introduction to Software Architecture. After watching this video, you will be able to describe what software architecture is, explain the importance of well-designed software architecture, explain how software architecture impacts design decisions, such as tech stacks and production environments, and list several artifacts from software architecture design. Software design and documentation take place during the design phase of the SDLC. Software architecture, simply put, is the organization of the system. Software architecture serves as a blueprint for the software system that the programmers use to develop the interacting components of the software. The architecture comprises the fundamental structures of a software system and explains the behavior of that system. The architecture defines how components should interact with each other, the operating environment, and the principles used to design the software. The software architecture captures early design decisions that are often costly to change once implemented, and a software's architecture addresses non-functional aspects of the application, such as performance, scalability, maintainability, interoperability, security, and manageability. Well-designed software architecture is important for a number of reasons. First, it balances the differing needs of the stakeholders and serves as a basis for communication among team members. Next, the architecture represents the earliest design decisions, and those decisions conflate other coding implementation decisions later in the development process. Also, the well-designed architecture allows for agility due to changing requirements. A well-organized architecture increases the lifespan of a software system, even when implementation details change. Architectural design also guides the choice of technology stacks used for the system. Remember that architecture addresses non-functional capabilities, so choosing stacks that address these requirements is paramount in the design phase. Recall that a tech stack is a list of all the technologies, including software, programming languages, libraries, and frameworks that will be used to create the system. The architects must be aware of the stack's advantages and disadvantages to anticipate development needs. Much like blueprints communicate design decisions to the builders of a house, there are also several artifacts produced during the architectural design phase that are used to communicate the software design to the stakeholders. These artifacts include a software design document, or SDD, an architectural diagram, and unified modeling language, or UML diagrams. The SDD is a collection of technical specifications that indicate how the design should be implemented. It provides a functional description of the software and design considerations, such as assumptions, dependencies, constraints, requirements, objectives, and methodologies. The architectural diagram displays components, their interactions, their constraints, and their confines. It displays the architectural patterns used in the design. Architectural patterns are general, reusable solutions to commonly occurring problems and will be discussed in more detail in an upcoming video. UML diagrams are diagrams that communicate structure and behavior using common programming language agnostic notation. UML diagrams will also be discussed in more detail in another video. But another topic to be discussed in this module as it relates to software architecture includes production deployment considerations. The architecture drives choices about the environment in which the software is released. The production environment is comprised of the infrastructure that runs and delivers the application to the end user, such as the servers, load balancers, and databases. In this video, you learned that software architecture functions as a blueprint and represents the underlying organization of the application. A good architectural design is important because it serves as a basis for communication among team members. Software architecture represents the earliest design decisions, is hard to change once development starts, and accommodates changing requirements during development. Architectural design influences technology stack choices and the production environment. And artifacts resulting from the design include the SDD, the architecture diagram, and UML diagrams. Welcome to Software Design and Modeling. After watching this video, you will be able to compare and contrast the terms structure design and behavioral models, describe unified modeling language or UML and its advantages when designing software, and discuss the purpose of an interaction and a state transition diagram. Software design is a process during which structural components and behavioral attributes of the software are documented before it can be developed. One of the key activities of the design process is modeling the software to express its design. This involves creating visual or diagrammatic representations of the bigger software solution and its subcomponents, as well as the interactions between them. This can be done using simple flowcharts or more standardized methods like UML. A software system can be construed in terms of structural elements. Structured design conceptualizes a software problem into well-organized, smaller solution elements called modules and submodules. Structured design stresses organization in order to achieve a solution. A well-structured design should contain modules that are cohesive and loosely coupled. Cohesion means that all functionality-related elements are grouped together, and coupling is the communication between different modules. For a system to be loosely coupled, the modules should be weakly associated so changes in one component have minimal effect on another. And loose coupling is an architectural principle often used in service-oriented architectures and microservices-based architectural patterns, which will be discussed later in the module. This diagram shows a simplified example billing system. Modules are arranged in a hierarchy and communicate with each other. The rectangles represent the modules and submodules, and you can see that billing is the main module and the other rectangles are submodules to the main billing module. In this example, the submodules are insurance verification, submit claim, and output total. The arrows represent the flow of the data in the system. Behavioral models describe what a system does without explaining how it does it. The overall behavior of a system can be communicated through behavior models. There are a number of different UML diagrams that can be used to communicate the behavior of a system. We will discuss two such diagrams, a state transition diagram and an interaction diagram. When developing a complex software system with interconnected modules, it can be difficult to remember the relationships, behaviors, and hierarchies among different elements. UML, which stands for Unified Modeling Language, is a way to visually represent the architecture, design, and implementation of complex software systems. UML is a standardized modeling language that can be used throughout development processes. UML diagrams can be divided into two classes, either structural or behavioral. UML is programming language agnostic, so software developers can readily interpret and apply it to their work, no matter which language they are developing in. There are several advantages of using UML to communicate architecture, behavior, and structure with development teams. The biggest advantage of UML diagrams is that they allow you to plan out features before any coding takes place, which saves time and money. Secondly, the diagrams can be used to bring new team members or developers switching teams to get up to speed quickly. Also, the diagrams can be used to facilitate communication between technical and non-technical audiences more easily. And finally, having a visual representation of the system allows developers to navigate the source code because they can see the relationships among modules. So, there are many types of UML diagrams, but generally, UML diagrams can be classified as either behavioral or structural. We will discuss behavioral models next, and then object-oriented design. The behavior of a system can be explained and represented with the help of a UML diagram called a state transition diagram. The state transition diagram is a collection of states and events that describes the different states that a system has and the events which cause a change of state in the system. The diagram shown is an example of a state transition diagram that models a patient going to see a doctor at a clinic. The different states include waiting, testing, and with the doctor. The arrows represent possible transitions from one state to another and names the event that triggers the transition. An interaction diagram is used to model the dynamic nature of a software system. They help visualize objects and their relationships. A sequence diagram, which is the type of interaction diagram shown here, displays the communication between objects with respect to time. This example shows a patient making an appointment in an online portal, and this is another example of a behavioral UML diagram. In this video, you learned that structured design breaks down a software problem into well-organized, smaller solution elements. Behavioral models describe the behavior of the system without explaining how the system implements the behavior. Developing UML diagrams saves time and money by helping developers quickly get up to speed on a project, plan features in advance of coding, and help developers navigate resource code easily. A state transition diagram is a behavioral model containing a collection of states and events that describe the different states of a system and the events which cause a change of state. And finally, an interaction diagram describes how interacting objects communicate. Welcome to Object-Oriented Analysis and Design. After watching this video, you will be able to explain what objects and classes are, describe the purpose of a class diagram, and explain object-oriented design in relation to software architecture. Object-oriented analysis and design, or OOAD for short, is an approach for analyzing and designing a software system when the system will use object-oriented programming languages to develop it. So, before we discuss OOAD, let's learn a little more about object-oriented programming in languages like Java, C++, or Python. At the heart of OOAD are objects. Objects contain data, and they also have behaviors that prescribe the actions the object can take. I could create an object, for example, that represents a patient. And let's say that patient's name is Naya Patel, and Naya needs to cancel an appointment she made. Before creating Naya, however, we must first create a generic version of a patient object. The generic version of an object is called a class. Let's discuss classes next before we discuss more about Naya. Specific objects, also called instances, are created from classes, which are blueprints or templates for an object. So, from our previous example, considering Naya Patel, Naya would be an instance of the patient class. The class contains the object's generic attributes, the properties and methods, but it is only when the object is created, which is called instantiation, inside the code, that these generic attributes are set to particular values. So, the patient class might have a variable called last name, which is a property, but does not specify what that last name is. Last name is just a placeholder until the object is created and assigned a name. And once the object has been instantiated, its methods can be called to make the object perform some action, such as making or canceling an appointment. OOAD is used for a system that can be broken down into objects that interact with each other. In this way, multiple developers can work on different aspects of the application at the same time. As noted earlier, visual UML diagrams can be created that show both the static structure and dynamic behavior of a system. We've seen a couple of examples of behavioral UML diagrams already, so now let's look at a structural UML diagram called a class diagram next, now that we know what classes are. This is an example of a class diagram. Class diagrams are commonly used to communicate a software system structure in OOAD. The class diagram shows how the classes in an object-oriented design relate to one another. Each box represents a class and shows its attributes. Recall that an object's attributes are both its properties or its data and its available actions, called methods. A class diagram also shows the relationships between classes. A subclass is said to inherit its parent class attributes, meaning it has the same properties and methods as the parent class, but also may add additional properties and methods. In this diagram, the nurse, doctor, and technician classes are subclasses of medical personnel, and the specialist class is a subclass of the doctor class. This means that doctors can do anything medical personnel can do, and specialists can do anything a doctor can do. In this video, you learned that object-oriented analysis and design is the process of planning a software system based on the behaviors of interacting objects. Objects contain data, and they also have behaviors that prescribe the actions the object can take. Classes are blueprints for objects, and a class diagram is a structural UML diagram that shows the relationship between objects. Welcome to Insider's Viewpoints, the importance of design and software architecture. In this video, we will hear from experts discussing the importance of design and software architecture in a software engineering project.
Design and architecture are crucial. If you don't know where you're going, how do you know what you need to do now? You always need to know what your program needs to be prepared to handle and the system that it's operating within. If you are running a series, if you're running a bunch of applications that are all co-hosted on the same server, you can make certain assumptions about the ways those services can interact with each other that do not hold.
I also sometimes think of architecture and orchestration. So you can have like a beautiful, really nice sounding instrument, but if it's not in sync with the rest of the orchestra, it's going to sound like a complete cacophonous mess in the end. So you really need to think about the bigger picture, sustainability, whether what you're building actually makes sense in the larger sort of ecosystems.
And every time, if you spend the time to write your code and then you figure out why it doesn't work, you've wasted a lot of time writing that code. Maybe you've learned some things, not a total waste, but you've spent a lot of time that could have been spent moving forward. And so if you can think about those things ahead of time on a project, and then when you write your code, you're reasonably sure that the code you write is actually going to persist and get used, that's generally speaking a better place to be in. So architecture is very important.
It's like there's a lot of talk about its scale, global availability. Often something you build would work very well in a very hyper-local environment, but not work well when it's expected to be used across the globe, or works well for one user but doesn't work well for a million users.
I'm building the service. I need X, Y, Z pieces of data to come into the function that I want to write. Where are those things coming from? How are they getting passed in? Once I have them, what do I need to do with them? What else needs to access this data? And how am I going to get the data to those other parts also? And if you don't have those questions answered, you end up writing a lot of churny code. If everything is on a separate server somewhere in the cloud, or separate physical servers that are just located somewhere different inside your data center, then you have to incur a network hop to go over them. And that takes time. Your page might start timing out, and your customers might get really upset at you for how long things take. And so if you're building something in like a microservice architecture, the way that you load your data becomes much more important than if everything is hosted together on the same server. But maybe the question of who is using my service? How do I know who you are? That can become an interesting question depending on where your services are running, and what mechanisms are available to you to identify people. If you want your customers to log into a website, how are you doing account management? How do you know who that person is and what they're allowed to do? Or if you have multiple services talking to each other, again, how do you know what that service is, what it's allowed to do? How do you make the call between one and the other? How do you transmit data between different parts of your stack? So architecture is very important. It doesn't always have to be super well-defined, super strictly defined, but you need to have some idea of what things do you need, roughly where they're going to live, and what are they responsible for? Those would probably be the three big questions to ask. What, where, and scope of them. So
these sorts of concepts, you have to think about those things when you're designing or architecting a system. You're thinking like 5-10 years ahead too when you're thinking about architecture and design. You're not thinking about just building something quickly and getting it up. You actually want to plan ahead. So I think a lot of architecture and design is thinking about, how many steps, how many years, whatever in the future, what is it going to look like then? What do you need to do to keep growing the system and evolving it? Because you don't want to make gigantic architecture changes that often. You don't really. When buildings are repaired, there's like tiny bits of things get repaired, and then at some point you tear the thing down and rebuild it. And I think that's a similar model applied to sustainable system architecture. You don't want to re-architect and redesign every few years. You want it to last as long as you possibly can.
Welcome to Approaches to Application Architecture. After watching this video, you will be able to describe component-based architectures and service-oriented architecture, explain the characteristics of a component, differentiate between components and services, and describe the characteristics of distributed systems. A component is an individual unit of encapsulated functionality that serves as a part of an application in conjunction with other components. There are 6 characteristics of components. Components should be reusable, replaceable, independent, extensible, encapsulated, and non-context specific. Let's briefly discuss each of these principles. Reusable implies that components should be designed such that they can be reused in different applications. Replaceable means that a component should be easily replaced with another component. Independent means the component should be designed so it doesn't have dependencies on other components. Extensibility entails the ability to add behavior to a component without changing other components. Encapsulation consists of bundling a component's data and methods to hide its internal state so it doesn't expose its specific implementation. And creating a component that is non-context specific involves designing it so it operates in different environments. Data that sets its internal state should be passed to the component rather than included within or accessed by the component. Let's take a look at some examples of components. An API can be packaged as a component if it can be reused across multiple systems and applications. For instance, a component could be an open-source API that connects a system to a particular database. A component can also be the interface for a database, called a data access object, that switches the user to a different database without the application knowing about the switch. And a controller is a type of component that determines which other components need to be called for a particular event. It controls the flow of data between 2 other components. Component-based architecture, then, focuses on the decomposition of the design into these logical components. Component-based architecture provides a higher level of abstraction than object-oriented designs. A component-based architecture should define, compose, and implement loosely coupled independent components so they work together to create an application. A service is like a component, also a unit of functionality, but it is designed to be deployed independently and reused by multiple systems. A service focuses on a solution to a business need. A key difference between a component and a service is that a service will only have one unique, always running instance with whom multiple clients communicate. This diagram displays the relationship between objects, components, and services in a layered architecture. Services are made of components, and components consist of objects. A service is a type of component. It is meant to be deployed independently of the overall system. Examples of services include checking a customer's credit, calculating a monthly loan payment, or processing a mortgage application. In a service-oriented architecture, or SOA, services are loosely coupled and interface with each other via a communication protocol over a network. SOA supports building distributed systems that deliver services to other applications through the communication protocol. So let's discuss distributed systems next. A distributed system is a system with multiple services located on different machines that coordinate interactions by passing messages to each other via a communication protocol, such as Hypertext Transfer Protocol, also known as HTTP. Even though the services on a distributed system operate on multiple machines, a distributed system appears to the end user as a single coherent system. A distributed system shares resources such as hardware, software, and data. They are fault tolerant, meaning if a node or a service fails, the system continues to run, also implying that the system may change during execution without service interruption. Multiple activities run concurrently on a distributed system, reducing latency and increasing throughput. Another property of distributed systems is that they are scalable as the number of users increases. The computers running the distributed system do not need to use the same kind of hardware or operating systems. and a distributed system may be made up of different kinds of computers and programming languages. Now, a node is any device on a network that can recognize, process, and transmit data to other nodes on the network. A distributed system consists of multiple interconnected nodes where the nodes are running one or more services in an SOA. Distributed systems generally use one or more of the following basic types of architecture: client-server, 3-tier, peer-to-peer, or microservices. These application architectures and their characteristics will be discussed in another video. In this video, you learned that components are reusable, independent, replaceable, extensible, encapsulated, and non-context specific. Component-based architecture is the decomposition of the system into logical, independent components. Services are made of components, and components consist of objects, and services are deployed independently and can be reused by multiple systems. In an SOA, services are loosely coupled and interface with each other via a communication protocol over a network. And lastly, distributed systems run on multiple services on different machines, and they appear to the end user as a single coherent system. Welcome to Architectural Patterns in Software. After watching this video, you will be able to describe different software architectures, such as 2-tier, 3-tier, peer-to-peer, event-driven, and microservices, and provide an example of each architectural pattern. An architectural pattern is a repeatable solution to a problem in software architecture. Patterns highlight common internal elements and structures of a software system. Different architecture patterns may share related characteristics. In this video, we will discuss 2-tier, 3-tier, peer-to-peer, event-driven, and microservices. However, there are many other patterns that will not be covered in this video. These patterns include Model View Controller, Message Broker, Blackboard, Pipe Filter, and Controller Responder. The 2-tier architecture, also called client-server, is a computing model in which the server hosts, delivers, and manages most of the resources and services delivered to the client. The interface resides on the client machine and makes requests to a server for data or services. This type of architecture usually has more than one client computer connected to a server component over a network connection. A 3-tier architecture, or an N-tier architecture, where there are more than 3 layers, is the most common software architecture. The 3-tier architecture is composed of several horizontal tiers that function together as a single unit of software. A tier only communicates with other tiers located directly above and below it. Related components are placed within the same tier, and changes in one tier do not affect the other tier. The 3-tier architecture organizes applications into 3 logical and physical computing tiers: the presentation tier, or user interface; the middle tier, which is usually the application tier, is where business logic is processed; and the data tier, where the data is stored and managed. The peer-to-peer architecture, or P2P for short, consists of a decentralized network of nodes that are both clients and servers. The workload is partitioned among these nodes. Peers make a portion of their resources directly available to other network participants without the need for central coordination by servers. Resources are things like processing power, disk storage, or network bandwidth. Peers both supply and consume resources, in contrast to the traditional client-server architecture, in which the consumption happens strictly by the client and the servers supply the resources. Peer-to-peer architecture is useful for file sharing, instant messaging, collaboration, and high-performance computing. An event is anything that results in a change of state. An event can be thought of as an action that is triggered by the end user, such as a mouse click or another part of the program. Event-driven architecture focuses on producers and consumers of events. Producers listen for and react to triggers while consumers process an event, and the producer publishes the event to an event router. The router determines which consumer to push the event to. The triggering event generates a message called an event notification to the consumer which is listening for the event. The components in event-driven architectures are loosely coupled, making the pattern appropriate for use with modern distributed systems. Microservices are an approach to building an application that breaks its functionality into modular components called services. An application programming interface, also called an API, is the part of an application that communicates with other applications. An API defines how two applications share and modify each other's data. APIs can be used to create a microservices-based architecture. The API gateway routes the API from the client to a service, and orchestration handles communication between services. Let's discuss an example for each of these patterns. A text messaging app is an example of a two-tier pattern. The client initiates a request to send a text message through a server, and the server responds by sending that message to another different client. And another example of the two-tier pattern is database clients connecting with database servers. Many web apps use the three-tier pattern. They use a web server to provide the user interface, an application server to process user inputs, and a database server that handles data management. The functions of these three types of servers will be discussed in more detail in another video. Ride-sharing apps such as Lyft and Uber are examples of event-driven patterns. The customer sends a notification that they need a ride from a particular location to another location, and that event is routed to a consumer. Cryptocurrencies such as Bitcoin and Ethereum use a peer-to-peer pattern. Each computer in the blockchain acts as both server and client. Finally, social media sites are composed of microservices. A user has an account, and that account can request different services, such as adding friends, targeted ad recommendations, and displaying content. Architectural patterns are not necessarily mutually exclusive. In other words, two or more of these patterns can be combined. For instance, a three-tiered architecture can also be microservice-based, or a peer-to-peer architecture can also be event-driven. However, not all architectural patterns can be used in conjunction with others. A peer-to-peer cannot also be two-tier because a single machine in a peer-to-peer architecture represents both a client and a server, whereas a two-tier architecture separates the client from the server. It is up to the system architect to determine which architectural patterns the software system should adhere to. In this video, you learned that an architectural pattern is a repeatable solution to an architectural problem. A two-tier pattern has a client and server. Text messaging apps use a two-tier pattern. A three-tier pattern has three tiers that interact with each other. Web apps use a three-tier pattern. An event-driven pattern has actions that are produced and responded to by a consumer. Ride-sharing apps use an event-driven pattern. The peer-to-peer pattern consists of a decentralized network of nodes that acts as clients and servers. Cryptocurrency is an example of the peer-to-peer pattern. Microservices are loosely coupled individual services that behave as a single system and interact with the client. Communication is orchestrated among services, and social media sites are an example. And finally, two or more patterns can be combined in a single system, but some are mutually exclusive. Welcome to Application Deployment Environments. After watching this video, you will be able to list different types of pre-production environments and state their purpose, differentiate a production environment from other application environments, and compare and contrast deployment options. An application environment is the combination of the hardware and software resources required to run an application. This includes the application code and/or binary executables for its various components or modules, the software stack it requires for running the application, such as modules and libraries it depends on, third-party applications and middleware, and the operating system. Any networking components and infrastructure, as well as any physical or virtual hardware, including computing or processing resources, memory, and storage. There are a variety of environment types, depending on the application's stage in the life cycle. The pre-production environments are those platforms that the application resides on in various forms as it gets prepared for production. Common pre-production environments are development, QA, which stands for quality assurance, and staging. The development environment is the platform on which the application is being actively coded, and in many cases, it may just be the developer's workstation. The QA environment, sometimes called testing, is the environment that allows the QA team to test the application's components. The staging environment is the environment that is as close to replicating the production environment as possible, but is not meant for general users. Now let's discuss the production environment. The production environment, often just called production, includes the entire solution stack, consisting of both hardware and software on which the application runs as additional infrastructure components. The production environment is intended for all users. Unlike the pre-production environments, this robust environment must take the application load into consideration because it is the environment intended for general use, possibly by thousands or millions of people at the same time for enterprise-level applications. Production environments must also take into account non-functional requirements like security, reliability, and scalability. This makes the production environment more complicated than the pre-production ones. Now let's take a look at the production environment infrastructure. There are several options for deploying application environments. In on-premises deployment, the system and its infrastructure resides in-house, within the organization's physical location, often behind a firewall. Firewalls prevent unauthorized access to or from a private network. If an organization desires greater security or control of an application and the data in use by that application, it may deploy the application on-premises. For on-premises software deployments, an organization is responsible for the system, hardware, related infrastructure, and maintenance required to run the application. On-premises deployment is usually more expensive when compared to cloud deployment. So let's discuss cloud deployments next. There are 3 types of cloud deployment models: public, private, and hybrid. The public cloud is when you leverage the software supporting infrastructure over the open internet on hardware owned by the cloud provider. That hardware and the associated services are shared with other companies. Public cloud providers include Amazon Web Services, or AWS, Microsoft Azure, Google Cloud Platform, and IBM Cloud. The public cloud is the most common due to its scalability and cost. With a private cloud, the cloud infrastructure is provisioned for exclusive use by a single organization. The software system can be run on-premises, or the infrastructure could be owned, managed, and operated by a service provider. For example, AWS is also a private cloud service provider. The main advantage of a private cloud is its increased security, but it also allows for more flexibility because it can be fully customized. Now, a mix of both public and private clouds working together seamlessly is called a hybrid cloud model. A hybrid cloud potentially optimizes the advantages of both public and private cloud models with regard to cost, security, scalability, and flexibility. In this video, you learned that application environments include development, testing or QA, staging, and production. Production environments must also take into account non-functional requirements like load, security, reliability, and scalability. And application environments can be deployed either on-premises on traditional hardware or on public, private, or hybrid cloud platforms. Welcome to Production Deployment Components. After watching this video, you will be able to describe components commonly required for deployment in a production environment, describe the purpose of a firewall and a load balancer, and differentiate between different types of servers. Let's consider an N-tier architecture required to deploy an application in a production environment and represent the infrastructure using a diagram. The top tier is the presentation tier, which contains the front-end client applications. All of the other tiers are located behind a firewall. Firewalls and other components mentioned in this diagram will be discussed in further detail later in the video. Now, the next tier is the web tier, which has a web load balancer that distributes incoming traffic to several web servers. The tier below the web tier is the application server tier. This tier contains an app load balancer or a proxy server that routes traffic to different application servers. And the bottom tier is the data tier that contains the database server. A high availability replica of the database is often used to ensure reliability. Some environments may have additional components or tiers. Also, not all of these components are necessary for every deployment. For example, in some environments, there might not be a need for both application servers in addition to web servers. Now, let's look at these components in further detail. A firewall is a security device that monitors traffic between networks. It permits or blocks requested data based on a set of security rules. It acts as a barrier between networks to block viruses, malware, and hackers from accessing the internal network. The purpose of load balancers is to distribute network traffic efficiently among multiple servers, called a server farm, on a network. Load balancers are used to prevent server traffic overload and are located between clients and the servers. A load balancer determines which servers are capable of fulfilling those requirements in a manner that maximizes availability and responsiveness. Load balancers ensure that no one server is overworked. They manage concurrent requests from clients and return the correct data in a fast and reliable manner. Web and application servers are either software or machines that provide services, resources, data, or applications to another computer program called the client. Servers store, process, and manage network data, devices, and systems. A web server delivers content such as web pages, files, images, and videos to a client. And a web server primarily responds to hypertext transfer protocol requests coming from a web browser, such as a user accessing a website. An app server is a server that runs business logic and provides the application to the client rather than the client running the app on their own machine. Its primary job is to enable interaction between the end user and the server-side application code. The application code represents the business logic that determines how data can be created, stored, and changed, and that logic dictates things like transaction results and what data is written to and retrieved from a database. Next, a proxy server is an intermediate server that sits in between two tiers and handles requests between those tiers. A proxy server can serve multiple purposes, such as load balancing, system optimization, caching, acting as a firewall, obscuring the source of the request, encryption, scanning for malware, and more. And a proxy server can improve the efficiency, privacy, and security of data flowing through a network. Finally, a database is a collection of related data stored on a computer that can be accessed in various ways. A database is usually controlled by software, called a database management system, or DBMS. The DBMS controls a database by connecting the database to users or other programs. The database server controls the flow and storage of data. The DBMS connects the database server to an application so data stored in the database can be retrieved or manipulated by the application. In this video, you learned that common components needed for a production environment include a firewall, a load balancer, web and application servers, proxy servers, and database servers. A firewall is a security device that monitors traffic between networks. A load balancer distributes network traffic among servers. A web server delivers web content, such as web pages, files, images, and videos, to a client. An application server runs business logic and provides the application to the client rather than the client running the app on their own machine. And finally, a database server stores and controls the flow of data through a database management system. Welcome to Insider's Viewpoints, Deployment Architecture. In this video, we will hear from experts discussing important aspects of software deployment.
I think often you need to think about scale, like the sort of just in general, is your system, how many users will your system has, how much data do you expect to flow through it, how much data do you expect to produce and store, how real-time do you need the data access to be, what is your logging story like, do you have privacy concerns, do you need to ensure that data is anonymized, so you kind of, I think, thinking about the scale, the regionality, is it global, is it local, what is your logging, what are your logging needs both for internal and external data analysis, mapping out the data flows. So these are sort of the things I think we start with with design principles.
And in terms of choosing infrastructure, like whether you want to go serverless, whether you want to use a hosted backend, or you're hosting your own, these are all design and architectural decisions that will probably, for your first few jobs, already be taken for you.
What's your system of SLOs, your availability look like, service level objectives, right? So you need to just think about sort of those sorts of things. I think ensuring you have like what does a healthy system mean to you? What does a well-running system mean to you? You need to define those metrics up front and sort of have those monitored and watch those as your system lives on, and make sure that you're meeting those objectives and goals and have a plan to mitigate them if they fall below where you like them to be. These days, I think microservices and keeping code as modularized as possible to avoid giant sort of bloated behemoth code bases is really important so that people can move fast and deploy fast.
But what I would say is a critical part of the deployment option is when you look at deployment and integrating your code, testing is fundamental. So I would strongly urge all of you to really pay attention to testing and to use test-driven development, TDD, test-driven development, as a development habit that you inculcate in your life as developers and engineers. It'll stand you in very, very good stead. I think that's the single most important part. You won't always do it, but you should try and do it as much as you can.
You need to think about whether you want to canarying. There's a canary in a coal mine analogy. So there's a process called canarying where you try to roll out new code and test whether it's going to blow things up or break things. And you want to think about you need to think about how quickly you need to release or not, how quickly you may need to roll back your code or not.
Welcome to What Does a Software Engineer Do? After watching this video, you will be able to describe the types of software that software engineers develop and the technologies that they use. Identify the categories of software engineers and the teams they work in, and describe the day-to-day tasks and responsibilities of a software engineer. Software engineers use their talents in engineering, mathematics, and computing to design and develop software that solves real-world problems for their users. If you're an analytical thinker who enjoys problem solving, software engineering might be the career for you. Software engineers develop a plethora of different types of software, from desktop to web applications, to mobile apps, games, operating systems, and network controllers. They use many technologies to do this, including programming languages, development environments, frameworks and libraries, databases, and servers. There are two categories of software engineer: back-end engineers, also known as system developers, who build the computer systems and networks that front-end applications use, and front-end engineers, or application developers, who are more client-focused. They create the software that users will interact with, such as Android, iOS, and Windows applications, and platform-agnostic websites. Software engineers work in a wide variety of settings. You could work in a team developing off-the-shelf software, bespoke software to meet a specific client's requirements, or internal software for users in your organization. And within your team, you might work on data integration layers, which access and load data from a variety of sources into your solution; business logic, which applies real-world business rules to the data in your solution; or user interfaces, which enable users to interact with your solution. On a day-to-day basis, you might undertake tasks such as taking user specifications and designing new software systems to meet their requirements, writing code and testing that it works as expected, evaluating and testing new software programs, optimizing software programs for maximum efficiency, maintaining and updating existing software systems, documenting code so that other developers can understand it, or presenting new systems to users and customers. And some software engineers, such as DevOps practitioners, also integrate and deploy their code onto the underlying infrastructure. As well as building your own systems, you'll also be testing, improving, and maintaining software built by your colleagues. The responsibilities of a software engineer are as many and varied as the tasks which they undertake. In a junior position, you are likely to start out with a limited set of responsibilities focused on writing, testing, deploying, and documenting code, but as your career progresses, this will widen. And in a senior role, you will likely have primary responsibility for multiple areas of the software solution, including the planning and designing phases. In this video, you learned that software engineers design and develop a range of software solutions. Back-end engineers build the computer systems and networks, and front-end engineers build the user interfaces. Software engineers undertake a range of tasks, from designing and writing new software to maintaining and updating existing software. And as your career develops, you will move from being responsible for one small section of code to many areas of one or more products.
Hi, I'm Shelley, and I work as a software engineer for a startup company in North Carolina. When I arrive at work in the morning, I spend some time catching up on my messages and checking my calendar for the day. Before heading to my daily stand-up meeting, I quickly check the status of my code merge request from yesterday. Great! It's got positive feedback from others in the team and some suggestions from my mentor about improvements I could make. I'll work on those later. During our daily stand-up meeting, each member of the team talks about what they achieved yesterday and what they're working on today. Jonathan, my mentor, gives me some more advice about how I can optimize the code I wrote yesterday. After the meeting, I return to my desk excited to implement the feedback I've received and continue working on my code. Now, it's focus time, when I can concentrate purely on my project work. I use Jonathan's comments on the merge request alongside the notes that I made during our stand-up to re-engineer a couple of methods to run faster. I also use some of our analysis software to compare timings with the previous version, and, when I'm satisfied that there's a marked improvement, I submit a new merge request to gather additional feedback. I then send Jonathan a message to ask if he can review it later today. After lunch, I'm invited to a meeting where the marketing department explains that they need a new feature to monitor the effectiveness of their campaigns. One of the senior software engineers, Marie, mentions that she's previously developed a React-based front end for a management dashboard that we could easily reuse. I'm tasked with creating a minimum viable product, MVP, for a small team in the marketing department to trial and provide feedback on. I've not used React before, but this is a great chance to get some hands-on experience with it while still making a contribution to the team. Learning on the job and developing new skills is an important part of a software engineer's role. On my return from the meeting, I find that Jonathan has reviewed my code and approved the merge request. He's impressed with the speed of the code and with my coding style. It's really helpful to get regular feedback from more experienced members of the team who can suggest alternative ways of solving problems. I've also received a bug report notification for one of the features I was working on last week. When I review the full report, I quickly spot the mistake and begin fixing it. To check that the fix and the original functionality work as expected, I develop and run a test case for the feature. It passes, so I submit a merge request for my fix and resolve the bug. Now I'm free to start researching React. I spend the rest of the afternoon reviewing the React documentation, watching videos, and reading blogs to give me an overview of React. I then contact Marie to ask for access to the front end she developed so I can review the existing solution. This gives me design ideas and inspires me to start planning my dashboard. On my cycle home, my head is buzzing with thoughts about how the new dashboard will look and the functionality I could provide through it. Tomorrow can't come quickly enough.
Welcome to Skills Required for Software Engineering. After watching this video, you will be able to differentiate between hard and soft skills, describe the hard skills needed by a software engineer, and describe the soft skills needed by a software engineer. Hard skills are the practical skills needed to perform a particular role. So, for a software engineer, these will be the technical skills they need to design, build, maintain, and repair software solutions. Hard skills are learned skills. In the case of software engineering, they are usually learned in a school, college, or university environment, or by studying online courses, diplomas, or certificates. Alternatively, they can be gained from years of experience in the field. Hard skills are quantifiable, so it's easy to measure whether an individual can demonstrate a particular skill and to certify them in that skill. Commonly required hard skills in the software engineering sphere include programming languages, version control, cloud computing, testing and debugging, monitoring, troubleshooting, agile development, and database architecture. Now, soft skills, on the other hand, are less tangible. They are your personal characteristics and interpersonal skills. They're the non-technical skills that are part of your personality and, as such, are harder to define, quantify, or certify than hard skills. Because they're not linked to a particular business, though, they are easily transferable between roles and across industries. The job requirements for any role will be a combination of hard skills and soft skills. So let's look at some of the hard skills that are relevant to a software engineer. Software analysis and design skills are essential for a software engineer. You need to be able to analyze your users' needs through a variety of methods and then design effective solutions that meet those needs. You'll also need to be able to develop those solutions. Computer programming and coding are essential development skills. While some job roles require a specific language and/or toolset, employers will sometimes welcome you with experience in any language but expect you to cross-train into their preferred language. The Coding Bootcamp website, Coding Dojo, states that some of the most in-demand languages are currently Java, Python, C#, and Ruby. An understanding of a variety of frameworks and object-oriented principles are also key skills for a software engineer. While you'd hope to always create flawless solutions, it is likely that at times your code will either not work or not work in the way that you intended. You need testing skills to determine whether your code meets the functional specification of the solution and if it's easy to use. And when your code isn't working as expected, you need debugging skills to work out why. And when your solution is complete, you need deployment skills to distribute it to your users. These could include shell scripting, containers, and continuous integration and continuous delivery or CI/CD tools. You'll also need monitoring skills so that you can review the performance of your solutions and troubleshooting skills to resolve any issues that may occur. So now let's look at the soft skills of a software engineer. Teamwork is a key soft skill. Software engineers work in a variety of teams, some based on the project they're working on and some based on their specific role. If you're practicing agile development, you may also work in small teams known as squads. And you might also work closely alongside another developer in pair programming. Working in teams enables you to take advantage of each individual's strengths, as well as providing opportunities for you to gain new knowledge and skills. You'll need to be able to communicate with a wide variety of stakeholders in your project, from technical colleagues to non-technical personnel. For example, you may need to ask your peers for support and ideas, your manager for guidance and direction, your client for clarification of their needs, and your users how they'd best interact with your solution. Software solutions are often time-sensitive projects, and as such, your manager will be keen that you meet their deadlines. Managing your own time is imperative to ensure that you don't cause delays to others waiting for your work. And with increasing numbers of teams working across time zones, what could previously only seem like a small local delay can create a whole day of lost time for someone located elsewhere in the world. Software engineers need great problem-solving skills to succeed. You need them in the design phase to work out how to create an appropriate software solution, in the development phase to work out the code required to perform the task required, in the testing and debugging phase to locate and resolve any bugs, and throughout the lifecycle of the software to manage any issues that may arise. And when those issues do arise, you need to be adaptable to meet the changing needs of the project. Examples of changes include your client requesting a change or addition to the functionality, your manager requesting you to move on to a different area to meet a looming deadline, or your user requesting an alternative method of achieving a specific task. And finally, you need to be open to feedback on your work. Most software teams use some type of peer review system where peers review each other's code. This helps enforce any corporate standards and improves the code. In a junior role, you'll also likely have a mentor who'll provide feedback and pointers where you can improve. And your stakeholders will provide feedback on pre-release and final versions of your solution. Accepting all of this feedback in an open and welcoming way ensures that your solution becomes the best that it can be and that you progress in your role. In this video, you learned that a combination of hard and soft skills are essential to a software engineer. Hard skills are measurable, learned skills such as programming, testing, and troubleshooting. And soft skills are your personality and characteristics, such as communication and problem solving. Welcome to Insider's Viewpoints, Advice to Future Software Engineers. In this video, we will hear from software engineers discussing their advice to those who are considering getting into the field.
Practice. You should practice all the time. you should learn new skills as much as you can. There are a lot of free resources out there that you can use to help you build new projects. I think the best way to continue working on your craft is to not only learn new things, but also use them to build new projects. Doesn't matter if it's something that's been done before. The point is that you're doing it now, and you're using the tools that you've used to build something new.
The most important thing for my career has been finding a business domain that I am interested in that has what look like not low-hanging fruits, but interesting problems to grapple with. The interesting problems for you are certainly going to be different than the interesting problems for me. But if you narrow down the domains that you're interested in, that can really help tailor both the things that you study, the types of jobs that you apply for. I have other friends where the domains that they're super interested in is like machine learning. Like they're just nuts for machine learning, and so they'll do anything that they can exercise like an artificial intelligence kind of thrust to the whatever business problem it is that they're working on. So like find that general domain and then kind of like dive in on that one.
But don't be scared to fail either. I think the beauty about one of the beauties about software engineering and the way that tech is evolving is there are a lot of opportunities, and there will continue to be new opportunities, and there's lots of movement in the industry. So if you take a job and you really are excited about it, but it ends up not working out as well, you can always, I think, move to somewhere else. There's lots of different types of lots of roles, lots of companies, all that sort of people move around. So don't let one potential failure either mean you give up. I think wouldn't be a failure.
Yes, so my best advice for those looking to get into the software engineering industry is to figure out what role you want to get into, make a list of the required skills for that role, and find free resources to start learning online. So when I was exposed to coding in 2018, after trying a few technologies, I decided that I wanted to be a front-end engineer or a front-end developer. And so I made a list of all the skills that I needed, and I started learning those skills using like free or low-cost resources online.
I think being careful about what's sort of hot and new. There's often, this is more specifically to like taking jobs and how do you find like a good role and fit for you. I know a lot of companies will often sort of market themselves as being, we're working with XYZ new technology. It's super, super hot, and it's like the latest and greatest, and almost use buzzwords as a way to attract people. Be inquisitive and ask clarifying questions. Be wary in that sense too, or cautious when it comes to some of the buzzwords and new things, and just know what you're getting into.
Don't neglect the job hunt process. Pay due attention to that, because if you just study and don't pay attention to the job hunt process, you're going to get frustrated because you're going to finish one phase and then have a long period of frustration and self-doubt after that. So if you can do the job hunt phase in preparation sort of in parallel with the latter half of your learning journey, I think you're going to be prepared to hit the market hard when you're ready. And it's just a question of time after that, time and persistence.
Welcome to Insider's Viewpoints, Advice to Women in Software Engineering. In this video, we will hear from software engineers discussing their advice to women in the field or who are considering getting into the field.
Recently, there have been a lot of good positive momentum and a diversification of the industry, and making software engineering a more welcoming place for women in general.
So I come from work environments that are, primarily women, and now I'm in a work environment that is primarily men. I think I've had a pretty good experience with my coworkers personally, but in the beginning it did very much feel like a little bit kind of like you're alone because, you're either the only or one of 2 or 3 women on your team, I would say just remind yourself that you actually do deserve to be there, that you actually do belong. You do belong there. And everybody started exactly where you are. Everybody who started as an engineer and even at your company started and was like, I do not know what's going on, but you're capable and you'll figure it out.
But if you're a software developer at a company, your main job should be software development. And if your bosses or management or other people in the company want you to do other types of work, you should be getting compensated for it. You should have a title that reflects what it is that you do. I have seen this happen a lot where the woman on the team will be the one who cares about diversity, for instance, and so is part of diversity workshops and clubs at the company, and is participating in diverse hiring events and doing all sorts of like extra training around that side of things. And then review time happens, and as a software developer, if you're getting reviewed on code, you need to make sure that you're getting enough of that code in your life. Everyone needs to contribute. Everyone needs to pull their weight. It can't all go on one person.
Join a team that does make you feel like they do support women and want to elevate women and advocate for women. So I think it's very fair to ask directly to, say, a hiring manager, what is your plan for diversity on your team? What types of programs do you or the organization or company have in place to ensure that women are successful? And be willing and open to speak up if there's something that you think is uncomfortable.
It's not all on you to fix if something is broken. There are other people involved, and they also are adults who should be reasonable human beings and able to take advice and constructive feedback. So let them take that advice and constructive feedback. You don't have to do all the changing.
Never be compelled to join a team where you're not feeling good about it, or you think that there's a risk that it's not a welcoming, so ask other people too. I think it's very fair to just ask those questions.
Don't stay. Don't stay if you don't like it. The company needs you more than you need them, almost certainly. So leave when you can. If something isn't working out for you, leave. You have that ability. And there are companies that have less of that in their culture and less of that in their engineering teams. It can feel rough trying to find it sometimes, but if you do find yourself at a place that is not a healthy, positive, growing environment for you, leave. It doesn't reflect on you. Again, it reflects on the company.
And I know any company or organization that's even remotely taking diversity and inclusion seriously, specifically with regards to with women, will have programs in place to support women, elevate women, and basically there is an eye on that, and as there should be. There's a lot of effort being put into hiring women and getting women into senior leadership roles, which I think is very important.
Figure out what role you want and find free resources to get into those roles. One thing to bear in mind is, as a woman, we are a minority and we're underrepresented in the tech industry. So there are a lot of free or low-cost programs tailored specifically to women who want to get into computing, or women who are in computing looking to advance their careers.
Welcome to Job Outlook for Software Engineers. After watching this video, you will be able to explain why demand is high for software engineers, describe the job outlook for a software engineer, describe what to expect from a software engineering role, and describe the employment options in software engineering. There are various reasons behind the current high demand for software engineers. Almost all industries need software to compete and grow, and this results in a continuous demand for software engineers. Most organizations require applications and websites for their company to function. Some apps and websites are for internal use, while others are used to interact with customers. The Internet of Things is also driving the need for software that interacts with products. This is a need that will continue to expand for the foreseeable future. All types of software programs, from messaging applications to commerce websites to office software, are available in different flavors from different vendors. Whenever one vendor releases a new version of their particular program, a competing company is likely to also update their program, requiring more software engineers to create the new releases, enhance functionality, and add new capabilities. So, the outlook is bright for software engineers. The U.S. Bureau of Labor Statistics predicts a higher than average 22% job growth rate for software developers, analysts, and testers from 2020 to 2030. That's an average of almost 200,000 openings each year in the United States alone. These roles are likely to be across many industries, from mobile application development to health and insurance. There is also predicted to be a large increase in security software due to the increase in computer security threats and cybercrime. Many software engineers are graduates with degrees in software engineering or computer science. However, increasingly, employers like IBM, Google, and Tesla are starting to hire non-graduates who demonstrate the required skills for the role. This opens software engineering up to a wider range of society, ensuring that the cost of obtaining a degree doesn't preclude candidates from the industry. Salaries for software engineers vary significantly with years of experience in the field. As you acquire more experience and become harder to replace, employers typically provide higher compensation. In the USA, salaries range from $90,000 for a junior role through to $120,000 or higher for an experienced position. The average of $110,000 per annum for a software engineer is more than 2.5 times the average base salary across the USA. This, alongside bonuses and benefits such as medical insurance, gym membership, profit shares, and retirement plans, make a software engineering role an attractive proposition. So, what should you expect from a software engineering role? Dress codes are unlikely to be formal unless you're in a customer-facing situation. Hours are often flexible, sometimes around core hours set in the middle of the day. You may occasionally be required to attend meetings or calls which can dictate a physical or online presence at a particular time of the day. And the number of hours are likely to increase as you get near to product release dates, often without any matching increase in pay. The flexibility to work from home varies across employers, but there is no technological reasons why this cannot be done. In fact, some software teams are spread across the globe, working across all hours of the day. Software engineer employers include almost any type of business that you can imagine, from large technology companies such as Facebook, Amazon, Apple, Netflix, and Google, also known as FAANG, to medium-sized software companies that develop specific software and solutions to small software houses and startups. And almost all large non-technology companies, like banks, retailers, and pharmaceuticals, need software engineers for their own internal or external systems. And lastly, most employers will encourage continual learning, whether that be expanding your technical skills or enhancing your soft skills. They're usually keen to invest in keeping your skills up to date so that you can develop the best software solutions for them. Now, in the software engineering world, regardless of your job title, there are different employment options to suit your lifestyle and situation. Employed roles in a company or organization provide stability and a regular income. These can range from an apprenticeship or internship to a part-time role through to a full-time role. In software engineering, more so than a typical job, there is a huge independent contracting market and opportunities in the gig economy. These can range from simple website development to super specialized skills, languages, stacks, and products. In this type of employment, you can provide contract or consultancy services to organizations on a time-based or project-based model, or you can work on a freelance basis, taking on short-term contracts to work on projects that interest you. And many software engineers also code for free as volunteers, contributing to open-source projects. This can help you gain experience, enhance your skills, improve your employment opportunities, and enhance your technical eminence. It also makes you feel good by doing something for a cause or community or social initiative that's important to you. In this video, you learned that the high demand for software engineers is due to increasing needs for software, increasing complexity of applications, and a continuing growth of technology. The outlook for software engineers is promising. The role of a software engineer can be flexible and satisfying, and that employment options for software engineers are flexible and varied from full-time employment through to voluntary activities. Welcome to Career Paths in Software Engineering. After watching this video, you will be able to describe typical career paths for a software engineer and identify the likely roles within career paths. A career path in software engineering opens up as you gain experience and attain new skills. Often it heads in one of two directions, technical or management. If you thrive on working with code and solving problems, then the technical path enables you to continue working closely with technology as your career progresses. Or if you exhibit strong leadership qualities alongside the soft skills of a good software engineer, you might progress onto managing a team of software engineers and the work that they do. So let's take a look at a common career path for a software engineer progressing on the technical or managerial path. Remember that different organizations will use different job titles, but the roles will be similar across the board. You're likely to start out in an entry-level position as a junior software engineer or associate software engineer. At this level, you'll be developing small chunks of software to meet agreed client specifications. You'll be assigned a team leader or mentor who will guide you along the way and provide support when you need it. During this phase of your career, you'll be on a steep learning curve, gaining new skills and experience with every block of code that you write. You could then move on to a software engineer position. In this role, you'll be expected to be more independent and be able to break larger tasks down into smaller, achievable subtasks. You may be learning new programming languages and demonstrating an understanding of the software development lifecycle. At this stage, you might be asked to mentor a junior software engineer or take responsibility for a larger part of a project. The next stage of your career could be a senior software engineer position. In this role, you're likely to have involvement across the whole of a project and with an entire code base. You may be asked to mentor software engineers and to conduct code reviews across the team. And from the experience you've gained in earlier roles, you'll be expected to be able to solve a wide range of problems in an efficient way. If you choose to follow the technical path, then your next role might be as a staff software engineer. In this role, you'll work as part of the technical team, developing, maintaining, and extending software. You'll be responsible for ensuring that the software meets customer and user expectations, and that it uses resources efficiently. If you decide to follow a managerial career path, you could become a technical lead. In this role, you'll manage the team of developers and engineers developing the software in your organization. You could be responsible for the entire development lifecycle and report to the project stakeholders. Continuing along the technical path, you might progress to be a principal engineer or technical architect. At this stage, you'll be responsible for the architecture and design of a software solution, as well as the development of it. You'll be expected to create processes and procedures for your team and provide technical direction. On the managerial path, you could become an engineering manager. In this role, you'll ensure that the entire team is appropriately supported and encouraged to progress in their careers. Becoming a director of engineering could be the next stage in the progression of your career. It is a strategic and technical role. On the strategic side, you'll determine priorities for the projects within the company, identify hiring needs, and define long-term goals. On the technical side of the role, you'll be involved in defining new projects, specifying requirements, and overseeing the project. The lead of an organization's technology arm is likely to be the Chief Technology Officer, or CTO. In this role, you oversee all of the research and development in the company. You'll also monitor the company's systems and infrastructure to ensure that it meets your needs and budget. Even at this level, you'll continue learning. As technology evolves and new products appear on the market, you'll be responsible for deciding which ones meet your business needs and could give your organization a competitive advantage. Of course, not everyone who starts out as a junior software engineer follows these traditional software engineering paths, but you'll find that the skills you gain will benefit you in a wide variety of other roles. If after working on client projects for a while, you decide that you prefer interacting with the clients to writing code, you could transition into a technical sales or customer support role. If you enjoy coding but find working with numbers and data is more appealing, you could transition into a data engineer or data scientist role. And if you find that the data side of your new role is your passion, you could move on to become a database administrator or database developer. And if you enjoy finding and fixing bugs, you might transition to a software tester role. IT is a vast field with an abundance of opportunities across many skill sets. So starting your career in software engineering is a great choice, even if you use it as a stepping stone to move to other technical or leadership roles in the future. In this video, you learned that a career in software engineering is likely to follow a technical or managerial path. At each stage on that path, you will take on more responsibility and a wider range of tasks. And starting out as a software engineer enables you to take on an array of other options at any stage in your career. Welcome to Software Engineering Job Titles. After watching this video, you will be able to list commonly used job titles for software engineers and identify the primary duties of and skills needed for these roles. Job titles such as software engineer and software developer are very broad and can be used to describe a spectrum of roles. As well as these titles, you may come across other titles related to specific subdomains in software engineering. While individual organizations might use company-specific job titles, you'll find that most fit into one of the more generic titles. Types of software engineer roles include front-end engineer, back-end engineer, full-stack engineer, DevOps engineer, software quality assurance engineer, software integration engineer, software security engineer, mobile app developer, and games developer. Front-end engineers focus on developing the user interface, or UI, of a software solution. They're also sometimes referred to as UI developers or web developers. In this type of role, you're responsible for the visual design of the software, including the layout of UI elements and the overall aesthetics of the application or website. It's important for a front-end developer to understand how users interact with software and the principles of user experience design. You'll also need to understand how objects and code run differently on different operating systems, devices, and browsers to ensure that your solution works on the user's chosen system. Key skills of a front-end engineer include web development languages and UX and UI frameworks. Back-end engineers focus on the business logic of a software solution. In this type of role, you're responsible for the core logic of the software implementing functionality to perform tasks, such as accessing data and databases, logging information, and caching systems by using application programming interfaces or APIs. You'll also be responsible for ensuring the scalability and performance of the solution. Key skills of a back-end engineer include programming languages, application frameworks, web servers, app servers, and load balancers, databases, and deployment and containerization tools and technologies. Full-stack engineers work across the whole software solution. In this type of role, you're able to create both the user interface and the back-end functionality of an application or website using the skills of both front-end and back-end engineers. Key skills of a full-stack engineer include web development languages, programming languages, UX, UI, and back-end frameworks, web and application servers, databases, APIs and web services, and deployment and containerization tools. DevOps, or Development and Operations, aims to deliver the software in an agile manner by combining software development and IT operations. DevOps engineers apply agile processes and methodologies to streamline their product development, improvement, and maintenance, as well as transcend the boundaries of the traditionally distinct development and operations teams. In a DevOps role, you need familiarity with both front-end and back-end technologies. The skills, technologies, and products that a DevOps engineer is likely to use include source code management tools, programming languages and frameworks, scripts, and deployment, containerization, and monitoring tools. And depending on the actual job posting, you might use alternative products and services, but they will be of a similar nature to those shown here. Software quality assurance engineers, also referred to as software QA engineers or software test engineers, test, review, assess, and write software to validate the quality of an application. In a QA role, you'll develop automated tests, tools, and procedures to test the functionality of software solutions. You'll use bug tracking software to log any errors you discover and report them to the software development team. The key skills for software QA engineers include programming languages, shell scripting, bug tracking and issue management tools, testing automation tools, and specific software stacks depending on how the application is deployed. Software integration engineers write code to integrate software into hardware products, enabling smart devices and the Internet of Things products. In this role, you'll use programming languages and frameworks to program hardware, such as consumer devices, home security systems, electronics, and other interfaces. The key skills for a software integration engineer include programming languages and proprietary technologies, frameworks, and toolkits. Software security engineers, sometimes referred to as white hat or ethical hackers, work to find security flaws and vulnerabilities in software. As a security engineer, you'll create systems, methods, and procedures to test software solutions and exploit their security weaknesses so that they can be fixed before the solution ships. The key skills for a security engineer include programming languages, reverse engineering, shell scripting, tools for vulnerability and penetration testing, and network security and encryption tools. Mobile app developers design, develop, and implement software solutions for mobile devices, such as smartphones and tablets. You'll use web skills to create front-end apps, as well as learn the various different platforms to write the back-end code interacting with the specific type of device. The key skills for a mobile app developer include mobile operating systems, web development languages, and programming languages, as well as web services and technologies. And games engineers write gaming software for a wide variety of devices, from PCs to smartphones to web browsers to game consoles. As a games developer, you'll work alongside graphic artists, sound technicians, and game designers to create the code used in games. In this video, you learned that there are many different job titles under the umbrella term of software engineering, each of which has specific duties and responsibilities and requires a specific set of skills. Welcome to Insider's Viewpoints, Career Pathways, and Continuing Education in Software Engineering. In this video, we will hear from experts discussing how they became software engineers, their education, and their background.
So I have a non-traditional path into software engineering. My bachelor's degree is in social work, and I worked as a social worker for some time. I was introduced to coding via social media. Randomly on social media, I was scrolling in December 2018, and afterwards I kind of fell down the rabbit hole of learning how to program, and I decided to go to a 10-month long, very intense coding bootcamp to make the switch into software engineering. And so one thing I have learned over the past three and a half years is that your career doesn't have to be linear, and your career doesn't have to look like anyone else's.
If I just picked computer science, I love math. That's the only thing that I think really drew me to computer science was, if you love math, apparently you'll love computer science too. So I think some of the most successful engineers that worked for me or I've worked with come from backgrounds, not even sort of like mine either, people with non-technical backgrounds who picked up coding on the side. There's so many folks who come from or English majors or philosophy majors or bio, whatever it is, because I think there's this, you can learn all these skills and become a really strong engineer without having gone to a four-year college or more for computer science specifically or another engineering role.
In college, I ended up taking applied math. I did applied math as my major. I always wanted to work on things that had a practical application, which is why I went into applied mathematics rather than pure mathematics anyway. Yeah, so I did that research program, and as part of that program, we were writing simulations using MATLAB, actually. That was a fun time. So we were writing simulations using MATLAB, and I realized I enjoyed that part more than I enjoyed the mathematical research part of it, and that's kind of what kicked it all off. It's like, oh, computers are a lot of fun. So I ended up graduating college with an applied math major, a computer science minor, and then I've been taking computer science jobs ever since then.
So I received a Bachelor of Fine Arts, actually, so not anything tech related. And I worked in education for a few years. I ended up as an art teacher, and it was during that time that I decided that I wanted to switch paths because I wanted a little bit more freedom with my job, more flexible schedule. I wanted the opportunity to work remotely. So I decided to take a class to see if I would like it at a community college near my house. And I really, really loved that class. And at the same time, kind of just watch videos on Udemy and YouTube and teach myself some things that I wasn't learning in class. I took 32 credits at the community college level. And then after that, I did apply to graduate school. While in grad school, I received an internship offer at my current company. I did a summer internship, and directly following that, I started full-time.
Next, we will hear from these experts regarding how they maintain their skills and keep up with the continuous technology evolution.
I follow people on Twitter who talk about emerging technologies and new technologies. I also subscribe to this newsletter called TLDR, and they pretty much just surmise everything that's going on in the tech industry. That's what I like to do to keep up to date. And I also take various courses on things that are interesting to me.
Yeah, and I think just carving out time to learn, whether it's within your, often companies will give people some amount of time to for personal development and growth, which can mean taking courses to learn new languages or frameworks.
I've found that I learn best if I have a project that makes me need to learn the thing. So I started with Googling. Like, honestly, Reddit threads frequently are the best places to find out about what are the popular and new technologies these days. If you just search on Google for best website framework, Reddit 2022, you'll find numerous posts of people debating the pros and cons of different types of frameworks. And then actually another very important thing is debug it. Attach a debugger, put in print statements, do everything you can to be able to inspect the flow of the code that is getting run. Knowing how to debug is about almost equally an important skill as knowing how to write the code.
The way that I kind of keep on top of everything is reading documentation. I have really great coworkers who are always also in the know of like when things are updated, when languages are updated, when to use new technologies. So they help me out a lot there. And we also get Udemy for free, like Udemy Business for free for all employees, which is a really great way to learn new things and also stay on top of new technologies that come out.
Welcome to Software Engineering Code of Ethics. After watching this video, you will be able to state each of the 8 principles in the Software Engineering Code of Ethics and explain each of the 8 principles in the Software Engineering Code of Ethics. The Joint Task Force on Software Engineering Ethics and Professional Practices developed a code of ethics outlining their goals and standards for software engineers engaged in the design and creation of software. The task force was formed by the Institute of Electrical and Electronics Engineers Computer Society, or IEEE-CS, and the Association for Computer Machinery, or ACM, in order to recognize the prominence of computing in global commerce, government, and society. This IEEE-CS-ACM Joint Task Force championed the need to hold software engineers accountable so that the present and future status of the field as a beneficial and respected profession is maintained. The Code of Ethics consists of 8 principles that pertain to the specification analysis, design, development, testing, and maintenance of software, and are dedicated to serving the public interest. These principles are intended for anyone who is in or related to the profession and includes engineers, mentors, instructors, managers, students, and policymakers. Here we will summarize each principle. However, the full text of each principle and its additional clarifying clauses can be found on the IEEE-CS and ACM websites. The principles in the Software Engineering Code of Ethics focus on the following topics: public, client or employer, product, judgment, management, profession, colleagues, and self. The public principle comes first because it is expected that software engineers should act primarily in accordance to positively affect the public good. This includes accepting responsibility for their work with regard to safety, fairness, accessibility, and integrity. Next, software engineers should act in the best interests of both their clients and their employers. They should act honestly and be forthright when it comes to unethical actions such as plagiarism or illegal activities. They should seek consent where necessary and appropriate and honor confidentiality. The third principle relates to the product under production. Software engineers should seek quality while keeping in mind cost and timelines. Now, this next principle outlines how software engineers act with integrity and independence in their professional judgment. They are expected to maintain objectivity and honesty when working with the software and relevant documents they are involved with. Software engineers should not engage in any inappropriate financial activities, such as bribery and double billing, nor may they accept duties that create a conflict of interest. Software engineering managers and leaders should also behave in a manner consistent with these principles where it applies to them and those they manage. They should work to minimize risk and employ security procedures. And managers and leaders should also work to ensure realistic expectations of their staff, provide just compensation, and procure intellectual property rights whenever appropriate. The profession principle describes the duty of software engineers to protect the reputation of the profession by acting with integrity and not elevating themselves at the expense of others. Software engineers should let managers, employers, and clients know they intend to act in compliance with this code of ethics and express concern over violations of the code. Similar to the profession principle, software engineers shall treat their colleagues with respect and fairness. They should encourage their peers to comply with this code of ethics and not take credit for the work of others. The final principle, focused on the software engineer themselves, reminds software engineers about the importance of lifelong learning and professional development. They should endeavor to create quality software and strive to conduct themselves in a professional manner. It should be noted that this code of ethics is not a replacement for conscientious decision-making and common sense, but it can be used as a supplemental guide. Knowing when and where to apply these principles will always be up to the discretion and wisdom of the individual. In this video, you learned that the Code of Ethics serves the public interest to hold software engineers accountable in the analysis, design, development, testing, and maintenance of software. And the 8 principles in the Code of Ethics are public, client or employer, product, judgment, management, profession, colleagues, and self.
Welcome to this course, Introduction to Artificial Intelligence. Imagine unlocking new career opportunities and gaining a competitive edge in your field just by knowing how to harness the power of artificial intelligence, or AI. AI is a must for individuals or businesses to push the boundaries of what's possible, driving success like never before. With AI revolutionizing the way we live and work, new innovations are touching our lives every day. From life-saving leaps forward in healthcare management and fraud detection and prevention in finance, to personal assistants like Siri and Alexa, autonomous vehicles, personalized experiences through Netflix and Spotify, and fresh content generated by ChatGPT in seconds, people who know how to use AI are transforming our world. If you're looking to fuel your career and transform your business, this course is your gateway to an exciting field shaping your future. According to PwC, over 70% of companies have already adopted some form of AI, and that trend is only set to increase. Whether you're a CEO, software developer, product designer, administrator, or individual just starting out in your career, AI can enable you to do your job in new, more powerful ways. Therefore, this course is for all beginners interested in knowing AI, whether professionals, enthusiasts, practitioners, or students. So if you're looking to take your career to the next level or shine out as a business innovator using AI, this course is the ideal way to begin your AI journey. This course serves as your gateway into the dynamic world of AI, where you'll deepen your understanding of its fundamental concepts and terminology. By the end of this course, you will be able to describe what AI is and explain its core concepts. You will understand how AI applications and use cases can transform our lives and work. You will also recognize the potential and impact of AI in transforming businesses and careers, and discuss the issues, limitations, and ethical concerns surrounding AI. What can you look forward to as you advance through this course? The course is divided into 4 power-packed modules. As soon as you start with the first module, you'll dive into the world of AI, looking at popular AI applications that are already in use across many industries. You'll learn about various common tools like ChatGPT, Google Gemini, Microsoft Copilot, and other applications of generative AI. You'll gain insights into virtual assistants and smart home devices that use AI to automate routine tasks to make life so much more convenient. And you'll examine how AI is reshaping various industries and sectors. In the second module, you'll immerse yourself in the core concepts of AI and build your confidence in using technical terms such as deep learning, machine learning, and neural networks. You'll look at generative AI models, including large language models or LLMs, and their capabilities. You'll explore the development and application of AI and build your understanding of various domains such as natural language processing, NLP, and computer vision. And you'll discover how advancements in these areas are driving exciting innovations that are changing how we live and work. Once you begin with the third module, you're going to discover how AI can be leveraged for content generation, data analysis, customer service, product development, and more. You're going to see how AI is already benefiting organizations through real-world use cases, and you'll be guided to work out how AI can transform your work and work environment too. Plus, you'll explore some of the most sought-after AI careers, including AI engineering, data science, robotics engineering, NLP engineering, and AI research, so you can then make an informed decision on what your next learning step should be once you've completed the course. Naturally, other aspects of AI need to be considered too. So in the 4th module, you'll look at the ethics of AI, how it is governed, and how prevalent concerns and issues surrounding the AI landscape are being addressed. You'll gain insights into aspects of AI like explainability, fairness, robustness, transparency, and privacy. And you'll investigate the different perspectives of key players and the approaches they are using to address the ethical challenges posed. To help you get your head around all these new terms and build your confidence in the subject, your learning journey will follow a series of videos and readings. You'll have fabulous opportunities to chat with your peers and connect with course staff in the discussion forum. And you'll hear from experienced practitioners through expert viewpoint videos as they share their perspectives on the concepts that you learn. You'll also participate in hands-on activities and labs that help you apply your knowledge in practice and deepen your understanding. You'll be presented with practice quizzes at the end of each lesson to help you reinforce your learning. And you'll complete a final project and graded quiz at the end of the course so you can earn your certificate. So, if you're ready to explore the world of AI and discover how your understanding of AI concepts can power your career and put you ahead of the rest of your field, you've come to the right place. Let's get started. Welcome to Introducing AI. After watching this video, you'll be able to define AI as augmented intelligence. You will also be able to discuss the types of AI based on their strengths. AI's history can be traced back to the very origins of computing. Since the days of the abacus and early calculators, humans have strived to automate mental tasks. The formal journey began in the 1950s when Alan Turing proposed the Turing test for machine intelligence, and John McCarthy coined the term artificial intelligence. Progress from early programs like ELIZA and Shardloo in the 1960s to the rise of expert systems in the 1970s, the 1980s witnessed a surge in machine learning, setting up the stage for further progress. The 1990s introduced neural networks, and the 2000s marked the ascent of deep learning. From 2010 to 2020, AI applications spread across industries, with applications like natural language processing, NLP, and computer vision. AI has continued its rapid expansion in the present decade, including advancements in deep learning models, autonomous systems, and healthcare applications. But what exactly is AI? Artificial intelligence, or AI, refers to the simulation of human intelligence processes by computer systems. It involves using algorithms and data to enable machines to perform tasks that typically require human intelligence, such as learning, reasoning, problem-solving, and decision-making. AI can range from simple automation to complex deep learning and neural networks. The Internet has revolutionized connectivity and given us faster access to more information. Distributed computing scales data processing, enabling efficiency. IoT proliferates connected devices, generating massive amounts of data. Social networking has encouraged most of us that data to be unstructured. Together, they reshape our digital landscape, accelerating information access and innovation. With augmented intelligence, information that subject matter experts need is placed at their fingertips and backed with evidence, enabling them to make informed decisions. Experts are encouraged to scale their capabilities and let the machines handle the time-consuming work. How do we define innate intelligence? Human beings have innate intelligence, which is defined as the intelligence that governs every activity in our body. This intelligence is what causes an oak tree to grow out of a little seed and a complex organism, like an elephant, to evolve from a single-celled organism. How does AI learn? The only innate intelligence machines have is what we give them. We provide machines with the ability to examine examples and create machine learning models based on the inputs and desired outputs. We do this in different ways, such as with supervised learning, unsupervised learning, and reinforcement learning, about which you will learn in more detail later. AI can be divided into categories based on strength, breadth, and application. Considering the strength of AI, it can be of 3 types: weak AI or narrow AI, strong AI or generalized AI, and super AI or conscious AI. Weak or narrow AI is AI that is applied to a specific domain. Applied AI can perform specific tasks but not learn new ones, making decisions based on programmed algorithms and training data. For example, language translators, virtual assistants, AI-powered web searches, recommendation engines, and intelligent spam filters. Strong AI or generalized AI refers to artificial intelligence capable of engaging in and performing a diverse array of distinct and unrelated tasks. It possesses the ability to acquire new skills to tackle novel challenges, achieving this by autonomously learning fresh approaches. Generalized AI is the combination of many AI strategies that learn from experience and can perform at a human level of intelligence. Its use cases include finance, human resources, information technology, research and development, and supply chain. Super AI or conscious AI extends the concept of generative AI to a more advanced level. It is an AI with human-level consciousness, which would require it to be self-aware, showing advanced cognitive abilities and developing its own thinking skills. Because we are not yet able to adequately define what consciousness is, it is unlikely that we will be able to create a conscious AI in the near future. Super AI could demonstrate capabilities beyond human intelligence in areas like healthcare, autonomous vehicles, robotics, natural language understanding, and environmental conservation. AI is the fusion of many fields of study. Computer science and electrical engineering determine how AI is implemented in software and hardware. Mathematics and statistics determine viable models and measure performance. Because AI is modeled on how we believe the brain works, psychology and linguistics play an essential role in understanding how AI might work. Philosophy, on the other hand, provides guidance on intelligence and ethical considerations. While the science fiction version of AI may be a distant possibility, we already see more and more AI involved in the decisions we make every day. Over the years, AI has proven to be useful in different domains, impacting our society in meaningful ways. In this video, you learned how AI is defined as augmented intelligence, aiming to extend human capabilities and tackle tasks beyond human and machine capabilities. You also learned that machine learning models are developed through supervised learning, unsupervised learning, and reinforcement learning. Finally, you learned how AI can be divided based on its strengths. You learned about weak or narrow AI, an AI tailored for specific domains, strong or generalized AI, an AI with diverse capabilities across unrelated tasks, super or conscious AI, an AI having human-level consciousness.
I want to share with you the story of how I got to work today. I submit to you that my drive from my home to my office used 3 forms of intelligence. The first intelligence was human intelligence. The intelligence there was the intelligence that I needed to operate the vehicle, to turn the steering wheel, to check my mirrors. The second form of intelligence was artificial intelligence. Once I got on the highway, I turned on the self-driving feature in my car. Fancy. Now the car stayed in its own lane, kept an appropriate distance from the vehicle in front, and maintained a proper speed. No input from me at all. When I got off of the highway, I used a third form of intelligence, augmented intelligence.
Augmented intelligence, well, that took the form of all the driver assist features in the vehicle. Things like collision detection to alert me if I got too close to the car in front, and blind spot avoidance to tell me if there was a vehicle alongside me as I changed lanes. Artificial intelligence, well, that is the ability for machines to perform tasks that normally require human intelligence, such as reasoning, natural communication, and problem solving. It basically replaces the need for a human. So computers are doing the work, us humans not really needed. And the artificial intelligence performs certain tasks and makes decisions, and it's incorporated into so many systems today. Now, contrast that with augmented intelligence. Now, this is where you have machines and you have humans both working together. And they're doing so to enhance each other's efforts when completing tasks. Augmented intelligence systems augment our human abilities. Things like screen readers for the blind, voice-driven navigation, or my in-car collision avoidance system. They're all examples of augmented intelligence at work. They act on our behalf in the physical world, but in a way that complements our own capabilities. So, artificial or augmented, which form of intelligence will give us the best results for a given problem? Well, to answer that, let's create a strengths matrix. So machines versus humans. Now, one thing machines are great at is ingesting large amounts of data. They can take in more data at a faster rate than any human could. And they also don't get tired, so they can just keep going and going, ingesting that data as they go. Machines are especially good at things like repetitive tasks. And to do so in a way that is reliably accurate. Unlike my spelling of repetitive. So if you need to quickly analyze a lot of data or do something over and over again with no margin for error, and then specifically artificial intelligence is really your best bet. Now, on the other hand, us humans, well, we have a few advantages too. We're very good at generalizing information. We can take a single piece of data and understand the concept that it represents. We're also very good at creativity. We can come up with ideas, we can solve problems and communicate our findings in a way that, well, machines just can't. And we have emotional intelligence too. And that's a big benefit where we can understand the reactions of others, and it's critical for tasks like customer service or caregiving. Now, augmented intelligence is really a sweet spot that combines all of these human strengths with a bit of a helping hand from our machine counterparts. By using AI to help us see and understand the world in new ways, we're able to do things that would be impossible for us humans on our own. So, which form of intelligence is best? The answer is both. And that's why I love augmented intelligence. It's how humans will continue to thrive and lead in the world. And get me to work safely.
Welcome to Introducing Generative AI and its use cases. After watching this video, you will be able to describe generative AI and its major capabilities and recognize its use cases in diverse sectors. As artificial intelligence continues to grow, generative AI emerges as an innovative frontier. While traditional AI tends to focus on analyzing data and making decisions, like recommending the songs you want to listen to or translating any language, Generative AI, or Gen AI, takes a step forward and creates new content from scratch. Gen AI is an AI technology capable of creating new and novel data, ranging from text and images to music and videos. Unlike conventional AI models, generative AI does not rely on predefined rules and patterns. Instead, it uses deep learning techniques and relies on vast datasets to generate new ideas. Generative AI can use large language models, or LLMs, for processing and generating human-like text. LLMs can perform a variety of natural language processing tasks, including text generation, translation, and summarization. Alternatively, generative AI can design and incorporate LLM into a larger, more advanced AI system to perform various advanced tasks, such as decision-making and problem-solving. Generative AI's capabilities drive its rapid integration across various aspects of our lives. Examples: it can facilitate the creation of new content in diverse formats, including text, images, videos, and audio. Generative AI is capable of human-like intelligence conversations. Through data augmentation, it allows to generate new training data, enhancing the accuracy of machine learning models. According to recent research conducted by Goldman Sachs, the use of generative AI could help the global economy grow by about 7%, which is nearly $7 trillion. The research also conveyed that generative AI could elevate productivity growth by 1.5% over 10 years. Generative AI is boosting creativity and customer experiences across diverse sectors. In marketing, it helps companies create personalized advertisements, email campaigns, or social media posts based on individual preferences and behaviors. In creative fields, generative AI can produce unique digital art, music, and video content for advertising and marketing campaigns, and generate soundtracks for films or video games. Product development is another area where generative AI is making an impact. By analyzing trends and consumer feedback, it can help to generate ideas and even optimize existing designs for better performance and cost-effectiveness. Generative AI is reshaping industries, driving innovation, and improving efficiency. In the field of healthcare and precision medicine, generative AI can support physicians by providing tailored treatments. It can also simulate surgeries and produce medical images to aid doctors in developing treatments. In gaming, generative AI can create interactive game worlds by generating new levels, characters, and objects that adapt to player behavior. In fashion, generative AI can design and produce virtual try-on experiences for customers and recommend personalized fashion choices based on customer behavior and preferences. In education, generative AI can create customized learning materials and interactive learning environments that adjust to students' learning styles and paces. In this video, you learn that generative AI is a type of artificial intelligence that can generate content across various mediums, such as written texts, images, audio, or videos. LLMs are advanced neural network architectures for processing and generating human-like text. Capabilities of generative AI include diverse content creation capabilities, human-like conversation, and data augmentation. Domain-specific use cases of generative AI are marketing, creative, and product development. Industry-specific use cases of generative AI are healthcare, gaming, fashion, and education and training.
So generative AI is all the rage. But one question I get quite frequently is, how does generative AI differ from AI that we were doing 5, 10, 20, maybe even 30 years ago? To understand that, let's take a look at AI the way it existed before generative AI. So typically the way that it worked is you started off with a repository. And a repository is exactly what it sounds like. It's just where you keep all of your information. And they can be, data in tables, rows and columns. It can be images. It can be documents, It could really be anything. It's just kind of as an organization where you keep all of your historical information or stuff. The second part is what we call an analytics platform. And in the IBM world, an example of an analytics platform is SPSS Modeler or Watson Studio. And then the third component is the application layer. So let's say you're a telco. You have all your information about the customers in the repository. And let's say you want to know which customers are likely to churn or cancel their service. So you would take that information in the repository, move it into an analytics platform. Inside the analytics platform, you would build your models. In this case, who is and isn't likely to churn or cancel their service. And then once you have those models built, you would put them in some kind of application. And the application would is where you try to prevent those people from canceling. So for example, if somebody's likely to cancel, maybe you reach out to them and try to convince them not to, or give them some kind of benefit so that they stick around as a customer. But this in itself, I wouldn't call this AI. This is more of a predictive analytics or a predictive model. To make this AI, you have to provide a feedback loop. And a feedback loop allows you to automate the process. So for example, you're a telco and you have your information on your customers, you figure out who's going to cancel, you take action through an application to try to keep them from canceling, but your models here sometimes are right or sometimes they're right, sometimes they're wrong. What the feedback loop allows you to do is to learn from that experience. So if there's situations where you predicted somebody was going to cancel and they didn't, maybe you can drill in and make your models better so that you don't make that same mistake a second time. So think of it like this: fool me once, shame on you; fool me twice, shame on me. That's what you want your AI to do. You want your AI to learn from its previous mistakes and its previous successes too. And a feedback loop allows you to do that. So this is the way that it always existed. I've been in this business for over 30 years and this predates me. But with generative AI, this whole paradigm has changed. The whole fundamental architecture and the way that we do things is different now. With generative AI, you start off with data, not from your organization, not from a repository inside the walls of your company, but you start off with data from Earth. Okay, so maybe not Earth, right? But you start off with this massive, massive, massive quantity of information about everything. That information then is used by large language models. But these large language models they're very powerful, they're very big, and they're remarkable, to be honest. But a lot of times they don't have the specifics that you need to guide you in your business. So for example, a large language model might know in general why people cancel a particular service if you're a telco. But they wouldn't have the nuances and the idiosyncrasies of why your specific customers cancel. That's when you use what's called prompting and tuning. So the prompting and tuning layer is where you take the large language models, which are very general models, and make them specific to your use case. So going back to our telco who's trying to deal with customer churn, they would have this model that's built not just on customer churn or your customers, but built on massive quantities of information that have everything in it. LLMs are derived from that massive quantity of information. Then you use this prompting and tuning layer to try to fine tune those models so that they're specific to your organization. And then the final part is you have an application layer, just like you do with traditional AI. And the application, again, is where you take the AI so that it's consumed, so that it's going to fulfill its specific purpose. And also, just like with traditional AI, you also have a feedback loop. But your feedback loop typically just goes back to the prompting and tuning part of it, because these are typically outside of your organization. So there you have it. That's why large language models or generative AI is different, because the fundamental architecture is different. And primarily, it has to do with the size and the quantity, both of the data coming in and the models being built. And these models and this data is way too big for any organization to hold in their repository. That's why we need a fundamentally different architecture. Thanks so much for your time. I hope this was helpful.
In this video, Martin and I are going to talk about AI and answer the question, are we there yet?
And stick around to the end where Jeff and I will be explaining how we use AI in our everyday lives.
So we're going to have a conversation about AI. Are we there yet? Well, so I think we're kind of there, because one definition of AI is basically the simulation of intelligent behavior in computers. And we've kind of done that. What do you think, Martin?
Yes, I would agree with that definition, but are we there yet? Absolutely not. I don't think so. And the reason I think that is because of something called AGI, which is an acronym for Artificial General Intelligence. And this really describes an AI system that is equivalent to a human and is as diverse as a human and can do anything that a human can do, at least as well or better. And I don't think we are there yet.
Okay, maybe not. So let's take a look at some examples of where we've come from and where we're going. So maybe a hypothetical.
Yeah, I've got a good one. I've got a good one. So let's just consider, I also write some numbers down here. Let's see this. If I put this up and then let's do 3, 1, 2, 5. If I could tell you in my head, just like that, the answer to that math equation, is that intelligence?
It's really impressive. It's a nice parlor trick. But you know, I've got a calculator that can do the same thing. And I'm really not ready to declare that my calculator is sentient. It's not artificially intelligent. So maybe not there yet, but it's a great example. Well, how about, I'll tell you a story from in my middle school days. My science teacher considered intelligence would be if you knew all the elements in the periodic table, where they went, what their atomic numbers were, how to spell them and their abbreviations, and you could place all of that where it belonged. And that would have been considered intelligent. Was she right?
With the greatest respect to your science teacher, I don't think that's intelligence either. I think what you've just described there is a database lookup.
Yeah.
How about then something a bit more advanced than that? Something that takes years and years to get good at, like a chess grandmaster. Now think of all of the time that you have to invest to learn, all of the patterns, all of the moves, all of the strategy. Is a chess grandmaster a real example of intelligence?
Yeah, I think most people would say somebody who is the best in the world at chess is a genius. So you would think if you're a genius, you're intelligent. But guess what? IBM did this trick in 1997 where we created a computer we called Deep Blue, and Deep Blue was able to beat the best chess player in the world handily. So that already, if that's your bar, we already passed it. Yet again, we kind of feel like we're left empty. We're still not feeling there yet. So what is the classic question, the classic problem to solve?
You're going to tell me the Turing test, right?
I am going to tell you the Turing test. That's exactly right. And what is the Turing test for those who don't know? With the Turing test, you basically have a user here, and they cannot see who it is that they are typing to. So they're typing messages back and forth. And they may be talking to another person, or they may be talking to a computer. And if it's indistinguishable when they have their communications and they can't tell if they're talking to another person or talking to a computer, then we would declare game over. The computer has achieved artificial intelligence. So if we could ever do that, then we'd be there, right?
Well, this one is a little bit disputed as to have we passed the Turing test or not. But in 2014, technically, some people say that we did, with a chatbot that simulated a 13-year-old boy.
Well, so that's setting the bar kind of low. 13-year-old boy, you and I used to be one of those. So I think maybe we want to set the bar higher. But would we consider other technologies maybe that have raised the bar further towards the Turing test?
I mean, I talk with ChatGPT daily, and sometimes I could be convinced that is a real person. So I think there have been a lot of advances in that kind of area.
I think so. I talk to ChatGPT regularly too. Nobody else will talk to me, so at least that one that hasn't failed me yet. So that's a good example. clearly the bar has been raised. If we ask the question, are we there yet or not? I feel like it's a little bit like we move the finish line every time we get close to it. As soon as we cross it, then we say, yeah, but that's not quite there yet. So we kind of had this sense of, if you look at all of these things together, we have these sort of siloed savants. We have something that's really great at arithmetic. We have something that's really great at memorization and recall, something that's great at a narrowly bounded game that is quite complex, but still has very specific rules that can be mathematically described. Or we're talking about a kind of general intelligence, emotional intelligence that would be required to pass the Turing test and things like that. So we continue to have these developments in individual areas, but putting it all together, that's your AGI.
But I think it's also worth pointing out that the development curve for AI, it just seems very recently, even this year, is just going faster and faster than ever before. And we are getting closer and closer to this idea of general intelligence, moving away from where we have everything siloed, like Deep Blue, which is deeply siloed to just chess, to now these AI systems that are really getting closer and closer to being able to accomplish much more of what we do as humans.
I think you're right. When I was in school, we talked about artificial intelligence, and it was always about something that was about 5 or 10 years away. And then 10 years later, it was another 5 or 10 years away. But I feel like we're actually narrowing the gap. In the last few years, it's been this steep curve toward what we would consider general artificial intelligence. So, are we there yet?
No, but we've never been closer.
Awesome.
Hey, Jeff, we didn't get to the bit where you tell me how you're using AI in your everyday life.
I did forget that. So, I actually have a self-driving car that brings me to work. It's basically a computer that takes me places. How about you? How do you use AI?
I realize that I'm not a very good photographer, but I'm much better at AI prompting. So I just prompt what I want in a picture and it generates a beautiful professional photograph. It's fantastic.
Great.
Welcome to AI in Daily Life. After watching this video, you will be able to identify the common use cases of AI in daily life. You will also be able to explore the benefits of AI's integration in routine activities. Have you ever wondered how your social media feed is customized to your preferences? Or how does an online store know the products you will like? Or, more interestingly, have you ever thought of temperature and lights in your home that adjust automatically? Welcome to the world of AI, where AI algorithms work to personalize your digital experience or learn your routines and preferences to provide a smart home experience. A report published on Statista.com suggests that within the last 5 years, the number of digital voice assistants being used in devices worldwide for day-to-day activities has rapidly increased from 4.2 billion to 8.4 billion units. AI is all around us. Whether providing personalized experiences, streamlining tasks with efficiency and automation, enhancing accessibility, improving day-to-day convenience, boosting safety and security, optimizing navigation routes, or enhancing healthcare facilities, AI provides numerous benefits in daily life. Let's explore a few such examples. AI makes our lives efficient and convenient by automating repetitive tasks and processes, saving time and effort in daily activities. Virtual assistants like Siri, Google Assistant, and Alexa employ AI algorithms to interpret and act upon voice instructions and help complete tasks, such as scheduling reminders, answering queries, delivering weather forecasts, and managing smart home devices. Further, in your smart home setup, AI empowers devices like thermostats, lights, and security cameras to understand user habits and preferences over time. This allows you to automate tasks such as temperature adjustments, lighting control, and security alert notifications, enhancing convenience and energy efficiency. AI uses a recommendation system to analyze vast amounts of data to provide personalized recommendations in areas such as entertainment, social media, and online shopping. Have you used streaming platforms like Netflix, Amazon Prime, or Spotify to watch movies, podcasts, or music? All these platforms offer personalized suggestions based on the user's viewing history and preferences. Similarly, social media platforms like Facebook and Instagram personalize the content based on the user's interests and past interactions. Likewise, e-commerce platforms like Amazon and eBay use AI algorithms to provide personalized product recommendations based on the user's browsing history and purchase behavior. AI-driven chatbots aid customers with their queries, and visual search technology enables them to find products by uploading images, further enhancing the online shopping experience. AI plays a significant role in enabling security across various domains with which we interact in our daily lives. These include cybersecurity, such as encryption, access control, and risk assessment; fraud detection to detect fraudulent activities in financial transactions, online payments, and identity verification; biometric authentication systems that use facial recognition, fingerprint scanning, or voice recognition; and AI-enabled video analytics, which enhances surveillance systems that monitor our investments, detect fraudulent transactions, identify credit card fraud, and prevent financial crimes. AI is transforming the healthcare sector, impacting our lives in several ways. AI chatbots and virtual assistants can provide 24/7 support, reminding you to take medication or offering basic healthcare information. AI-powered wearables, such as fitness trackers and smartwatches, monitor your heart rate, sleep patterns, and even blood oxygen levels. This data is crucial for identifying potential health risks early and monitoring your well-being. AI algorithms can help you diagnose diseases and personalize treatment plans through data-driven insights. AI is integrated into smart devices in numerous ways, enhancing user experience and functionality and making them valuable tools in our daily lives. AI enhances smartphone cameras with features like facial recognition, scene detection, portrait mode, and automatic image enhancement, enabling users to capture high-quality photos and videos effortlessly. AI-powered navigation apps utilize real-time traffic data, historical traffic patterns, and user feedback to optimize routes, estimate travel times accurately, and provide alternative routes to avoid congestion, improving the efficiency of daily commutes and travel planning. AI algorithms are utilized in keyboards and messaging apps to suggest words or phrases as you type, predict the next word in a sentence, and correct spelling and grammar mistakes, streamlining text input on mobile devices. In this video, you learn that AI's use cases and benefits in daily life are profound and multifaceted. You learned how virtual assistants and smart home devices use AI to automate routine tasks, making our lives efficient and convenient. How AI uses a recommendation system to provide personalized suggestions across various streaming, social media, and e-commerce platforms. Further, you learned how it boosts security and safeguards us against potential threats via biometric authentication and fraud detection. You also learned how AI transforms healthcare with wearables and diagnostics. Finally, you learned how AI's integration into smart devices enhances user experience and functionality. Welcome to AI chatbots and smart assistants. After watching this video, you will be able to explain how AI chatbots and smart assistants work and explore their benefits and diverse applications across industries. Have you ever booked a vacation or ordered dinner with just a few commands? AI chatbots are revolutionizing how we interact with technology by handling tasks and conversations that once required human intervention. From setting your reminders to controlling smart home devices with just a voice command, AI chatbots can significantly simplify your life. AI chatbots and smart assistants are AI-driven software programs that understand and respond to queries, provide information, and perform tasks. They use advanced algorithms and natural language processing, or NLP, techniques to understand and respond to user inputs in a way that simulates human-like conversation. As AI has advanced, chatbots have undergone a remarkable evolution from simple rule-based systems where interactions followed predefined patterns to AI-powered personal assistants. The most recent breakthrough comes with generative AI models, which enable chatbots to engage in intelligent, context-based conversations and offer personalized recommendations. Today, several chatbot platforms and smart assistants exist, each offering unique features and capabilities. Examples of some chatbot platforms include IBM Watson X Assistant, ChatFuel, Wit.ai, and more. Some popular smart assistants include Siri, Google Assistant, Amazon Alexa, Microsoft Cortana, and so on. Examples of popular generative AI chatbots are ChatGPT and Google Gemini. So, how do AI chatbots work? AI chatbots use a database of information, deep learning, machine learning, and NLP to understand the patterns in conversation. First, the chatbot analyzes your input to recognize the intent and keywords. If it is a speech input, the chatbot converts it into text and then processes it further. Once the input is processed, the chatbot uses AI algorithms and NLP engines to recognize your intent and context of the input and accordingly categorize the input to determine the appropriate response. The chatbot also analyzes previous interactions and user preferences for more relevance. Next, the dialogue management system selects the appropriate response from the chatbot's knowledge base. Meanwhile, the machine learning algorithm updates the chatbot's knowledge base with information from the current conversation. Finally, the chatbot generates the response, which can include providing information, answering questions, performing tasks, or engaging in a conversation with you to gather more information. Let's assume you want to know about the weather in your location. To provide an accurate response, the chatbot will access the Weather Application Programming Interface, or API, to retrieve the current weather forecast for your location. Some of the benefits of AI chatbots include their all-time availability, which ensures that you can access information anytime and anywhere. They offer scalability to handle large volumes of inquiries and interactions without significant overhead costs. The benefits also include providing personalized services and suggestions, as chatbots can tailor responses and recommendations based on user preferences and prior interactions. It enables natural conversation and response by utilizing NLP. Chatbots can also be trained to communicate in multiple languages, expanding their reach and effectiveness. AI chatbots have diverse applications across various industries and domains. Let's discuss some of them. In the field of customer service, chatbots handle routine inquiries and provide instant assistance. Another application is in e-commerce, where chatbots recommend products based on preferences and facilitate transactions. In healthcare, chatbots assist patients with appointment scheduling, medication reminders, and symptom assessment. Whereas in the field of education, chatbots are used for language learning and tutoring. As the chatbot industry grows, it will continue to reshape business communications profoundly. Businesses are now focused on building more human-like chatbots using machine learning and NLP. With the help of sentiment analysis, chatbots will be able to analyze whether the conversation is going well and will respond to customer emotions accordingly. Enterprises will use chatbots for internal tasks as well, like HR inquiries and IT support, automating these processes to improve work efficiency. Chatbots are also expected to automate tasks, such as processing refunds. These future trends and innovations signify an exciting era for AI chatbots, where they will become more intelligent and versatile. In this video, you learned that AI chatbots and smart assistants are AI-driven software programs that understand and respond to queries, provide information, and perform tasks. Chatbots have evolved from simple rule-based systems to AI-powered personal assistants and generative AI chatbots that are capable of complete conversations. Their benefits include all-time availability, scalability, personalized services and suggestions, natural conversations, and multilingual communication. Applications of AI chatbots span across industries, including customer service, e-commerce, healthcare, and education. Future trends in AI chatbots involve more human-like interactions, sentiment analysis, automated HR and IT support tasks, and handling processes like refunds. Welcome to the Applications of AI in Different Industries. After watching this video, you will be able to explore the use cases and real-world examples of AI in different industries. You will also be able to explain the impact and benefits of using AI in different industries. AI has been evolving like never before, and its involvement in different industries has been increasing rapidly. A recent global survey conducted by Statista.com on AI's adoption in business estimates that 23% of company chief executive officers, or CEOs, have already adopted AI in their business operations, whereas 43% plan to explore options for adopting AI in the future. Among chief medical officers, or CMOs, 32% have adopted AI, with 39% planning to explore it in the future. Imagine how a manufacturing plant deals with the challenge of unexpected machine failures, or how the reliability of critical medical equipment is ensured in the healthcare industry. Deploying AI-driven predictive maintenance systems in various industries helps detect potential failures before they occur. This further leads to minimized downtime, increased productivity, and reduced maintenance expenses, ultimately resulting in enhanced efficiency and cost-effectiveness. Let's delve into the impacts and applications of AI across diverse industries in more detail. In manufacturing, AI is a driving force behind a new era of efficiency and optimization. AI-driven robotics and automation transform production processes by handling repeated tasks and assembly. This frees up human workers for more complex and creative tasks, increasing speed, accuracy, and scalability. For instance, in BMW's manufacturing units, cobots, or collaborative robots, are used alongside humans in a shared workspace to enhance efficiency and increase productivity. AI uses an image recognition system to inspect products for defects on assembly lines, ensuring that only top-quality products are delivered to customers. This helps reduce waste and enhance customer satisfaction. AI can optimize energy consumption in manufacturing facilities by analyzing usage patterns and identifying opportunities for savings. Through smart grids and AI-driven energy management systems, AI can significantly reduce energy costs and improve sustainability. For instance, the food and beverage manufacturing industry leverages AI-powered quality control systems to inspect defects, contamination, and freshness in food products, ensuring that only safe and high-quality food items are packed and distributed. AI is a game changer in healthcare, offering innovative solutions and providing tangible benefits across various domains. As part of medical imaging analysis, AI can analyze medical images such as X-rays, MRIs, and CT scans to assist radiologists in detecting abnormalities and making diagnoses. In predictive analytics, AI systems analyze electronic health records, or EHRs, patient data, and historical trends to predict patient outcomes and identify individuals at risk of developing specific conditions. This empowers healthcare providers to anticipate and prevent diseases, resulting in more proactive and effective patient management. Moreover, AI enhances operational efficiency by optimizing the allocation of resources, streamlining scheduling, and managing supply chains more effectively. A popular use case of AI in healthcare includes drug discovery and development. AI speeds up the process of discovering drugs by examining molecular structures, predicting drug-target interactions, and simulating clinical trials. Organizations like Benevolent AI leverage AI algorithms to identify potential drug candidates for various diseases, significantly reducing the time and cost involved in the drug development process. This can lead to the discovery of novel treatments for ailments such as cancer and Alzheimer's. In the financial sector, AI is a strategic partner in revolutionizing banking, investment, and risk management. AI-powered chatbots provide personalized assistance and real-time support for banking transactions, enhancing customer experience. Investment analysis, in line with the AI algorithm, helps customers identify trends, opportunities, and risks in financial markets by processing large amounts of data. AI enables risk management strategies to become more proactive and precise, thereby predicting potential threats, mitigating frauds, and optimizing portfolio performance. Robo-advisors use AI algorithms to offer automated, algorithm-driven investment suggestions, portfolio management, and financial planning services. Have you heard of Bank of America's AI tool, Erica? To provide customers with a more convenient way to manage their finances, Bank of America leveraged AI and introduced Erica, an AI-powered virtual assistant. Erica uses AI to assist customers with various tasks, such as balance inquiries, bill payments, budgeting, fraud alerts, and financial insights. AI has also significantly impacted customer engagement, inventory management, and marketing in the retail sector. AI-powered recommendation engines analyze customers' preferences and browsing behavior to provide personalized product recommendations. For instance, Amazon.com uses AI to suggest products to customers based on past purchases and similar items viewed by other users. AI-driven demand forecasting algorithms analyze historical sales data, market trends, and external factors to predict future product demand. This enables retailers to optimize inventory levels, reduce stockouts, and minimize excess inventory holding costs. AI enables retailers to personalize marketing campaigns and promotions based on individual customer profiles and behavior. For instance, AI-driven marketing automation platforms like Salesforce Marketing Cloud use machine learning algorithms to segment customers, target them with personalized messages, and optimize campaign performance. Nowadays, entirely cashierless stores are beginning to emerge. AI-powered cashierless stores leverage computer vision and machine learning algorithms to enable frictionless retail shopping experiences. For instance, Amazon Go stores have utilized AI technology to automatically detect when customers take products from shelves and charge them through their Amazon account upon exiting the store. As AI continues to evolve, its potential for further innovation and growth is boundless. It promises transformative advancements that will reshape industries and revolutionize how we live and work. In this video, you learned about AI's transformative influence across various industries. You learned how AI-driven robotics and image recognition systems have brought a new era to the manufacturing industry, and how AI optimizes energy consumption. You also learned how AI has offered innovative solutions through medical imaging analysis and predictive analytics, and how it improves operational efficiency in the healthcare industry. Similarly, the finance industry has seen enhanced customer service and investment analysis. Finally, you learned how AI has impacted areas like customer engagement, inventory management, and marketing areas of the retail sector, and how cashierless stores have redefined retail experiences. Welcome to Generative AI Tools and Applications. After watching this video, you will be able to recognize various applications of generative AI across multiple domains and explore the integration of generative AI in industry-leading companies. Generative AI has sparked a revolution across numerous fields by enabling machines to autonomously create new content. Imagine detailed images, fascinating videos, and compelling stories, all generated by advanced AI algorithms. This powerful technology has demonstrated immense potential. Undoubtedly, language stands as the most crucial application area for generative AI. To create new content, generative AI tools are built on underlying AI models, such as large language models or LLMs. Initially, LLMs could only accept text inputs and create text outputs. When OpenAI first released ChatGPT, it was built on the text-only LLM GPT-3. However, with the development of multimodal LLMs, these models can now process multiple forms of data, including audio, images, and even videos. Now, generative AI has seen significant advancements with multimodal models. OpenAI's GPT models can now process both text and image data. They excel at solving complex problems with greater accuracy. Similarly, Google introduced two groundbreaking language models, Palm models and Gemini models, that unlocked generative AI's potential. Both of them excel in textual and linguistic tasks. While Palm models are limited to text in and out workflows, Gemini family of models has multimodal capabilities that include captioning an image, answering questions about photos, describing videos, and even discussing multimedia content. In fact, it is the foundational model that powers the functionalities of Google Gemini tool that we use today. These models and tools have provided new narratives to authors, journalists, and content creators, and this is just the beginning. Other large language models, such as Amazon's Titan models, Meta's Llama models, and Anthropic's Claude models, are revolutionizing how you create and interact with content. Generative AI has also influenced the visual arts and design sphere, empowering artists and designers with new tools and techniques for creative expression. For example, Stable Diffusion are among the most advanced in text-to-image technology. Another advancement, like DALL-E model, exhibits the ability to generate images that precisely match the input text. Did you know generative AI has contributed to the advancements in image generation? For instance, StyleGAN model is used for producing high-quality images of faces and other objects. Super resolution is another model used for enhancing the resolution of an image by increasing the number of pixels. Along with text and image generation, generative AI also facilitates the domains of voice and music generation. For instance, Murph is a platform at the forefront of AI voice generation technology, excelling in generating synthetic voices that closely replicate human speech nuances and tones. OpenAI introduced Whisper, an open-source model that enables transcription in multiple languages as well as translation from those languages into English. Did you ever imagine generating music with just a few words? AI-powered music generators can now produce a wide array of genres, from classical compositions to contemporary beats. Not just genres, but generators can tailor music to evoke specific moods, ranging from cheerful melodies to melancholic tunes. Musicians, producers, filmmakers, videographers, and businesses are all experimenting with generative AI tools at some level. Tools like JukeDeck and Amper Music use generative AI algorithms to compose original music tracks based on user input. Other than those, AIVA allows you to generate new songs in more than 250 different styles in a matter of seconds. So, whether you're a complete beginner or an experienced professional, you can use these AI tools to create your own songs. Generative AI algorithms can generate videos that closely resemble reality. These algorithms analyze human features and movements from existing data, creating characters and backgrounds that display lifelike qualities. Generative AI models can not only generate visuals, but also craft compelling stories, creating highly engaging videos. Google's Imagen Video is a machine learning model that generates high-definition videos. OpenAI Sora is another model that can create realistic and imaginative scenes from text instructions. Many popular companies are leveraging the power of generative AI. According to a recent poll conducted by Gartner, 55% of organizations, that is more than half, are in piloting or production mode with generative AI. Google utilizes generative AI in Google Photos for image enhancements, Google Duple for natural language understanding, and Magneta for music generation. Salesforce and OpenAI introduced a ChatGPT app named Einstein for its Slack platform. The app is said to leverage ChatGPT's AI technology. Adobe utilizes generative AI in Adobe Sensei, the company's AI and machine learning platform. It powers features such as automated photo editing and font recognition. Additionally, IBM has introduced Watson X, an advanced AI and data platform to help businesses create custom AI applications. It provides tools for training models, managing data, following rules, and working well with other systems. In this video, you learn that generative AI has revolutionized multiple industries, which has given rise to multiple applications. Various LLMs like GPT, Palm, and Gemini are used for text generation. Various tools such as ChatGPT and Google Gemini are based on such large language models. Generative AI also helps with image generation, with advanced models like Stable Diffusion and DALL-E. Generative AI enhances voice and music generation, creating genres and moods with tools like Murph and AIVA. Generative AI algorithms can create lifelike videos and models, like Google's Imagen Video and OpenAI Sora. You also learned that popular companies such as Google, Salesforce, Adobe, and IBM have adopted and integrated with the technology of generative AI.
Everybody is talking about generative AI, but Gen AI is a subset of the larger field of machine learning. And I'm going to give you 10 use cases of how machine learning, or ML, is used today in everyday life. And by machine learning, I'm talking about the subfields of artificial intelligence in which machines learn from data sets and past experiences by recognizing patterns and generating predictions. Now, machine learning is projected to become a $200 billion industry by 2029, but it's already very much here today. So let's get into it. Now, one aspect of machine learning that's seen huge utility is NLP, or natural language processing. That's the ability for machines to make sense of the unstructured mess that we like to call human language. So use case number 1 is customer service. Text-based queries can be handled by chatbots, which act as virtual agents that many businesses provide on their e-commerce sites. The chatbots can resolve many queries themselves, and where they can't, they can route customers to where they can find the appropriate help from a human customer service representative. ML also powers voice assistants. Things like Siri and Alexa, where first speech to text and then NLP machine learning models help understand a spoken command. That same capability is used by services like Slack and YouTube to power auto-transcription of spoken words in video content. Now, number 3 is ML and mobile apps. Where would we be without Spotify's ML models for generating song recommendations, or LinkedIn's use of ML to make employment suggestions? Your phone is likely filled with apps that call out to services running machine learning models. And actually, ML in smartphones really deserves its own category, because with the power of modern smartphones, some of that machine learning is performed directly on the device, such as computational photography to generate background blur in your selfie shots, or unlocking your phone with facial recognition, or onboard device image classification models that help you to search your photo library. Like that time I was trying to find this picture of my cat where he jumped into the dryer, ML helped me to find that without me spending a ton of time scrolling through my Photos app. Hey, the dryer wasn't actually on. Now that's an example of a needle in a haystack problem. Thousands of images, and there's only one I'm looking for, which in a way is similar to use case number 5, that is financial transactions. Now, in the US alone, there are 150 million credit card transactions every day, and the vast majority of those are legitimate. How to detect the fraudulent ones? Well, ML and deep learning are widely used in fraud detection, where financial institutions train ML models and classification algorithms to recognize suspicious online transactions and flag them for further investigation. 150 million credit card transactions every day is 1,739 every second. So this is a task that would be near impossible to perform manually. Well, did you also know that between 60 and 73% of all stock market trading is conducted by ML algorithms, and that percentage is increasing every year. All right, let's quickly knock out a couple more. So ML is used frequently in cyber security. Reinforcement learning uses ML to train models to identify and respond to cyber attacks and detect intrusions. ML informs a lot of our transportation these days. For instance, Google Maps uses ML algorithms to check current traffic conditions and determine the fastest route. And ride-sharing apps like Uber and Lyft use ML to match riders to the drivers. And ML plays a large role in filtering email messages as well, through classification of incoming messages and autocomplete responses. Now, number 9, that's healthcare. This is one example where machine learning can help augment and speed up human capabilities. Now, it's estimated that doctors evaluating mammograms miss between 30 to 40% of cancers, and the rate of false positives is even higher. ML is already helping here, where pattern recognition models are trained to classify tumors that are hard to see with the human eye. This is increasing not only the accuracy of interpreting radiology imaging, but it's also increasing the reading time of radiologists, allowing them to focus their attention on the more suspicious examinations flagged by the ML models. There are also ML successes in early lung cancer screening and finding bone fractures. Okay, one last one, and a question for you. In general, which department in an organization uses AI and machine learning the most? Well, according to Forbes, it is the marketing and sales department. Marketers use ML for lead generation, data analytics, and search engine optimization, and they often build on top of existing ML models. So, for example, consider how recommendation algorithms like those at Netflix make TV and movie suggestions as to what to watch next based on your derived tastes and interests. Well, the marketing and sales department can use those same ML models for targeted, personalized marketing campaigns tailored to those very same tastes and interests. Look, we hear so much these days about the future of AI, and in particular AGI, artificial general intelligence, that will one day match and surpass the intelligence of humans. But right now, that level of AI doesn't exist. It's theoretical. But machine learning, that's AI that is already here, and it really is very much part of our everyday lives.
Welcome to Cognitive Computing. After watching this video, you'll be able to explain the concept of cognitive computing and its core elements. You will also be able to analyze the impact of cognitive computing technologies on various industries. Remember those school textbook exercises that followed predetermined learning paths? They may lack the capability to adapt to individual learning styles. Cognitive computing is one such technology that can evaluate an individual's performance and offer personalized recommendations. It provides enhanced functionality, adaptability, and intelligence across various domains. The term cognitive involves intellectual activities such as thinking, reasoning, and problem-solving. Similarly, cognitive computing aims to create systems that mimic these human cognitive processes. It is a branch within AI that mimics human thought processes to create intelligent machines. Cognitive computing makes machines active partners, not just tools. These advanced systems do more than execute commands. They grasp your needs, anticipate your questions, and proactively deliver valuable insights. For instance, the cognitive computing system can help a bank detect fraudulent transactions, or it can be employed by a company to improve its customer support through the chatbot. When we as humans seek to understand something and to make a decision, we go through 4 key steps. First, we observe visible phenomena and bodies of evidence. Second, we draw on what we know to interpret what we are seeing to generate a hypothesis about what it means. Third, we evaluate which hypotheses are right or wrong. Finally, we decide, choosing the option that seems best and acting accordingly. Just as humans become experts by going through the process of observation, evaluation, and decision-making, cognitive systems use similar processes to reason about the information they read, and they can do this at massive speed and scale. Cognitive computing has 3 core elements: perception, learning, and reasoning. Let's see how these processes function to simulate decision-making and human-like intelligence. Perception is the basis of cognitive computing to interpret and understand the environment. The components of perception include sensing, where data, whether structured or unstructured, is gathered from various sources. Cognitive computing employs machine learning algorithms to analyze the data and extract meaningful information from the data. By analyzing patterns and trends within the data, the system gains a detailed idea of complex relationships and makes accurate predictions. This repetitive process highlights the evolving nature of cognitive computing. Some of the key benefits of cognitive computing include elevated decision-making due to the analysis of huge datasets. It improves efficiency as it saves time and resources by automating tasks. Additionally, it enables more human-like and interactive communication between machines and humans with the help of natural language processing. Cognitive computing has multiple applications, from healthcare and finance to education and entertainment. Several companies across various industries are using cognitive computing technologies to enhance their products, services, and operations. Some notable examples include IBM Watson, which uses cognitive computing in the fields of healthcare, finance, retail, and customer service. Google utilizes cognitive computing techniques in its products and services, including Google Search, Google Assistant, and Google Translate. Amazon's Alexa virtual assistant employs cognitive computing to understand and respond to voice commands, manage smart home devices, and provide personalized recommendations to users. JP Chase and Wells Fargo use cognitive computing to detect fraud, assess risk, and automate customer service. In this video, you learn that cognitive computing technology mimics human cognitive processes like thinking, reasoning, and problem-solving. The core elements of cognitive computing include perception, which refers to gathering and interpreting data from various sources, learning, which refers to using machine learning algorithms to analyze data, and reasoning, which refers to making accurate predictions and decisions based on data analysis. The benefits of cognitive computing include improved decision-making, increased efficiency, and more interactive human-machine communication. Companies like IBM, Google, Amazon, JP Chase, and Wells Fargo use cognitive computing to enhance their services and operations. Welcome to the Terminologies and Related Concepts of AI. After watching this video, you will be able to explore the key terms associated with artificial intelligence. You will also be able to explain the various key concepts of artificial intelligence. AI enables a world where machines can not only understand human language, but also predict our needs, recognize our faces, and provide safety against threats. In this age of AI, understanding the language, key terms, and related concepts of AI becomes crucial. These will not only enhance your knowledge, but also enable you to leverage AI's full potential, drive innovation, and stay ahead in your field. For instance, autonomous vehicles or self-driving cars rely heavily on AI technologies, such as machine learning, deep learning, natural language processing, and computer vision to navigate and make real-time decisions. Understanding these key terms can provide valuable insights into how these vehicles operate, their benefits, and their challenges. Before discussing various terminologies and key concepts of AI, let's begin with understanding AI. Artificial intelligence is a branch of computer science that focuses on creating systems capable of performing tasks that typically require human intelligence. AI systems will typically demonstrate behaviors associated with human intelligence, such as planning, learning, reasoning, problem-solving, knowledge representation, perception, motion, manipulation, social intelligence, and creativity. AI is categorized into narrow AI, general AI, and super AI. Narrow AI, or weak AI, performs specific tasks. General AI, also known as strong AI, possesses human-like cognitive skills and is capable of learning and adapting across various tasks, whereas super AI, or conscious AI, aims to surpass human intelligence and is currently theoretical and not yet realized. Now that you have understood what AI is, let's dive into the concept of machine learning. Machine learning is a subset of AI that uses computer algorithms to analyze data and make intelligent decisions based on what it has learned without being explicitly programmed. Machine learning algorithms are trained with large datasets and learn from examples. They do not follow rule-based algorithms. Machine learning enables machines to solve problems on their own and make accurate predictions using the provided data. Moving on, Let's discuss deep learning. Deep learning is an important concept and a specialized subset of machine learning. It uses multi-layered neural networks, known as deep neural networks, to analyze complex data and simulate human decision-making. Deep learning algorithms can label and categorize information and identify complex patterns in data. It enables AI systems to learn continuously and improve the quality and accuracy of results by evaluating the correctness of decisions. Another important concept is neural networks, a computation model inspired by the human brain's neural structure. Neural networks consist of interconnected nodes or neurons and have 3 layers. While the input layer receives and processes raw data, hidden layers perform complex computations and transform data. The output layer converts processed data into output format, producing the result. In this video, you learned how AI simulates human intelligence in machines and how it can be divided into 3 categories: weak AI for specific tasks, strong AI with human-like cognitive abilities, and super AI, which aims to surpass human intelligence. You also learned how machine learning, a subset of AI, uses algorithms to analyze data, make decisions without explicit programming, and enables autonomous problem-solving. Additionally, you learned that deep learning uses neural networks with multiple layers to analyze complex data. Finally, you learned about neural networks, a computational model consisting of interconnected nodes with 3 layers. Welcome to machine learning. After watching this video, you will be able to describe the fundamentals of machine learning and recognize its various types. Machine learning, a subset of AI, uses computer algorithms to analyze data and make intelligent decisions based on what it has learned. Instead of following rules-based algorithms, machine learning builds models to classify and make predictions from data. Let's understand this by exploring a problem we may be able to tackle with machine learning. What if we want to determine whether a heart can fail? Is this something we can solve with machine learning? The answer is yes. Let's say we are given datasets as beats per minute, body mass index, age, sex, and the result of whether the heart has failed or not. With machine learning, we can learn and create a model that, given inputs, will predict results. So what is the difference between this and using statistical analysis to create an algorithm? An algorithm is a mathematical technique. With traditional programming, we take data and rules and use these to develop an algorithm that will give us an answer. In the previous example, if we were using a traditional algorithm, we would take the data such as beats per minute and BMI and use this data to create an algorithm that will determine whether the heart will fail or not. Essentially, it would be an if-then-else statement. When we submit inputs, we get answers based on what the algorithm we determined is, and this algorithm will not change. Machine learning, on the other hand, takes data and answers and creates the algorithm. Instead of getting answers in the end, we already have the answers. What we get is a set of rules that determine what the machine learning model will be. The model determines the rules and the if-then-else statement when it gets the inputs. Essentially, what the model does is determine what the parameters are in a traditional algorithm, and instead of deciding arbitrarily that beats per minute plus BMI equals a certain result, we use the model to determine what the logic will be. This model, unlike a traditional algorithm, can be continuously trained and used in the future to predict values. Machine learning relies on defining behavioral rules by examining and comparing large datasets to find common patterns. For instance, we can provide a machine learning program with a large volume of pictures of birds and train the model to return the label bird whenever it has provided a picture of a bird. We can also create a label for cat and provide pictures of cats to train on. When the machine model is shown a picture of a cat or a bird, it will label the picture with some level of confidence. This type of machine learning is called supervised learning, where an algorithm is trained on human-labeled data. The more samples you provide a supervised learning algorithm, the more precise it becomes in classifying new data. Unsupervised learning, another type of machine language, relies on giving the algorithm unlabeled data and letting it find patterns by itself. You provide the input, but not labels, and let the machine infer qualities that the algorithm ingests unlabeled data, draws inferences, and finds patterns. This type of learning can be useful for clustering data, where data is grouped according to how similar it is to its neighbors and dissimilar to everything else. Once the data is clustered, different techniques can be used to explore that data and look for patterns. For instance, you provide a machine learning algorithm with a constant stream of network traffic and let it independently learn the baseline, normal network activity, as well as the outlier and possibly malicious behavior happening on the network. The third type of machine learning algorithm, reinforcement learning, relies on providing a machine learning algorithm with a set of rules and constraints and letting it learn how to achieve its goals. You define the state, the desired goal, allowed actions, and constraints. The algorithm figures out how to achieve the goal by trying different combinations of allowed actions and is rewarded or punished depending on whether the decision was a good one. The algorithm tries its best to maximize its rewards within the constraints provided. You could use reinforcement learning to teach a machine to play chess or navigate an obstacle course. A machine learning model is an algorithm used to find patterns in the data without the programmer having to explicitly program these patterns. In this video, you learn that machine learning is a subset of AI that uses computer algorithms to analyze data and make decisions. Unlike traditional programming, which uses fixed rules, machine learning models evolve by learning from data. There are three main types of machine learning: supervised learning, which is trained on labels to classify new data. The more samples you provide a supervised learning algorithm, the more precise it becomes in classifying new data. Unsupervised learning that finds patterns in unlabeled data. It is useful for clustering similar data points and detecting anomalies. And reinforcement learning that learns to achieve goals within a set of rules and constraints by maximizing rewards. It is applicable in tasks like playing chess or navigating obstacle courses. Welcome to the Machine Learning Techniques and Training. After watching this video, you will be able to explain the core concepts of machine learning, including supervised, unsupervised, and reinforcement learning techniques, and discuss various supervised learning tasks such as regression, classification, and neural networks. You will also be able to describe the process of training a machine learning model, including the roles of training, validation, and test data sets. Machine learning is a broad field that can be divided into three categories: supervised learning, unsupervised learning, and reinforcement learning. There are many different tasks you can solve using these categories. Supervised learning involves using data sets with predefined class labels to train models for predicting or classifying new data points. This means the data you receive includes labels indicating what each data point represents. In this example, you have a table with labels such as age or sex. With unsupervised learning, you do not have class labels, and you must discover class labels from unstructured data. This could involve deep learning, which looks at pictures in unstructured data, interprets them, and processes them, further grouping them into clusters based on their features. Reinforcement learning is a different subset, and what this does is it uses a reward function to penalize bad actions or reward good actions. Supervised learning can be split into three categories: regression, classification, and neural network. Regression models are built by looking at the relationships between features X and the result Y, where Y is a continuous variable. Essentially, regression estimates continuous values. Neural networks refer to structures that imitate the structure of the human brain to process input data, recognize patterns, and make decisions or predictions. Classification, on the other hand, focuses on discrete values it identifies. You can assign discrete class labels Y based on many input features X. In the previous example, given a set of features X, such as beats per minute, body mass index, age, and sex, the algorithm classifies the output Y as two categories, true or false, predicting whether the heart will fail or not. In other classification models, you can categorize results into multiple groups. For instance, you can predict whether a movie belongs to the genres of action, comedy, drama, or horror. Some forms of classification include decision trees, support vector machines, logistic regression, and random forests. Classification allows us to extract features from the data. The features in this example would be beats per minute or age. Features are distinctive properties of input patterns that help determine the output categories or classes of output. Each column is a feature, and each row is a data point. Classification is the process of predicting the class of given data points. Our classifier uses training data to understand how given input variables relate to that class. What exactly do we mean by training? Training refers to using a learning algorithm to determine and develop the parameters of your model. Imagine you are training a model to predict whether an email is spam or not, true for spam, false for not spam. To do this, you start by showing the algorithm some real-life emails that are labeled as true, indicating they are spam. Then, you show more emails labeled as false, indicating they are not spam. You continue this process with emails labeled as true or false. The algorithm adjusts its internal parameters until it has learned to distinguish from the data which emails are spam, that is, true, and which are not, that is, false. In machine learning, a dataset is usually divided into three parts: training, validation, and test sets. The training set is used to train the algorithm. The validation set helps to validate the results and adjust the algorithm's parameters. The test set contains data the model has not seen before and is used to assess the model's performance. You can then measure the model's effectiveness using terms like accuracy, precision, and recall. In this video, you explored the three main categories of machine learning: supervised learning, which builds models using labeled data; unsupervised learning, which discovers patterns in unlabeled data, often through clustering; and reinforcement learning, which employs a reward system to guide actions. Additionally, you learned how supervised learning is divided into regression, classification, and neural networks. Regression estimates continuous values by analyzing the input-output relationship. Neural networks imitate the human brain structure to process data, and classification focuses on discrete values by assigning class labels based on input features. Lastly, you learned how model training involves splitting the dataset into training, validation, and testing sets. The training set trains the algorithm, the validation set fine-tunes and validates it, and the testing set evaluates its performance on new data. Welcome to Deep Learning. After watching this video, you will be able to describe the fundamentals of deep learning and recognize its various applications. While machine learning is a subset of artificial intelligence, deep learning is a specialized subset of machine learning. Deep learning layers algorithms to create a neural network, which is an artificial replication of the brain structure and functionality. This enables AI systems to continuously learn on the job and improve the quality and accuracy of results. It also allows these systems to learn from unstructured data, such as photos, videos, and audio files. Deep learning, for example, enables natural language understanding capabilities of AI systems and allows them to work out the context and intent of what is being conveyed. Deep learning algorithms do not directly map input to output. Instead, they rely on several layers of processing units. Each layer passes its output to the next layer, which processes it and passes it to the next. The many layers are why it's called deep learning. When creating deep learning algorithms, developers and engineers configure the number of layers and the type of functions that connect the outputs of each other to the inputs of the next. Then they train the model by providing it with lots of annotated examples. For instance, you give a deep learning algorithm thousands of images and labels that correspond to the context of each image. The algorithm will run those examples through its layered neural network and adjust the weights of the variables in each layer of the neural network to be able to detect the common patterns that define the images with similar labels. Deep learning fixes one of the major problems present in older generations of learning algorithms. While the efficiency and performance of machine learning algorithms plateau as the datasets grow, deep learning algorithms continue to improve as they are fed more data. Deep learning has proven to be very efficient at various tasks, including image captioning, voice recognition and transcription, facial recognition, medical imaging, and language translation. Deep learning is also one of the main components of driverless cars. In this video, you learn that deep learning is a specialized subset of machine learning that layers algorithms to create a neural network. Deep learning enables AI systems to continuously learn and improve. Deep learning enhances AI's natural language understanding by grasping context and intent. Deep learning is highly effective in tasks like image captioning, voice recognition, facial recognition, medical imaging, language translation, and even driverless car technology. Welcome to Neural Networks. After watching this video, you will be able to describe neural networks and their functionality. You will also be able to recognize various types of neural networks. Imagine teaching a machine to learn in a manner like a human brain, like recognizing faces and images or driving cars independently. The mechanism behind such remarkable capabilities lies within neural networks. Neural networks are computational models influenced by the human brain's neural structure. An artificial neural network consists of interconnected nodes, known as neurons. The neurons take incoming data, like the human brain's neurological network, and learn to make decisions over time. By providing the network with data, such as images of cats and dogs, it can learn to recognize patterns and form connections. The more data it is exposed to, the more effectively it learns. A neural network consists of one input layer and one output layer. It can also have one or more hidden layers. The input layer receives the data. For example, in an image recognition task, the input layer would take in the image's pixel values. Hidden layers process the data. Each hidden layer transforms the input data by applying an activation function. Activation functions are mathematical functions that allow the network to learn complex patterns. Finally, the output layer of a neural network produces the final result of the network's processing. Note that as a network includes more hidden layers, it becomes deeper, which is why the term deep learning is used. Neural networks learn through a process called training. Let's understand the steps of this process. Firstly, as part of the forward pass or forward propagation step, the data passes through the layers of the neural network. In this step, the network computes an output. This output is compared to the actual answer to calculate the difference, called the error or loss. This step shows how well the network's predictions match the actual results. Then, in the backward pass or back propagation step, this error is sent back through the network to adjust the internal parameters, such as weights and biases. This adjustment aims to reduce the error for future predictions. The forward pass, error calculation, and backward pass are repeated many times with different sets of data until the neural network consistently makes accurate predictions. There are various types of neural networks. Let's look at some, including perceptron neural networks, feed-forward neural networks, deep feed-forward neural networks, modular neural networks, convolutional neural networks, and recurrent neural networks. The perceptron neural networks are the simplest type of artificial neural network, consisting of only input and output layers. In a feed-forward neural network, information flows in one direction, that is, forward. Each neuron in a layer receives input from neurons in the previous layer and then passes its output to neurons in the next layer. A deep feed-forward neural network is similar to feed-forward network with just more than one hidden layer. The modular neural network combines two or more neural networks to arrive at the output. A convolutional neural network, or CNN, is a type of neural network that is particularly well suited for analyzing visual data. The term convolutional refers to a mathematical operation, where a function is applied to another function and the result is a mixture of the two functions. In CNNs, this process takes place through multiple layers, with each layer performing a convolutional on the output from the previous layer. In recurrent neural networks, or RNNs, each of the neurons in hidden layers receives an input with a specific delay in time. This allows the RNN to consider the context of the input. You can use this type of neural network where you need to access previous information in current iterations. For example, it's useful in predicting the next word in a sentence, as it considers the context and flow of a conversation. In this video, you learned that neural networks are building blocks of AI systems, inspired by the structure of the human brain. Neural networks consist of layers, including an input layer, one or more hidden layers, and an output layer. Neural networks rely on forward propagation to process data from input to output layers. Backpropagation adjusts internal parameters based on the loss calculated during forward propagation. Various types of neural networks include perceptron neural network feed-forward, deep feed-forward, modular, convolutional neural network, and recurrent neural network.
Look, fair warning, if you're feeling a little hungry right now, you might want to pause this video and grab a snack before continuing, because I'm going to explain the difference between machine learning and deep learning by talking about pizza. Delicious, tasty pizza. Now, before we get to that, let's address the fundamental question here. What is the difference between these two terms? Well, put simply, deep learning is a subset of machine learning. Actually, the hierarchy goes like this. At the top, we have AI, or artificial intelligence. Now, a subfield of AI is ML, or machine learning. Beneath that, then we have NN, or neural networks, and they make up the backbone of deep learning algorithms, DL. Now, machine learning algorithms leverage structured, labeled data to make predictions. So let's build one, a model to determine whether we should order pizza for dinner. There are three main factors that influence that decision, so let's map those out as inputs. The first of those inputs we'll call X1. And X1 asks, will it save time by ordering out? We can say yes with a 1 or no with a 0. Yes, it will, so X, that equals 1. Now X2, that input says, will I lose weight by ordering pizza? That's a 0, I'm ordering all the toppings. And X3, will it save me money? Actually, I have a coupon for a free pizza today, so that's a 1. Now, look, these binary responses, 1s and 0s, I'm using them for simplicity, but neurons in a network can represent values from, well, everything to everything, negative infinity to positive infinity. With our inputs defined, we can assign weights to determine importance. Larger weights make a single input's contribution to the output more significant compared to other inputs. Now, my threshold here is 5. So let's weight each one of these. W1, well, I'm going to give this a full 5 because I value my time. W2, this was the will I lose weight one. I'm going to rate this a 3 because I have some interest in keeping in shape. And for W3, I'm going to give this a 2 because either way, this isn't going to break the bank to order dinner. Now, we plug these weights into our model, and using an activation function, we can calculate the output, which in this case is the decision to order pizza or not. So to calculate that, we're going to calculate the y hat, and we're going to use these weights and these inputs. So here we've got 1 times 5, we've got 0 times 3, and we've got 1 times 2. And we need to consider as well our threshold, which was 5. So that gives us, if we just add these up, 1 times 5, that's 5, plus 0 times 3, that's 0, plus 1 times 2, that's 2, minus 5. Well, that gives us a total of positive 2. And because the output is a positive number, this correlates to pizza night. Okay, so that's machine learning, but what differentiates deep learning? Well, the answer to that is more than 3. As in, a neural network is considered a deep neural network if it consists of more than 3 layers, and that includes the input and the output layer. So we've got our input and output, we have multiple layers in the middle, and this would be considered a deep learning network. Classical machine learning is more dependent on human intervention to learn. Human experts, well, they determine a hierarchy of features to understand the differences between data inputs. So if I showed you a series of images of different types of fast food, like pizza, burger, and taco, you could label these in a data set for processing by the neural network. A human expert here has determined the characteristics which distinguish each picture as the specific fast food type. So for example, it might be the bread of each food type might be a distinguishing feature across each picture. Now this is known as supervised learning because the process incorporates human intervention or human supervision. Deep machine learning doesn't necessarily require a labeled data set. It can ingest unstructured data in its raw form, like text and images, and it can automatically determine the set of features which distinguish pizza, burger, and taco from one another. By observing patterns in the data, a deep learning model can cluster inputs appropriately. These algorithms discover hidden patterns of data groupings without the need for human intervention, and they're known as unsupervised learning. Most deep neural networks are feed-forward. That means that they go in one direction, from the input to the output. However, you can also train your model through something called backpropagation. That is, it moves in the opposite direction from output to input. Backpropagation allows us to calculate and attribute the error associated with each neuron and allows us to adjust and fit the algorithm appropriately. So when we talk about machine learning and deep learning, we're essentially talking about the same field of study. Neural networks, they're the foundation of both types of learning, and both are considered subfields of AI. The main distinction between the two are the number of layers in a neural network, more than 3, and whether or not human intervention is required to label data.
Welcome to Generative AI Models. After watching this video, you will be able to explain the concept of generative AI models and list their various types. Who thought machines could be so creative? Generative AI models are making it possible to mimic human creativity for generating text, art, music, and video. Generative AI models are a class of AI systems that learn from large datasets by recognizing patterns and trends. By learning from the data, they use machine learning and deep learning algorithms to create new content. The design of a generative AI model changes depending on what it's designed to do and how it will be used. Some common types of generative AI models are variational autoencoders or VAEs, Generative Adversarial Networks, or GANs, autoregressive models, and transformers. VAEs work by transforming input data through encoding and decoding. They have three main parts: an encoder network, a latent space, and a decoder network. The encoder takes the input data and turns it into a simpler form called the latent space representation. It holds the key features of the data. The decoder then uses this latent space representation to create new outputs. The applications of a VAE model include image generation, anomaly detection, and so on. For example, the Fashion MNIST VAE model is used to generate and reconstruct images from the Fashion MNIST dataset, which includes different clothing items like shirts, shoes, and bags. It creates new, realistic images of clothing items based on the patterns it has learned from the data. GANs involve two neural networks, the generator and the discriminator. The generator creates new data samples, and the discriminator checks if the data is real or fake. Both networks train together. The generator tries to make data that looks real, and the discriminator tries to tell the difference between real and fake data. This process continues until the generator becomes so good at producing realistic data that the discriminator can no longer tell the difference. GANs can be used for image synthesis, style transfer, data augmentation, and so on. For example, GANs can be used in the fashion industry. A famous example is NVIDIA's Style GAN that can generate high-quality and realistic images of faces, animals, landscapes, and more. Autoregressive models create data sequentially, considering the context of earlier generated elements. These models predict the next element in the sequence based on the previous one. These models can generate sequences of data like text or music. For example, a music composition tool powered by an autoregressive model can generate new melodies. WaveNet is one of the examples of an autoregressive model that generates raw audio waveforms, producing high-quality, natural-sounding speech. Transformers are generally used in natural language processing, or NLP tasks. They consist of encoder and decoder layers, enabling the model to effectively generate text sequences or perform cross-language translations. For example, a multilingual chatbot uses transformers to understand and respond to queries in multiple languages. Large language models like OpenAI's Generative Pre-trained Transformer, or GPT family of models, and Google Gemini models are examples of transformers that can generate different creative text. Generative AI models can usually be categorized into unimodal models and multimodal models. Unimodal models process inputs and generate outputs within the same modality, whereas multimodal models handle inputs from one modality and produce outputs in a different modality. Modality refers to the type of data being processed. So, unimodal models handle one type of data, while multimodal models process multiple types of data. For instance, GPT-3 is a unimodal model that takes text input and generates text output. It can complete sentences, generate stories, or answer questions based on textual prompts. Whereas, DAL-E is a multimodal model that generates images from textual descriptions. For example, for a prompt like, "an elephant playing with a ball," DAL-E can create a corresponding image. Meta's ImageBind, another open-source multimodal AI model, processes diverse data types like text, audio, visual, and movement. Its unique ability to combine information across these modalities allows it to create art from mixed inputs. For instance, it can merge the sound of a flowing river with a cityscape visual, showcasing its versatility. As we move forward, these models will keep pushing the boundaries of creativity, revolutionizing industries, and enhancing human experiences. In this video, you will learn that generative AI models are a class of artificial intelligence systems that use algorithms to create new content. Generative AI model architectures include VAEs, GANs, autoregressive models, and transformers. VAEs use the encoder to convert the input data into latent space representation. Then the latent space captures the characteristics of data. And finally, the decoder generates outputs. GANs use the generator to generate new data samples, and the discriminator to verify the generated data. Autoregressive models create data sequentially, taking into account the context of earlier generated elements. Transformers generate text sequences or perform cross-language translations effectively. Models can be categorized into unimodal or multimodal. Unimodal models process inputs and generate outputs within the same modality, and multimodal models handle inputs from one modality and produce outputs in a different modality.
Over the past couple of months, large language models, or LLMs, such as ChatGPT, have taken the world by storm. Whether it's writing poetry or helping plan your upcoming vacation, we are seeing a step change in the performance of AI and its potential to drive enterprise value. My name's Kate Soul. I'm a senior manager of business strategy at IBM Research, and today I'm going to give a brief overview of this new field of AI that's emerging and how it can be used in a business setting to drive value. Now, large language models are actually a part of a different class of models called foundation models. Now, the term foundation models was actually first coined by a team from Stanford when they saw that the field of AI was converging to a new paradigm, where before AI applications were being built by training maybe a library of different AI models, where each AI model was trained on very task-specific data to perform a very specific task. They predicted that we were going to start moving to a new paradigm, where we would have a foundational capability or a foundation model that would drive all of these same use cases and applications. So the same exact applications that we were envisioning before with conventional AI, and the same model could drive any number of additional applications. The point is that this model could be transferred to any number of tasks. That gives this model this superpower to be able to transfer to multiple different tasks and perform multiple different functions is that it's been trained on a huge amount in an unsupervised manner on unstructured data. And what that means in the language domain is basically I'll feed a bunch of sentences, and I'm talking terabytes of data here to train this model. And the start of my sentence might be, no use crying over spilled, and the end of my sentence might be milk. And I'm trying to get my model to predict the last word of the sentence based off of the words that it saw before. And it's this generative capability of the model, predicting and generating the next word based off of previous words that it's seen beforehand, that is why that foundation models are actually a part of the field of AI called generative AI. Because we're generating something new. In this case, the next word in a sentence. And even though these models are trained to perform at its core a generation task, predicting the next word in the sentence, we actually can take these models, and if you introduce a small amount of labeled data to the equation, you can tune them to perform traditional NLP tasks, things like classification or named entity recognition, things that you don't normally associate as being a generative-based model or capability. And this process is called tuning, where you can tune your foundation model by introducing a small amount of data, you update the parameters of your model, and now it can perform a very specific natural language task. If you don't have data or have only very few data points, you can still take these foundation models, and they actually work very well in low labeled data domains. And in a process called prompting or prompt engineering, you can apply these models for some of those same exact tasks. So an example of prompting a model to perform a classification task might be you could give a model a sentence and then ask it a question. Is this sentence have a positive sentiment or negative sentiment? The model is going to try and finish generating words in that sentence, and the next natural word in that sentence would be the answer to your classification problem, so it would respond either positive or negative, depending on where it estimated the sentiment of the sentence would be. And these models work surprisingly well when applied to these new settings and domains. Now, This is a lot of where the advantages of foundation models come into play. So if we talk about the advantages, the chief advantage is the performance. These models have seen so much data, again, data with a capital D, terabytes of data, that by the time that they're applied to small tasks, they can drastically outperform a model that was only trained on just a few data points. The second advantage of these models are the productivity gains. So just like I said earlier, through prompting or tuning, you need far less labeled data to get to a task-specific model than if you had to start from scratch, because your model is taking advantage of all the unlabeled data that it saw in its pre-training when we created this generative task. With these advantages, there are also some disadvantages that are important to keep in mind. And the first of those is the compute costs. So the penalty for having this model see so much data is that they're very expensive to train, making it difficult for smaller enterprises to train a foundation model on their own. They're also expensive by the time they get to a huge size, a couple billion parameters. They're also very expensive to run inference. You might require multiple GPUs at a time just to host these models and run inference, making them a more costly method than traditional approaches. The second disadvantage of these models is on the trustworthiness side. So just like data is a huge advantage for these models, they've seen so much unstructured data, it also comes at a cost. Especially in the domain like language, a lot of these models are trained basically off of language data that's been scraped from the internet. And there's so much data that these models have been trained on. Even if you had a whole team of human annotators, you wouldn't be able to go through and actually vet every single data point to make sure that it wasn't biased, didn't contain hate speech or other toxic information. And that's just assuming you actually know what the data is. Often we don't even know, for a lot of these open source models that have been posted, what the exact data sets are that these models have been trained on, leading to trustworthiness issues. So IBM recognizes the huge potential of these technologies, but my partners in IBM Research are working on multiple different innovations to try and improve also the efficiency of these models and the trustworthiness and reliability of these models to make them more relevant in a business setting. All of these examples that I've talked through so far have just been on the language side, but the reality is there are a lot of other domains that foundation models can be applied towards. Famously, we've seen foundation models for vision, looking at models such as DALL-E 2, which takes text data and that's then used to generate a custom image. We've seen models for code with products like Copilot that can help complete code as it's being authored. And IBM's innovating across all of these domains. So whether it's language models that we're building into products like Watson Assistant and Watson Discovery, vision models that we're building into products like Maximo Visual Inspection, or Ansible code models that we're building with our partners at Red Hat under Project Wisdom, we're innovating across all of these domains and more. We're working on chemistry. So for example, we just published and released MoleFormer, which is a foundation model to promote molecule discovery for different targeted therapeutics. And we're working on models for climate change, building earth science foundation models using geospatial data to improve climate research. I hope you found this video both informative and helpful.
You've probably seen all sorts of AI terms flying around recently, and it can get a little confusing as to how they all relate to one another. Machine learning, deep learning, foundation models, and you've probably seen other terms like generative AI and large language models. So let's bring an end to the confusion and put these terms in their place. There's one thing they all have in common. They are all terms related to the field of artificial intelligence, or AI. Now, AI refers to the simulation of human intelligence in machines, enabling them to perform tasks that typically require human thinking. Now, AI in its various forms and paradigms has been around for decades. Perhaps you've heard of the chatbot called Eliza that was developed in the mid-1960s, and that could mimic human-like conversation to an extent. Now, a subfield of AI is called machine learning. So this sits within the field of AI. Now, what's machine learning? Well, it focuses on developing algorithms that allow computers to learn from and make decisions based upon data. Rather than being explicitly programmed to perform a specific task, these algorithms use statistical techniques to learn patterns in data and make predictions or decisions without human intervention. But like AI, ML, or machine learning, is a very broad term. It encompasses a range of techniques and approaches from traditional statistical methods through to complex neural networks. Now, some of the core categories within ML that we can think of are, firstly, supervised learning, where models are trained on labeled data. There's also unsupervised learning, and that's where the models find patterns in data without predefined labels. And there's also reinforcement learning, and that's where models learn by interacting with an environment and receiving feedback. Okay, so where does deep learning come in? Well, deep learning is a subset of machine learning. Goes right there. Now, that specifically focuses on artificial neural networks with multiple layers, and we can think of them looking a bit like this. So there's our nodes and all of our connections. Now, those layers are where we get the deep part from. And while traditional ML techniques might be efficient for linear separations or simpler patterns, deep learning excels at handling vast amounts of unstructured data like images or natural language and discovering intricate structures within them. Now, I do want to point out that not all machine learning is deep learning. Traditional machine learning methods still play a pivotal role in many applications. So we've got techniques like linear regression. That's a popular technique, or decision trees, or support vector machines, or clustering algorithms. These are all other types of machine learning, and they've been widely used for a long time. In some scenarios, look, deep learning might be overkill, or it just isn't the most suitable approach. Okay, so machine learning, deep learning, what else? Yeah, foundation models. Okay, so where do foundation models fit into this? Well, the term foundation model was popularized in 2021 by researchers at the Stanford Institute, and it fits primarily within the realm of deep learning. So I'm going to put foundation models right here. Now, these models are large-scale neural networks trained on vast amounts of data, and they serve as a base or a foundation for a multitude of applications. So instead of training a model from scratch for each specific task, you can take a pre-trained foundation model and fine-tune it for a particular application, which saves a bunch of time and resources. Now, foundation models have been trained on diverse data sets capturing a broad range of knowledge and can be adapted to tasks ranging from language translation to content generation to image recognition. So in the grand scheme of things, foundation models, they sit within the deep learning category, but represent a shift towards more generalized, adaptable, and scalable AI solutions. So look, I think this is hopefully looking a bit clearer now, but there are some other AI-related terms I think it's worth also explaining. And one of those is large language models, or LLMs. Now, these are a specific type of foundation model, so I've put them in this box here, and they are centered around processing and generating human-like text. So let's break it down. LLM. The first L, that's large, and that refers to the scale of the model. LLMs possess a vast number of parameters, often in the billions or even more. And this enormity is part of what gives LLMs their nuanced understanding and capability. Second L, that's for language. They're designed to understand and interact using human languages. As they are trained on massive data sets, LLMs can grasp grammar, context, idioms, and even cultural references. And the last letter, M, that's for model. At their core, they're computational models, a series of algorithms and parameters working together to process input and produce output. LLMs can handle a broad spectrum of language tasks like answering questions, translating, or even creative writing. Now, if LLMs are one example of foundation models, what are some others? Well, there's a bunch. You can think of one of those as being vision models that can see, in quotes, interpret and generate images. There are scientific models. Give that an S. And scientific models, for example, are used in biology, where there are models for predicting how proteins fold into 3D shapes. And there are audio models as well for generating human-sounding speech or composing the next fake Drake hit song. And finally, one last term that's gaining traction. We've all heard about it. It's generative AI. Now, this term pertains to models and algorithms specifically crafted to generate new content. Essentially, while foundation models provide the underlying structure and understanding, generative AI is about harnessing that knowledge to produce something that is new. It's the creative expression that emerges from the vast knowledge base of these foundation models.
Welcome to the Natural Language Processing, Speech, and Computer Vision. After watching this video, you'll be able to define natural language processing, or NLP, speech technology, and computer vision. You'll also be able to analyze their common application areas. Humans have the most advanced method of communication, known as natural language. While humans can use computers or smartphones to send voice and text messages, computers do not innately know how to process natural language. Natural language processing, or NLP, is a subset of artificial intelligence that enables computers to comprehend, interpret, and produce human language. A global survey on NLP's market size by Fortune Business Insights reveals that the current market size of USD $29.71 billion is likely to go up to USD $158.04 billion in the next 8 years, exhibiting a compound annual growth rate, or CAGR, of 23.2% within the forecast period. NLP uses machine learning and deep learning algorithms to discern a word's semantic meaning. It does this by deconstructing sentences grammatically, relationally, and structurally, and understanding the context of use. For instance, based on the context of a conversation, NLP can determine whether the word cloud is a reference to cloud computing or the mass of condensed water vapor floating in the sky. NLP systems also understand intent and emotion, such as whether you're asking a question out of frustration, confusion, or irritation. By understanding the real intent of the user's language, NLP systems draw inferences through a broad array of linguistic models and algorithms. NLP is broken down into many subcategories related to audio and visual tasks. For computers to communicate in natural language, they should be able to convert speech into text, making communication more natural and easier to process. They also need to convert text to speech, so users can interact with computers without the requirement to stare at a screen. So let's try to understand speech-to-text and text-to-speech technologies. Speech-to-text, or STT technology, changes spoken words into written text using neural networks. By analyzing voice samples and their text versions, the neural network identifies patterns in how words are pronounced. It then uses this knowledge to convert new voice recordings into the correct text. STT allows real-time transcription of voice commands, dictation, transcription services, and voice search. For instance, YouTube uses STT to provide automatic closed captioning. Virtual assistants like Siri and Google Assistant employ STT to process user commands, and search apps like Google Voice Search use STT to give responses to spoken queries. The flip side of STT is text-to-speech, or TTS, also known as speech synthesis. Let's understand how neural networks enable TTS. First, one neural network learns a person's voice by analyzing many voice samples. Then, a second neural network generates new audio and checks with the first network to see if it matches the original voice. If it doesn't, the second network adjusts the audio and tries again. This process continues until the generated voice sounds natural and matches the original. Together, STT and TTS enable seamless human-machine interaction through natural language. Translation services like Google Translate can listen to spoken language through STT, translate it, and then speak the translation through TTS. Smart home devices utilize STT to understand commands and TTS to provide feedback. NLP can also integrate STT and TTS technologies for various applications. In customer support, STT transcribes queries, NLP understands these queries and generates responses, and TTS delivers them. For accessibility, STT transcribes speech into text in real time, which is displayed on a screen or a mobile device. NLP analyzes and interprets this, converting it into comprehensible speech via TTS. When you show your face to the phone, have you wondered how your phone magically unlocks? This is made possible by facial recognition, which uses computer vision to analyze your facial image and then match it with a pre-existing one to grant access. So, what is computer vision? It is a field of artificial intelligence that empowers machines to interpret and comprehend visual data. It analyzes picture or video data to derive significant conclusions and make judgments. Computer vision is a technology that bridges the digital and physical worlds. For instance, it allows self-driving cars to understand and interpret their surroundings. Neural networks are crucial in advancing computer vision applications like image classification, object detection, and image segmentation. Image classification involves dividing images into predefined categories, like sorting products on e-commerce platforms or detecting disorders in medical images. Object detection, facilitated by algorithms such as YOLO or You Only Look Once, and faster RCNN, not only recognizes objects but also locates them within images, making it essential for areas like surveillance and autonomous vehicles. Image segmentation techniques further analyze visual content by dividing images into meaningful segments. It provides detailed labeling for each pixel, distinguishing between various object types or categories within an image. Let's now see how computer vision is beneficial in various industries. In retail, Amazon, Walmart, and Alibaba deploy computer vision for inventory management and personalized shopping experiences, optimizing operations and enhancing customer satisfaction. Manufacturing leaders like Toyota, Siemens, and Bosch integrate computer vision into production lines for quality control and automation, ensuring product consistency and efficiency. Agriculture companies, including John Deere and Monsanto, leverage computer vision for precision farming, enabling farmers to monitor crop health and optimize fields. In this video, you gained insight into how natural language processing aids computers in interpreting and producing human language, and how it uses machine learning and deep learning algorithms to understand a word's semantic meaning by deconstructing sentences grammatically, relationally, and structurally. Additionally, you learned about STT technology that transforms spoken words into written text, enabling real-time transcription for voice commands, dictation, and voice search. You learned about TTS technology, which converts written text into spoken words, and how it can be integrated with STT for seamless human-machine interaction through natural language. Finally, you learned how computer vision enables machines to understand visual data by analyzing images or videos, drawing meaningful insights, and making informed decisions.
What is natural language processing? Well, you're doing it right now. You're listening to the words and the sentences that I'm forming, and you are forming some sort of comprehension from it. And when we ask a computer to do that, that is NLP, or natural language processing. My name is Martin Keane. I'm a master inventor at IBM, and I've utilized NLP in a good number of my invention disclosures. NLP really has a really high utility value in all sorts of AI applications. Now, NLP starts with something called unstructured text. What is that? Well, that's just what you and I say. That's how we speak. So, for example, some unstructured text is add eggs and milk to my shopping list. Now, you and I understand exactly what that means, but it is unstructured, at least to a computer. So what we need to do is to have a structured representation of that same information that a computer can process. Now that might look something a bit more like this, where we have a shopping list element, and then it has sub-elements within it, like an item for eggs, and an item for milk. That is an example of something that is structured. Now, the job of natural language processing is to translate between these two things. So NLP sits right in the middle here, translating between unstructured and structured data. And when we go from unstructured here to structured this way, that's called NLU, or natural language understanding. And when we go this way, from structured to unstructured, that's called natural language generation, or NLG. We're going to focus today primarily on going from unstructured to structured in natural language processing. Now, let's think of some use cases where NLP might be quite handy. First of all, we've got machine translation. Now, when we translate from one language to another, we need to understand the context of that sentence. It's not just a case of taking each individual word from, say, English and then translating it into another language. We need to understand the overall structure and context of what's being said. And my favorite example of this going horribly wrong is if you take the phrase, the spirit is willing, but the flesh is weak, and you translate that from English to Russian, and then you translate that Russian translation back into English, you're going to go from the spirit is willing, but the flesh is weak, to something a bit more like the vodka is good, but the meat is rotten, which is really not the intended context of that sentence whatsoever. So NLP can help with situations like that. Now, the second kind of use case that I like to mention relates to virtual assistants and also to things like chatbots. Now, a virtual assistant, that's something like Siri or Alexa on your phone that is taking human utterances and deriving a command to execute based upon that. And a chatbot is something similar except in written language, and that's taking written language and then using it to traverse a decision tree in order to take an action. NLP is very helpful there. Another use case is for sentiment analysis. Now, this is taking some text, perhaps an email message or a product review, and trying to derive the sentiment that is expressed within it. So, for example, is this product review a positive sentiment or a negative sentiment? Is it written as a serious statement, or is it being sarcastic? We can use NLP to tell us. And then finally, another good example is spam detection. So this is a case of looking at a given email message and trying to derive, is this a real email message or is it spam? And we can look for pointers within the content of the message. So things like overused words or poor grammar or an inappropriate claim of urgency can all indicate that this is actually perhaps spam. So those are some of the things that NLP can provide, but how does it work? Well, the thing with NLP is it's it's not like one algorithm. It's actually more like a bag of tools, and you can apply these bag of tools to be able to resolve some of these use cases. Now, the input to NLP is some unstructured text, so either some written text or spoken text that has been converted to written text through a speech-to-text algorithm. Once we've got that, the first stage of NLP is called tokenization. This is about taking a string and breaking it down into chunks. So if we consider the unstructured text we've got here, add eggs and milk to my shopping list, that's 8 words, that can be 8 tokens. And from here on in, we are going to work one token at a time as we traverse through this. Now, the first stage, once we've got things down into tokens that we can perform, is called stemming. And this is all about deriving the word stem for a given token. So for example, running, runs, and ran, the word stem for all 3 of those is run. We're just kind of removing the prefix and the suffixes and normalizing the tense, and we're getting to the word stem. But stemming doesn't work well for every token. For example, universal and university, well, they don't really stem down to universe. For situations like that, there is another tool that we have available, and that is called lemmatization. And lemmatization takes a given token and learns its meaning through a dictionary definition, and from there it can derive its root or its lem. So take better, for example. Better is derived from good, so the root or the lem of better is good. The stem of better would be bet. So you can see that it is significant whether we use stemming or we use lemmatization for a given token. Now, next thing we can do is we can do a process called part of speech tagging. And what this is doing is, for a given token, it's looking where that token is used within the context of a sentence. So take the word make, for example. If I say, I'm going to make dinner, make is a verb. But if I ask you what make is your laptop, well, make is now a noun. So where that token is used in a sentence matters. Part of speech tagging can help us derive that context. And then finally, another stage is named entity recognition. And what this is asking is, for a given token, is there an entity associated with it? So, for example, a token of Arizona has an entity of a US state, whereas a token of Ralph has an entity of a person's name. And these are some of the tools that we can apply in this big bag of tools that we have for NLP in order to get from this unstructured human speech through to something structured that a computer can understand. And once we've done that, then we can apply that structured data to all sorts of AI applications. But hopefully this made some sense, and that you were able to process some of the natural language that I've shared today. Thanks for watching.
Can you tell us a little bit about the work you're doing with self-driving cars?
I've been working on self-driving cars for the last few years. It's a domain that's exploded, obviously, in interest since early competitions back in the 2005 domain. And what we've been working on really is putting together our own self-driving vehicle that was able to drive on public roads in the region of Waterloo last August. With the self-driving cars area, one of our key research domains is in 3D object detection. So this remains a challenging task for algorithms to perform automatically, trying to identify every vehicle, every pedestrian, every sign that's in a driving environment so that the vehicle can make the correct decisions about how it should move and interact with those vehicles. And so we work extensively on how we take in laser data and vision data and radar data and then fuse that into a complete view of the world around the vehicle.
When we think of computer vision, we usually think immediately of self-driving cars. And why is that? Well, it's because, it's hard to pay attention when driving on the road, right? You can't, both be looking at your smartphone and also be looking at the road at the same time. Of course, it's sometimes hard to predict what people are going to be doing on the street as well when they're crossing the street with their bike or skateboard or whatnot. So it's great when we have some sort of camera or sensor that can help us detect these things and prevent accidents before they could potentially occur. And that's one of the limitations of human vision is attention, is visual attention. So I could be looking at you, Rav, but behind you could be this delicious slice of pizza. But I can only pay attention to one or just some limited number of things at a time. But I can't attend to everything in my visual field all at once at the same time, like a camera could, or like how computer vision could potentially do so. And so that's one of the great things that cameras and computer vision is good for, helping us pay attention to the whole world around us without having us to look around and make sure that we're paying attention to everything. And that's just in self-driving cars. So I think we all kind of have a good sense of how that shapes, how AI and computer vision shapes the driving and transportation industry.
Well, self-driving cars are certainly the future. And there's tremendous interest right now in self-driving vehicles, in part because of their potential to really change the way our society works and operates. I'm very excited about being able to get into a self-driving car and read or sit on the phone on the way to work instead of having to pilot through Toronto traffic. So I think they represent a really exciting step forward. But there's still lots to do. We still have lots of interesting challenges to solve in the self-driving space before we have really robust and safe cars that are able to drive themselves 100% of the time autonomously on our roads.
Welcome to AI and Cloud Computing, Edge Computing, and IoT. After watching this video, you will be able to describe the basics of IoT, cloud computing, and edge computing, as well as identify their convergence for various use cases. The exciting intersection of AI, cloud computing, edge computing, and IoT brings you smart and real-time applications that change your everyday life. By transforming raw data into meaningful solutions, these technologies work for you to build a smarter and more connected future. Internet of Things, or IoT devices, are all around us in our everyday lives. For instance, fitness trackers and smartwatches that monitor health and activity levels, washing machines that can be operated remotely via smartphone apps, and even smart thermostats that learn your temperature preferences to automatically adjust heating or cooling. IoT devices are a network of physical devices connected to the internet that collect and share data for processing and analysis. These devices can be sensors, cameras, or other devices that generate data. So, how do they work? IoT devices collect data and send it via the internet to the cloud for storage and analysis. Now, cloud computing lets you store and use data and services over the internet instead of keeping everything on your computer. The main goal of cloud computing is to allow users to access and use powerful computer resources from remote data centers. So, it simply means using someone else's computer and software on the internet instead of your device and resources for computing tasks. For example, Gmail is a cloud service that lets you check your email online. Your emails are stored on the cloud, so you can access them from anywhere. So what role does AI play in cloud computing? Cloud computing gives us the space to analyze data, while AI algorithms provide smart abilities to find more detailed information in that data, do tasks automatically, and make decisions based on data. Together, they help us use data to its fullest. For example, in cloud-based email services, AI analyzes incoming emails to distinguish between spam and legitimate messages. It uses patterns and user behavior to automatically move spam mails to the junk folder. This automation improves over time as AI learns from user actions, ensuring users receive fewer unwanted emails. Not all data collected by IoT devices has to go to the cloud. Sometimes, edge computing is used, where the device processes and makes decisions locally before sending data to the cloud. This allows faster decision-making. So, what is edge computing? Edge computing refers to the practice of processing data closer to the source of generation, rather than relying on centralized data centers. One of the examples of edge computing can be a simple thermostat. Traditionally, a thermostat might rely solely on the cloud to manage your heating and cooling needs, but with edge computing, it can instantly sense the temperature and turn on the heater if it gets too cold. Edge AI is a type of AI that lives on the device itself, rather than relying on cloud. Imagine it as a mini brain built into your everyday devices. For instance, security cameras with facial recognition triggering alerts for unauthorized personnel can be one of the examples of Edge AI. So, how does the intersection of AI, IoT devices, cloud computing, and edge computing work? Let us take an example to understand. Imagine you have a fitness tracker that keeps track of your heart rate, steps, and activity level. This fitness tracker is your IoT device that collects and shares your data. With edge computing, your fitness tracker has its own power to do some tasks inside itself. It can count your steps, monitor your heart rate, and analyze this data in real time without needing to connect to the internet. For instance, if your heart rate gets too high during exercise, the fitness tracker can alert you right away and suggest slowing down. Now, this fitness tracker can use edge computing along with AI to analyze your activity level, such as recognizing when you are running versus walking, and provide instant coaching instructions. For example, based on the changes in your heart rate patterns, it can ask you to change your workout exercise. When you connect your fitness tracker to your smartphone via Bluetooth, you enable cloud computing. Your workout data and health metrics are sent to the cloud where they can be stored for a long time and can be analyzed and viewed on your smartphone app. Now, the app can use cloud-based AI to offer advanced features. For instance, it can check how you sleep and give tips to sleep better. Also, it can see your exercise data and make workouts just for you, depending on what you want to achieve. From AI-powered traffic lights and smart public transportation to smart agriculture and AI-based smart buildings, this integration works for you to make your life more efficient. In this video, you learned that IoT devices are a network of physical devices connected to the internet that collect and share data for processing and analysis. Cloud computing allows you to store and use data and services over the internet. Edge computing refers to the practice of processing data closer to the source of generation, rather than relying on centralized data center. The intersection of AI, IoT, cloud computing, and edge computing brings you smart and real-time applications. Real-world applications of AI, cloud computing, edge computing, and IoT can include AI-powered traffic lights, smart public transportation, smart agriculture, and smart buildings. Welcome to AI Agents. After watching this video, you will be able to explain what AI agents are and discuss the characteristics and types of AI agents. Additionally, you will be able to explore multi-agent systems and the various applications of AI agents. Did you know the global AI market is expected to increase to $1.8 trillion within the next 7 years, with a staggering compound annual growth rate, or CAGR, of 36.6%? According to Gartner, using AI agents in customer service will save companies around $80 billion by reducing labor costs. Understanding AI agents is crucial as it enables various businesses to use automation and data-driven decision-making, further improving efficiency, innovation, and competitiveness in the respective fields. Let's define what AI agents are. AI agents are software programs that interact with their environment, collect and process data, and perform tasks on their own to achieve the goals set by humans. They can make decisions, solve problems, and adapt to new information without needing constant human help. So, how do AI agents work? Let's take the example of a self-driving car. It includes several key phrases. Perception, where AI agents use sensors like cameras and radar in a car to gather data about the environment, spotting vehicles, pedestrians, and road signs. By understanding phase, algorithms process this data to identify objects, their speed, and movement. Then, you have decision-making, where the agent uses a knowledge base and logic and determines when to accelerate, brake, or turn. Further, in action phase, actuators execute these decisions, controlling the car's steering and brakes to navigate safely. Finally, learning phase, where the agent improves over time using machine learning, analyzing past experiences to enhance performance. For a self-driving car, this means continually learning from its driving experiences. AI agents possess several key characteristics, such as social ability, autonomy, reactiveness, and proactiveness. Social ability refers to an agent's capacity to communicate and collaborate with other agents and entities in its environment. Autonomy is the agent's ability to operate independently and make decisions without external help. Reactiveness allows agents to respond immediately to changes in their environment, while proactiveness enables them to take initiative and make decisions to achieve their objectives. Let's discuss the areas where each of the characteristics can be used. The social ability feature of AI agents is extensively used in the healthcare sector. In healthcare, chatbots use social skills to give medical advice, check symptoms, and schedule appointments and reminders. Self-driving cars use the autonomy feature to navigate roads, make driving decisions, and operate without human assistance. Reactiveness is employed in thermostats, which adjust home temperatures depending on real-time data. In industries, predictive maintenance systems use the reactiveness feature to analyze equipment data and schedule maintenance before breakdowns occur. In today's fast-changing tech world, managing and coordinating many independent systems is becoming more important. The need appears in different areas, like managing resources spread over a large area, operating smart transportation systems, and creating complex simulations. This is where multi-agent systems come in. In multi-agent systems, multiple agents work together to achieve individual and collective goals. Multi-agent systems enable distributed problem-solving, cooperative decision-making, and emergent behaviors from agent interactions. These multi-agent systems are used in various fields, including online marketplaces, robotic coordination, and traffic management. In online marketplaces, buyer and seller agents negotiate prices and manage transactions for their users, facilitating efficient and automated commerce. In robotic coordination, teams of robots collaborate on complex tasks, such as warehouse logistics or search and rescue missions. In traffic management, agents representing autonomous cars communicate to optimize traffic flow and reduce congestion. In today's digital age, tech giants employ AI agents in their services and products. Google integrates AI agents into YouTube for content recommendation and moderation, analyzing user behavior to suggest videos and manage content. Additionally, AI agents help in detecting and removing inappropriate content, enforcing community guidelines, and managing copyright issues. In Gmail, AI agents power features like Smart Compose and Smart Reply, which suggest responses based on the email's content. The AI agents also help organize emails, filter out spam, and find important messages. Google Maps uses AI agents for real-time navigation, gathering real-time data from various sources to provide accurate route recommendations, estimate travel times, and offer alternative routes to avoid traffic jams. Amazon's Alexa uses AI for voice recognition, understanding natural language, and controlling smart home devices. The Amazon.com e-commerce platform uses AI to recommend products, improve search results, and manage inventory. Amazon Web Services, or AWS, offers AI services for developers, such as machine learning models, natural language processing, and computer vision tools. As we enter a new era, AI agents are becoming more than just tools. They are partners in making strategic decisions and engaging with customers. Their impact will continue to increase. With this, you've reached the end of the video. In this video, you learn that agents in AI are software programs that engage with surroundings, process data, and autonomously carry out tasks to meet human-defined goals. You also learned about the key traits of AI agents. Social ability means agents can talk and work with others. Autonomy means they can work alone and decide things by themselves. Reactiveness lets them quickly react to changes, and proactiveness means they can take charge and make decisions to reach their goals. Finally, you learned that multi-agent systems facilitate distributed problem-solving and cooperative decision-making, and how the same can be applied in varied areas, such as online marketplaces, robotic coordination, and traffic management.
"2024 will be the year of AI agents. So what are AI agents? And to start explaining that, we have to look at the various shifts that we're seeing in the field of generative AI. And the first shift I would like to talk to you about is this move from monolithic models to compound AI systems. So models on their own are limited by the data they've been trained on. So that impacts what they know about the world and what sort of tasks they can solve. They are also hard to adapt, so you could tune a model, but it would take an investment in data and in resources. So let's take a concrete example to illustrate this point. I want to plan a vacation for this summer, and I want to know how many vacation days are at my disposal. What I can do is take my query, feed that into a model that can generate a response. I think we can all expect that this answer will be incorrect because the model doesn't know who I am and does not have access to this sensitive information about me. So they can help with summarizing documents, they can help me with creating first drafts for emails and different reports I'm trying to do. But the magic gets unlocked when I start building systems around the model and actually take the model and integrate them into the existing processes I have. So if we were to design a system to solve this, I would have to give the model access to the database where my vacation data is stored. So that same query would get fed into the language model. The difference now is the model would be prompted to create a search query. And that would be a search query that can go into the database that I have. So that would go and fetch the information from the database, output an answer, and then that would go back into the model that can generate a sentence to answer. So Maya, you have 10 days left in your vacation database. So the answer that I would get here would be correct. This is an example of a compound AI system, and it recognizes that certain problems are better solved when you apply the principles of system design. So what does that mean? By the term system, you can understand there's multiple components. So systems are inherently modular. I can have a model, I can choose between tuned models, large language models, image generation models, but also I have programmatic components that can come around it. So I can have output verifiers. I can have programs that can take a query and then break it down to increase the chances of the answer being correct. I can combine that with searching databases. I can combine that with different tools. So when we're talking about a system approach is I can break down what I desire my program to do and pick the right components to be able to solve that. And this is inherently easier to solve for than tuning a model. So that makes this much faster and quicker to adapt. Okay, so the example I used below is an example of a compound AI system. You've also might be popular with retrieval augmented generation, which is one of the most popular and commonly used compound AI systems out there. Most RAG systems, and the example I used below, are are defined in a certain way. So if I bring a very different query, let's say I ask about the weather in this example here, it's going to fail because the path that this program has to follow is to always search my vacation policy database, and that has nothing to do with the weather. So when we say the path to answer a query, we are talking about something called the control logic of a program. So compound AI systems, we said most of them have programmatic control logic, so that was something that I defined myself as the human. Now, let's talk about where do agents come in. One other way of controlling the logic of a compound AI system is to put a large language model in charge. And this is only possible because we're seeing tremendous improvements in the capabilities of reasoning of large language models. So large language models, you can feed them complex problems and you can prompt them to break them down and come up with a plan on how to tackle it. Another way to think about it is on one end of the spectrum, I'm telling my system to think fast, act as programmed, don't deviate from the instructions I've given you. And on the other end of the spectrum, you're designing your system to think slow. So create a plan, attack each part of the plan, see where you get stuck, see if you need to readjust the plan. So I might give you a complex question, and if you would just give me the first answer that pops into your head, very likely that answer might be wrong, but you have higher chances of success if you break it down, understand where do you need external help to solve some parts of the problem, and maybe take an afternoon to solve it. And when we put LLMs in charge of the logic, this is when we're talking about an agentic approach. So let's break down the components of LLM agents. The first capability is the ability to reason, which we talked about. So this is putting the model at the core of how problems are being solved. The model will be prompted to come up with a plan and to reason about each step of the process along the way. Another capability of agents is the ability to act. And this is done by external programs that are known in the industry as tools. So tools are external pieces of the program, and the model can define when to call them and how to call them in order to best execute the solution to the question they've been asked. So an example of a tool could be searching the web, searching a database at their disposal. Another example could be a calculator to do some math. This could be a piece of program code that maybe might manipulate a database. This can also be another language model that maybe you're trying to do a translation task and you want a model that can be able to do that. And there's so many other possibilities of what can do here. So these could be APIs, basically any piece of external program you want to give your model access to. Third capability, that is the ability to access memory. And the term memory can mean a couple of things. So we talked about the models thinking through the program, kind of how you think out loud when you're trying to solve through a problem. So those inner logs can be stored and can be useful to retrieve at different points in time. But also this could be the history of conversations that you as a human had when interacting with the agent. And that would allow to make the experience much more personalized. So the way of configuring AI agents, there's many ways to approach it. One of the most popular ways of going about it is through something called React, which, as you can tell by the name, combines the reasoning and act components of LLM agents. So let's make this very concrete. What happens when I configure a React agent? You have your user query. That gets fed into a model, so an LLM. The LLM is given a prompt. So the instructions that's given is, don't give me the first answer that pops to you. Think slow, plan your work, and then try to execute something, try to act. And when you want to act, you can define whether if you want to use external tools to help you come up with the solution. Once you call a tool and you get an answer, maybe it gave you the wrong answer or it came up with an error, you can observe that. So the LLM would observe the answer, would determine if it does answer the question at hand or whether it needs to iterate on the plan and tackle it differently up until I get to a final answer. So let's go back and make this very concrete again. Let's talk about my vacation example. And as you can tell, I'm really excited to go on one. So I want to take the rest of my vacation days. I'm planning to go on to Florida next month. I'm planning on being outdoors a lot, and I'm prone to burning. So I want to know, what is the number of 2-ounce sunscreen bottles that I should bring with me? And this is a complex problem. So there's a number of things to plan. One is, how many vacation days am I planning to take? And maybe that is information the system can retrieve from its memory because I asked that question before. 2 is, how many hours do I plan to be in the sun? I said I plan to be in there a lot, so maybe that would mean looking into the weather forecast for next month in Florida and seeing what is the average sun hours that are expected. 3 is maybe going to a public health website to understand what is the recommended dosage of sunscreen per hour in the sun. And then 4, doing some math to be able to determine how much of that sunscreen fits into 2-ounce bottles. So that's quite complicated, but what's really powerful here is there's so many paths that can be explored in order to solve a problem. So this makes the system quite modular, and I can hit it with much more complex problems. So going back to the concept of compound AI systems. Compound AI systems are here to stay. What we're going to observe this year is that they're going to become more agentic. The way that I like to think about it is you have a sliding scale of LLM autonomy. And the person defining the system would examine what trade-offs they want in terms of autonomy in the system. For certain problems, especially problems that are narrow, well-defined, so you don't expect someone to ask about the weather when they mean to ask about vacations. So a narrow problem set, you can define a narrow system like this one. It's more efficient to go the programmatic route because every single query will be answered the same way. If I were to apply the agentic approach here, there might be unnecessarily looping and iteration. So for narrow problems, programmatic approach can be more efficient than going the agentic route. But if I expect to have a system accomplish very complex tasks, like say trying to solve GitHub issues independently, and handle a variety of queries, a spectrum of queries, this is where an agentic route could be helpful because it would take you too much effort to configure every single path in the system. And we're still in the early days of agentic systems. We're seeing rapid progress when you combine the effects of system design with agentic behavior. And of course, you'll have a human in the loop in most cases as the accuracy is improving.
Welcome to Robotics and Automation. After watching this video, you will be able to define the term robotics and how robots work. You will further discuss how AI technologies are integrated into robotics. You will also be able to examine how robotics enable automation in various industries. Lastly, you will explore the concept of robotic process automation, or RPA, and its applications. Across the industrial world, companies are investing heavily in robotics and automation. With the advancement of technology, robots have become more capable of performing complex tasks that were previously done by humans. This shift is driven by the need for higher productivity, improved quality, and the ability to operate continuously. According to a recent global industrial robotics survey conducted by McKinsey, many industries plan to spend 25% of their budgets on automated systems over the next 4 years. Let us understand the term robotics and how it enables automation. Robotics involves designing, constructing, and operating robots, machines that can perform tasks by themselves or with some help. Robots are complex systems made up of several key components: sensors, actuators, and controllers. Sensors act as the robot's eyes and ears, gathering information about the environment. For instance, a camera sensor helps a robot navigate by capturing images and detecting obstacles, while temperature sensors ensure the robot operates within safe limits. Actuators are the robot's muscles, enabling movement and interaction with the environment. This includes electric motors, which move robotic arms and wheels, and hydraulic and pneumatic actuators, which control various parts of the robot. Controllers act as the robot's brain and run software that determines the robot's actions. For instance, in a robotic arm, the controller interprets sensor data and directs the motors to move the arm accurately. Robots use these components and work around various AI technologies, such as artificial intelligence, machine learning, and natural language processing, or NLP, to enable automation. Let's explore a few such examples. A robot vacuum cleaner uses AI to clean your home efficiently. It has sensors to detect dirt, walls, and furniture, and an AI controller to map your home and choose the best cleaning path. The actuators adjust the vacuum's wheels and brush to clean surfaces, such as carpets and hardwood floors. A smart lawnmower uses machine learning to mow your lawn efficiently. It has sensors to detect grass height, obstacles, and lawn boundaries. The controller learns the lawn's layout and grass growth patterns to optimize mowing routes and schedules. The actuators adjust the mower's wheels and blades to ensure an even cut. A voice-activated smart speaker robot uses NLP to understand and respond to your spoken commands. It has microphones as sensors to capture your voice, an NLP controller to process and understand language, and actuators to perform actions like playing music, providing updates, or controlling smart home devices. Did you know that these devices act as self-operating robots that do not need human intervention, as they can figure things out on their own? Let's discuss more such examples. Space exploration and deep-sea exploration find use of self-operating robots. Space rovers, like the ones on Mars, explore other planets, collect valuable information, and send it back to Earth all by themselves. Similarly, underwater drones explore deep parts of the ocean, collect samples, and do research in places that are hard for people to reach. Robots working directly alongside humans are known as cobots or collaborative robots. Unlike traditional robots, cobots are designed to interact directly with people, making automation more accessible and versatile. Cobots are equipped with advanced sensors and AI technologies, allowing them to communicate and coordinate their actions to complete tasks that require teamwork. For instance, in automobile manufacturing, one cobot can hold a part in place while the other welds it, ensuring precision and speed. In logistics, cobots can work together to sort and move packages efficiently. Robotics uses AI to enable automation in many industries. In healthcare, surgical robots perform precise operations, reducing recovery times and improving patient outcomes. Rehabilitation robots help patients recover mobility and strength, offering personalized therapy. Agriculture robots plant, harvest, and monitor crops with precision, boosting yields and reducing waste. They optimize irrigation, apply fertilizers accurately, and monitor crop health in real time. In retail, self-checkout kiosks and robots manage inventory and assist customers, streamlining operations and improving customer service. This reduces wait times and ensures stock availability. Let's now discuss another concept called Robotic Process Automation, or RPA. RPA is a type of computer software that helps create, use, and control virtual robots. These robots act like humans when they work with digital systems and software. A Pegasystems survey among 500 decision makers employing a range of RPA solutions revealed 63% view RPA as a major component of overall digital transformation. 23% said it is the most important component, whereas 14% said it is a minor component. RPA can automate repetitive and rule-based tasks across various industries. In finance and accounting, RPA automates invoice processing by capturing, validating, and posting invoices. It also manages payroll calculations, deductions, and payments, and generates financial reports by extracting data from multiple sources. In human resources, RPA streamlines employee onboarding by collecting documents, entering data, and setting up profiles. Leave management by handling leave requests and updating records. Recruitment by screening resumes, scheduling interviews, and sending communication. In this video, you learn that robotics involves designing, constructing, and operating robots to perform tasks with or without humans. It utilizes sensors to observe processors for decision-making, actuators for movement, integrating technologies like AI, machine learning, and NLP for automation. Further, you learned about cobots, which collaborate with humans using advanced sensors and AI, communicating and coordinating tasks that require teamwork. Lastly, you learned that robotic process automation, or RPA, automates repetitive tasks and helps create, use, and control virtual robots. Welcome to Transforming Businesses Through AI. After watching this video, you will be able to recognize how AI is transforming business operations and identify how various industries use AI to improve efficiency. AI is the game changer that is revolutionizing business operations with smart workflow automation, powerful data analysis, and efficient decision-making. This transformation is helping companies achieve new levels of success and stay competitive in fast-paced markets. Accenture predicted that AI in business operations would double workforce efficiency and boost profitability by an impressive 38% over the next 10 years. Organizations handle a wide array of tasks on a daily basis. AI automates repetitive tasks like data entry, scheduling, and report generation, allowing employees to focus more on creative and strategic work. Depending on which tasks you're looking to automate, a wide range of AI tools are available. For example, in customer service, AI chatbots understand natural language and customer sentiment to offer personalized support, helping businesses resolve issues faster and making customers happy. AI chatbots are also more budget-friendly than human agents, saving businesses money. Take AirHelp, for example. This global service uses AI to assist airline passengers with flight statuses, delivering speedy and cost-efficient customer service that boosts satisfaction and strengthens their brand reputation. In recruitment, AI tools analyze resumes and video interviews to find the best candidates. This helps businesses to fill positions faster, reduce productivity gaps, and ensure quality hires. Hilton's AI chatbot accelerates hiring by answering candidates' questions and scheduling interviews, saving HR's time and potentially lowering costs. In accounting, AI platforms automate payroll and auditing. This helps businesses in reducing the risk of human error in manual processes, leading to enhanced accuracy. For instance, EY has transformed auditing using AI to evaluate fraud risks and spot hidden patterns. So, EY can catch financial misstatements early, keeping clients and investors safe and sound. AI allows businesses to make informed decisions by swiftly analyzing large data volumes. It identifies patterns and trends that help to predict outcomes based on the history of data. This leads to fewer errors. AI-driven tools offer real-time analytics and dashboards, helping organizations monitor performance and identify improvement opportunities. In marketing and sales, AI tools analyze purchasing patterns and suggest items based on customer purchases and browsing history. This boosts sales and conversions, leading to higher customer satisfaction. Amazon uses AI for personalized recommendations and inventory management. This reduces the risk of stockouts and ensures they have the right products in stock, ultimately boosting sales and customer satisfaction. In manufacturing, AI tools aid in predictive maintenance by using sensors and data analysis to monitor equipment, preventing costly breakdowns. This allows businesses to schedule maintenance proactively and avoid catastrophic equipment failures. For instance, BMW uses AI to inspect parts on the production line, quickly spotting quality issues. This helps BMW produce higher quality cars more efficiently. Similarly, in healthcare and research, AI accelerates drug discovery and development by analyzing medical data, helping businesses develop successful drugs faster. For example, IBM's healthcare technology uses AI to analyze large volumes of medical data, providing insights for genomic analysis and disease diagnosis. This attracts new clients and strengthens IBM's reputation in the healthcare industry. AI is enhancing creativity in businesses by generating innovative ideas and overcoming creative blocks. This helps businesses resonate with their target audience, leading to higher engagement and increased sales. For example, in design and marketing, AI helps designers create personalized and user-friendly designs through exploration, leading to happier customers and increased sales. Canva's magic design feature suggests layouts, color schemes, and fonts based on content type and user preferences. This enhances their user experience and keeps people engaged with Canva. These capabilities are just a glimpse of the many ways AI is utilized in business. From creating operational efficiency and elevating customer experience to achieving significant cost savings, the benefits of AI are far-reaching. In this video, you learn that AI automates repetitive tasks for businesses, like data entry, scheduling, and report generation, and allows employees to focus more on creative and strategic work. AI enables businesses to swiftly analyze large data volumes by identifying patterns and trends, leading to fewer errors and better predictions. AI generates innovative ideas and overcomes creative blocks by helping businesses resonate with the target audience, leading to higher engagement and sales. Welcome to the video on the rise of generative AI for business. After watching this video, you will be able to recognize the transformative impact of generative AI on businesses and identify its practical applications in various business contexts. Businesses are hitting remarkable milestones and transforming technology and its application by harnessing generative AI. Let's see what some experts have to say about generative AI.
Arthur C. Clarke famously said that any sufficiently advanced technology is indistinguishable from magic. And perhaps the first time that you played with generative AI, it did evoke a sense of magic. Suddenly, for the first time in our history, we have technology that can speak our languages, understand our requests, and produce entirely novel output. AI can write poetry and draw otherworldly images. It can write code. It can surprise and delight us with an original joke or musical composition. It can create, and an act of creation often inspires wonder. AI isn't just about the digital world. It's also about the physical world. Applied properly, imagine what AI can do for the pace of discovery and innovation. What it can do for discovering new materials, for medicine, for energy, for climate, and so many of the pressing challenges that we face as a species. Ultimately, our success depends on how we approach AI.
A survey by JP Morgan indicates that investors predict the highest generative AI technology adoption in marketing at 28%, followed by legal services and insurance at 21%, media at 20%, data analytics at 18%, and consumer technology at 13%. This indicates significant transformations ahead for these industries. In the modern business landscape, companies are constantly grappling with the need to be more efficient, innovative, and customer-centric. So let's explore some key areas in businesses where generative AI is making contributions. Businesses often face the constant need for latest content, be it marketing material, product descriptions, or social media posts. Generating high-quality content can be time-consuming and resource-intensive. Here, generative AI platforms step in as game changers as they can analyze the target audience data to create unique and engaging content. This helps organizations overcome creative blocks and maximize their reach and impact among the audience. For example, Presardo, a generative AI platform, helped Vanguard boost their sales conversion rates by 15%. Vanguard leveraged Presardo to find the perfect phrases that captivate customers and crafted messages with the right emotion and action. This enabled them to deliver impactful content and seamlessly integrate data-driven insights into their marketing strategy. Another challenge is that businesses gather enormous amounts of data, but transforming this information into actionable insights can be overwhelming. Generative AI analyzes complex data sets to identify hidden patterns and generate reports translating data into actionable insights. According to a survey by Deloitte, employees leveraging generative AI save 1.75 hours daily, which equates to a full workday each week. For example, Salesforce integrated generative AI capabilities into its CRM platform to analyze customer data and enhance sales and marketing strategies. This helped their sales team identify leads, predict customer behavior, and personalize interactions to improve conversion rates. Traditional customer service can be frustrating for both customers and agents. Repetitive tasks like answering questions or basic troubleshooting hinder their ability to address complex issues. Generative AI-powered chatbots can handle repetitive tasks, providing fast and personalized answers to frequently asked questions. Additionally, AI can analyze customer data and suggest real-time troubleshooting steps, empowering agents to resolve issues efficiently. For example, Sephora is leveraging generative AI capabilities to deliver personalized beauty recommendations. When a customer shops at Sephora, their preferences, purchase history, and even skin tone and concerns are logged into a database. Generative AI helps process this data to craft personalized emails that suggest products specifically recommended for that customer. Product development teams often struggle with limited design options and the slow, iterative prototyping process. Generative AI models can produce multiple variations, enabling companies to shortlist the most appealing options. Nike, for instance, uses generative AI to innovate its product design process. By feeding data on materials, biomechanics, and fashion trends, it helps generate numerous design possibilities. Not only big companies, but also startups are leveraging the potential of generative AI. Young startups often struggle with limited resources and tight budgets. Creative content development and product designs can be a significant expense for them. With the help of generative AI technology, the team members need not focus on mundane and repetitive tasks, but on strategic planning and refinement. Along with cost effectiveness and increased efficiency, the early adoption of generative AI also provides a competitive advantage to startups. For example, Stitch Fix, a full-stack startup, uses Gen AI to help stylists interpret customer feedback and provide product recommendations. While these are just a few examples, the possibilities with generative AI are constantly evolving. As it matures, the benefits will likely become even more significant. The focus is now on practical ways to use generative AI while addressing its challenges, leading to more sustainable, responsible, and creative applications in various industries. In this video, you learned that businesses are leveraging generative AI in several key areas. Some of them include content generation, where generative AI can create high-quality content, such as marketing materials, product descriptions, and social media posts. Data analysis, where generative AI identifies patterns and generates actionable insights. Customer service, where generative AI-powered chatbots handle repetitive tasks and provide personalized answers, improving customer satisfaction. And product development, where AI models generate multiple design variations, streamlining the prototyping process. Finally, you learn that startups are also leveraging generative AI as it helps with cost effectiveness and increased efficiency and innovation.
When oxygen, heat, and fuel combine, we get fire. It's basic, it's primal, and is the key that unlocked human progress. Fire provided light and heat and protection. With fire, our ancestors could move to new climates and eat new foods. Pottery, metallurgy, chemistry, rapid transportation, and many other technologies all start with fire. But imagine if fire had been proprietary. What if that knowledge hadn't been shared? What if there had been just a few keepers of the fire? What would we be? My name is Darío Gil, and I'm Senior Vice President at IBM and the Director of IBM Research. We are in a landmark moment now with generative AI that will shape our society for generations to come. Chances are you're already an AI user. Even if you don't have a formal AI initiative or an AI team in place, it's already in use across your business. It might be baked into your off-the-shelf applications. It may show up in chatbots, in HR self-service portals, and transcription services. These are what we might call traditional AI. The focus is on executing discrete tasks, and usually each instance is trained individually on its own data that you had to compile and label. Now, what makes generative AI different is that it is enormously flexible. and not limited to narrow tasks. Think of it as, instead of filling specific blanks, it can write the whole document from scratch, to the point of being able to create or generate something entirely new. What makes this possible are foundation models. Foundation models aren't trained the same way as traditional AI. They're trained using self-supervised learning. You don't have to manually annotate a massive amount of data. You tell them to go read enormous amounts of text, and they do. And you end up with a large but versatile model with more human-like language capabilities. Algorithms use mathematical models to represent the relationships between the words they ingest. If you give the model a few words in a prompt, it can mathematically predict the likelihood of words in the response. Instead of needing to build one AI model for each specific task, you can train one model and adapt it to many varied downstream tasks. So we went from one task, one model, to one model, many tasks. Your chatbot and your HR self-service can be built on the same model as the new app that will write your marketing emails and summarize legal documents. So that's the first critical point. Ideally, a model isn't the final form of AI, it's just the foundation you build on. How you use it is up to you. When it comes to using AI, there are basically three modes of consumption. The first is embedded AI and is baked into off-the-shelf software. The software vendor creates the AI, and you put it to use in your business. Whether it's a writing assistant that can help you strike the right tone in your email, or image editing software that can automatically process your images, you get access to some great functionality that can make you more productive, which we always want. But the caveat is that what you can buy, so can everybody else. Those capabilities and productivity opportunities don't become differentiators. They set a new, higher baseline for everyone. The second mode of consumption is through API calls. As you develop custom applications for your business, they can call out to another company's AI service using that company's models and processes and then return the results. This is also a viable way of consuming AI. Depending on how cleverly you use the APIs and the diversity of AI service providers you use, you can start to differentiate how you put AI to work relative to your competitors. But there are caveats here too. The first is that, like with software, the models and services you tap into are available to everyone. The second is that when that API call goes out, it's connecting to what looks like a black box. You don't necessarily know what's happening on the other end, or the provenance and governance of the data used, which can make people nervous because your business is still accountable for the final outcomes. And a second word of caution when using someone else's AI has to do with the creation and accrual of value over the long term. In the past, we've seen a lot of value extractive business models. Another company will offer you a service like this API call, and you get value from that. But the other company is also extracting value from your usage and from your data, accumulating more and more. How much faster is their value growing than yours? Well, you can see it in the stock prices over time. There is an imbalance in the relationship that can have long-term consequences both for your specific business and for the overall economy and progress of technology. The third model of AI consumption is the platform model. This is the most comprehensive. This is how you become your own AI fire starter. And no, it doesn't mean doing it alone and reinventing AI from scratch and spending years and millions of dollars to build your own models. With a platform, you have all the elements and ingredients in place to build your own AI solutions. You have foundation models, you have tools to improve and customize models, and you have processes to build your own tailored AI solutions. And, importantly, you create and accrue value that is unique to your business. Ultimately, I believe that most businesses should end up with a mix of all three. You'll use third-party software with AI embedded, Sometimes it'll be totally appropriate to use someone else's AI. But to fully realize the value of AI and to differentiate yourself from competitors, you'll want a platform approach to create and own your AI. Let me just go a bit deeper on AI value creation, starting with foundation models. Foundation models are large-scale deep neural networks trained with lots of unlabeled data and subsequently adapted to many downstream tasks. It may be a broad general model, or it may be a narrower, deeper model. But the key is that it is pre-trained with the expectation that you can further enhance it with your own proprietary data. Like when a new employee joins your business, they come in with some general skills as a foundation and the ability to learn. The more they learn about your business, the more they add institutional knowledge and expertise, the more value they deliver. Well, the same is basically true of a foundation model. You use your AI platform to tune it with your specific business data, your proprietary knowledge and expertise, and it becomes more expert and more valuable for your business over time. And because you're in control of the platform and the processes and the data, you accrue ever larger amount of value over time. With some of the consumer AI on the market, we've already seen some of what happens when you surrender that control. You can get bad data that leads to bad outcomes. You can get hallucinations, basically AI generating very confident and very incorrect answers. You can get into some trouble for inadvertently using someone else's rights-managed content. We've even seen proprietary or sensitive data being inadvertently leaked back into the public spaces. That's why you need to know how your model is built and what data was included. And it's why tight control of your sensitive data should be prioritized. Strong AI governance is absolutely critical. Yes, now it is the time to jump into AI, but please look before you leap in and ensure that you're investing in a smart, safe, and sustainable approach where your business and your clients and customers are the primary beneficiaries. There is, I think, a myth about AI right now, a basic misunderstanding. For the general public, generative AI has seemingly come out of nowhere. A lot of people think that there is a handful of consumer-oriented AI experiences out there and that one model is going to win or just a few leaders. I don't think that that's how it's going to play out. The future of AI is not about one model. It's multi-model. Your business will be using multiple fine-tuned models to achieve the best results when applied to specific use cases. That's why the platform approach is so important. And realistically, the future of AI is not only proprietary. It will also be powered by open science and open source. Proprietary models will play a part, but so much of what is going to happen in the future will not happen behind closed doors. It will play out in plain view with full transparency and accountability that open source provides. The energy in the open source community is phenomenal. There are distributed projects, university projects, corporate efforts, all driving innovation, producing foundation models that you can tune and deploy for your use cases. Hugging Face is like GitHub for foundation models, and there are over 325,000 open source models available, and thousands more being added. And this is exactly how it should be. For the good of society in the long term, we don't want just one or a few winners, a few companies that can define what AI is and dictate how it's used. But that's not going to happen. What we're going to see is the democratization of AI. Okay, so I've talked about a lot of different topics, and I basically told you that you have a lot of work to do to be great at AI. And maybe that feels overwhelming. But really, that's not my intention. My goal is to take down barriers to participation, not put them up. There is a sense of urgency and fear about waiting too long and missing the moment. That's okay. I assure you that everybody is in the same situation, feeling the same emotions. But I promise that if instead of rushing into fast and easy options to check the box and say, yes, I've put AI in the business, if instead you're thoughtful and deliberate and strategic about an AI platform and data management and AI governance, if you become an AI value creator, you're going to be in a position to succeed over the long term. And you won't have to start over every time the wind changes direction. You may not have all the products and processes you need today. You may not have all the skills in place. That's fine. If you're not ready to start alone, find a partner that you can trust and get to work so that you can take advantage of the extraordinary opportunities that generative AI will unlock for your business. Personally, I'm very excited about this chapter in technology. We, all of us together, are going to use AI to reshape not just our digital world, but our physical world. We are going to use it to help tackle some of our toughest social, medical, environmental problems, and more. We'll do it through science, but also by empowering businesses like yours and mine to do more, faster, and more responsibly. Whatever things you do, you're going to get a powerful new tool to help you do them better. And it's the AI value creators that will be the ones who make the biggest impact. It is the value creators who will take the amazing foundational technology that is generative AI and use it to build entirely new solutions. That's why it is our goal to make AI accessible to everyone, to put it in your hands. And I can't wait to see what you will do with it.
Large language models, they are everywhere. They get some things amazingly right and other things very interestingly wrong. My name is Marina Danilevsky. I am a senior research scientist here at IBM Research, and I want to tell you about a framework to help large language models be more accurate and more up-to-date. Retrieval Augmented Generation, or RAG. Let's just talk about the generation part for a minute. So forget the retrieval augmented. So the generation, this refers to large language models, or LLMs, that generate text in response to a user query referred to as a prompt. These models can have some undesirable behavior. I want to tell you an anecdote to illustrate this. So my kids, they recently asked me this question. In our solar system, what planet has the most moons? And my response was, oh, that's really great that you're asking me this question. I loved space when I was your age. Of course, that was like 30 years ago, but I know this. I read an article, and the article said that it was Jupiter and 88 moons. So that's the answer. Now, actually, there's a couple of things wrong with my answer. First of all, I have no source to support what I'm saying. So even though I confidently said, I read an article, I know the answer, I'm not sourcing it. I'm giving the answer off the top of my head. And also, I actually haven't kept up with this for a while, and my answer is out of date. So we have two problems here. One is no source, and the second problem is that I am out of date. And these, in fact, are two behaviors that are often observed as problematic when interacting with large language models. They are LLM challenges. Now, what would have happened if I'd taken a beat and first gone and looked up the answer on a reputable source, like NASA? Well, then I would have been able to say, okay, so the answer is Saturn with 146 moons. And in fact, this keeps changing because scientists keep on discovering more and more moons. So I have now grounded my answer in something more believable. I have not hallucinated or made up an answer. Oh, and by the way, I didn't leak personal information about how long ago it's been since I was obsessed with space. All right, so what does this have to do with large language models? Well, how would a large language model have answered this question? So let's say that I have a user asking this question about moons. A large language model would confidently say, okay, I have been trained, and from what I know in my parameters during my training, the answer is Jupiter. The answer is wrong, but, we don't know. The large language model is very confident in what it answered. Now, what happens when you add this retrieval augmented part here? What does that mean? That means that now, instead of just relying on what the LLM knows, we are adding a content store. This could be open, like the internet. This could be closed, like some collection of documents, collection of policies, whatever. The point, though, now is that the LLM first goes and talks to the content store and says, hey, can you retrieve from me information that is relevant to what the user's query was? And now, with this retriever-augmented answer, it's not Jupyter anymore. We know that it is Saturn. What does this look like? Well, first, user prompts the LLM with their question. They say, this is what my question was. And originally, if we're just talking to a generative model, the generative model says, oh, okay, I know the response. Here it is. Here's my response. But now, in the RAG framework, the generative model actually has an instruction that says, no. First, go and retrieve relevant content. Combine that with the user's question, and only then generate the answer. So the prompt now has 3 parts. The instruction to pay attention to the retrieved content, together with the user's question, now give a response, and in fact, now you can give evidence for why your response was what it was. So now hopefully you can see, how does RAG help the 2 LLM challenges that I had mentioned before? So first of all, I'll start with the out-of-date part. Now, instead of having to retrain your model if new information comes up, like, hey, we found some more moons, now it's a Jupiter again, maybe it'll be Saturn again in the future, all you have to do is you augment your data store with new information, updated information. So now the next time that a user comes and asks the question, we're ready. We just go ahead and retrieve the most up-to-date information. The second problem, source. Well, the large language model is now being instructed to pay attention to primary source data before giving its response, and in fact now being able to give evidence. This makes it less likely to hallucinate or to leak data because it is less likely to rely only on information that it learned during training. It also allows us to get the model to have a behavior that can be very positive, which is knowing when to say, I don't know. If the user's question cannot be reliably answered based on your data store, the model should say, I don't know, instead of making up something that is believable and may mislead the user. This can have a negative effect as well, though, because if the retriever is not sufficiently good to give the large language model the best, most highest quality grounding information, then maybe the user's query that is answerable doesn't get an answer.
Welcome to Adopting AI in Your Business. After watching this video, you will be able to explain the key benefits of adopting AI in business operations. You will also be able to explore how businesses can effectively integrate artificial intelligence into their operations. Finally, you will also be able to describe the general steps to adopt AI in your business. AI is transforming business operations across industries, be it helping them surpass competitors, improve customer interactions, or develop new ideas. AI adoption helps create new opportunities for efficiency and growth. From e-commerce giants leveraging AI for personalized recommendations to various manufacturing firms using AI-powered robots, the possibilities are endless. Adopting AI in businesses offers several benefits. AI increases efficiency by automating repetitive tasks, freeing employees for higher-value work. It analyzes vast amounts of data to predict market trends and consumer behaviors, enhancing decision-making. It personalizes customer service through data-driven recommendations, boosting satisfaction. Finally, AI accelerates innovation, allowing businesses to create unique offerings and stand out from the competition. A recent global study conducted by Tata Consultancy Services found that more than 8 out of 10, or 86% of senior business leaders worldwide, have adopted AI to boost their current revenue streams or generate new ones. Let's delve into real-world examples of companies benefiting from AI adoption. Amazon utilizes AI across various aspects of its business operations. Amazon's recommendation engine uses AI algorithms to analyze user browsing history, purchase patterns, and demographic data to recommend products meeting customer preferences. This personalized system boosts sales and enhances customer satisfaction by reducing search times for relevant products. Amazon's AI-powered voice assistant, Alexa, uses natural language processing, or NLP, and machine learning to handle voice commands, enabling users to place orders, control smart home devices, and access information hands-free. Amazon uses AI in its supply chain to optimize its inventory and warehouses. AI-powered forecasting models analyze historical data and external factors to predict product demand, optimize inventory levels, minimize stockouts, and streamline logistics, thereby reducing costs and improving overall efficiency in product delivery. Tesla leverages AI in the automotive industry, specifically in autonomous driving technology. Tesla's autopilot systems leverage AI algorithms, including computer vision and deep learning, to enhance the performance of advanced driving assistance features. It analyzes data from cameras, radar, and sensors to navigate, detect obstacles, and make real-time driving decisions, improving safety and efficiency. The Summon feature in Tesla's autopilot system uses AI to detect and react to its surroundings. It enables drivers to use smartphone apps to remotely park vehicles within a specified range. Additionally, Tesla's battery management system, or BMS, uses AI to predict energy requirements based on driving conditions and driver behavior, adjusting acceleration and climate control to conserve energy. It also helps plan efficient routes with the navigation system, considering traffic and elevation. Let's now explore a general roadmap consisting of various steps to adopt AI in business operations. Adopting AI is a multifaceted process that requires careful planning and execution. From defining business goals and identifying suitable use cases, to data readiness and building AI capabilities, deploying AI solutions, and monitoring and optimizing AI systems, each step is crucial for success. The journey begins with defining the business goals. Businesses need to identify the specific problems they aim to solve with AI, engaging stakeholders to understand their needs and outline clear objectives. It is crucial to ask questions like, what are the pain points? And how can AI help achieve business goals? After setting the business goals, the next step is to identify suitable use cases. Perform a thorough analysis of your business processes to find specific areas where AI can be effectively applied. Focus on tasks that are repetitive, time-consuming, data-driven, or require complex decision-making. One of the most critical steps in adopting AI is data readiness. It is crucial for businesses to collect, clean, and organize their data to ensure it is ready for AI algorithms. Data readiness involves removing inconsistencies, filling gaps, and ensuring the data is relevant to the problem. The next step is to build AI capabilities within the organization. This includes training employees on AI concepts, tools, and techniques. Investing in upskilling your workforce ensures they can effectively use and manage AI technologies. The training program helps employees understand how AI can be applied to specific tasks. Next, AI solutions are deployed, choosing the best AI tools and technologies that match your business needs. The deployment is done in a phased manner, starting with pilot projects and gradually scaling up. It is necessary to ensure that AI solutions are integrated seamlessly with the existing systems and processes. In the final stage, after the AI solutions are deployed into the business environment, it requires continuous monitoring and optimization to track performance regularly and identify and resolve issues. This ensures that the AI models are updated and refined, making necessary adjustments over time. In this video, you learn that AI can be adopted in businesses to increase efficiency, enhance decision-making, improve customer service, and drive innovation. You also gained insights on a few real-world examples of companies that have adopted AI and obtained benefits from it. Finally, you learned general steps for adopting AI in business. First, as part of the business requirement analysis, you set clear goals. Next, you need to identify suitable use cases, identifying areas to apply AI. Then, prepare data by first collecting it and then cleaning and organizing it. Further, build AI capabilities to train employees and develop the necessary setup. Deploy AI solutions, integrate them with existing systems, and finally, monitor and optimize AI systems to ensure they work well. Welcome to the Frameworks for AI Adoption. After watching this video, you'll be able to explain the framework developed and used by IBM to adopt AI for business needs and explore the shift from a plus AI to an AI plus approach to adopting AI. Organizations are increasingly adopting artificial intelligence, or AI, to drive innovation and gain a competitive edge. However, successfully harnessing the power of AI can be challenging. To address this, organizations are turning to AI adoption frameworks to guide their AI implementation efforts. These frameworks provide a structured approach to identifying the right use cases, aligning AI initiatives with business goals, and creating a culture that supports responsible AI development and deployment. One comprehensive framework designed to guide enterprises through this transformative journey is the IBM AI Ladder. The IBM AI Ladder is a structured framework that navigates organizations from basic data collection to full-scale AI integration across 4 key stages: collect, organize, analyze, and infuse. Let's understand each of these stages in detail. The initial stage, collect, involves gathering and storing high-quality data from diverse sources. IBM tools like the IBM Cloud and watsonx.data facilitate this process. The key actions include identifying data sources, such as databases and IoT devices, implementing collection tools, and ensuring data quality. For instance, a retail company uses watsonx.data to gather sales data from various channels. The next stage in the IBM AI Ladder is organize. This stage focuses on cleaning, categorizing, and making data accessible for analysis. IBM Cloud Pak for Data, IBM InfoSphere, IBM Data Ops, and IBM watsonx.governance help with data management, governance, and security. Actions include cleansing data, categorizing it for easy retrieval, implementing governance policies, and centralizing storage. In the analyze stage, AI's potential is harnessed through advanced analytics and machine learning models. IBM tools like SPSS, Cognos Analytics, Watson Machine Learning, and IBM watsonx.ai enable efficient model building, testing, and deployment. Activities include applying statistical and machine learning algorithms, developing predictive models, visualizing insights, and refining models based on performance. For example, data scientists use watsonx.ai to analyze customer behavior. Finally, the infuse stage integrates AI into daily business operations to enhance decision-making and automate tasks. IBM watsonx APIs, RPA, and Cloud Pak for automation are helpful in embedding AI models, automating processes, monitoring models in real time, and training employees in AI utilization. For instance, AI insights were integrated into customer relationship management, or CRM systems, to automate marketing campaigns and optimize inventory management. The IBM AI Ladder framework is versatile. It transforms data into actionable insights and strategies, supporting industries such as healthcare, finance, manufacturing, and retail. In the current business landscape, where AI is becoming increasingly prevalent, company leaders need to shift their mindset and move away from the plus AI model, where AI is used as a supplementary tool, and instead embrace the AI plus approach, where AI is integrated holistically. This means they need to move from merely incorporating AI into their existing workflows, which only provide limited, incremental advantages, to a more comprehensive approach, where AI is a core part of the business, not just a supporting tool. This involves designing business processes with AI as a fundamental component from the outset, rather than as an afterthought or add-on. Let us understand this shift in detail. The AI Plus approach works towards a holistic integration process. This means that AI should be seamlessly integrated across all business functions. It involves embedding AI into product innovation, enhancing operational efficiency, and fostering a culture that embraces AI-driven decision-making. The goal is to make AI a core part of the organization's DNA, influencing every aspect of the business from strategy to execution. Then, the focus should be on identifying high-value AI use cases that can deliver significant returns on investment. Begin with projects with clear, measurable outcomes and the potential for substantial impact. Once these initial projects demonstrate success, scale them across the organization. This approach ensures that AI investments are strategically aligned with business goals and provide tangible benefits. Another crucial step is selecting the appropriate AI technologies and architectures for successful integration. This involves evaluating different AI tools and platforms to ensure they align with the business's specific needs and goals. It is essential for the right technology to be scalable and flexible. Further, a robust data foundation is essential for effective AI implementation. This includes ensuring that the data is trustworthy, transparent, and well-governed. High-quality data is critical for training AI models accurately and making reliable predictions. Additionally, organizations should comply with data privacy and security regulations to avoid legal and ethical issues. And finally, it is important for organizations to continuously innovate by developing new AI applications and modernizing existing ones. Leveraging a hybrid cloud platform can provide the necessary flexibility and scalability to support ongoing AI initiatives. Continuous improvement and adaptation ensure that AI solutions remain relevant and effective in addressing evolving business challenges. In this video, you learned about the IBM AI Ladder, a framework to adopt AI that involves the 4 key stages of collect, make data simple and accessible, organize, create a business-ready analytics foundation, analyze, build and scale AI with trust and transparency, and infuse, operationalize AI throughout the business. You also gained insights into adopting an AI plus approach that involves holistic integration, identifying use cases, choosing the right AI technology, robust data foundation, and continuous innovation and modernization. Welcome to Transforming Your Work Through AI Tools. After watching this video, you will be able to list the key AI tools utilized by various professionals and demonstrate their practical applications. In today's digital age, AI tools and platforms play vital roles across multiple industries. A report published by Statista shows a huge rise in global AI tool users. It is expected to reach over 700 million by the end of the decade. Professionals use AI tools to work smarter and be more creative. By using the tools, they stay ahead of the curve and unlock new growth opportunities. Popular tools like Microsoft Copilot and Google Gemini help professionals with tasks such as answering questions and generating text. Let's explore how professionals across various fields utilize these AI tools in their work. Meet Mark. He is a research analyst at a finance startup who is responsible for investigating the ongoing market trends, and for that, he uses Microsoft Edge. Now, to grasp concepts quickly and save his time, he uses Microsoft Copilot, a powerful AI tool that integrates seamlessly with daily apps like Microsoft Edge, Word, Excel, PowerPoint, and Outlook. Copilot helps Mark by summarizing the article's key points, defining unfamiliar terms, and eventually streamlining his tasks. Let's also look at a practical application of Google Gemini. Vijay, a healthcare professional, manages patient records and contact details. He relies on Gemini to create a standardized patient intake form template. By having a consistent template, Vijay can ensure that all necessary information is captured uniformly from each patient. This helps him in maintaining accuracy and efficiency in work. Tools like Microsoft Copilot and Google Gemini are valuable for people other than research analysts or healthcare professionals. They are also valuable for content creators, business operations professionals, customer service agents, and others. Let's look at some more examples. Marketers, content creators, and editors harness AI tools to streamline processes, generate innovative content, and achieve marketing goals. Sarah manages the social media team at a tech startup. To create engaging videos, her team relies on Synthesia. This AI tool helps her team to generate digital avatars, simplifying video production without requiring extensive technical skills. For crafting compelling content, her team uses Quillbot, an AI-powered tool that refines and condenses text, ensuring originality and coherence in their social media posts. Finally, to polish the final drafts, Grammarly comes into play. This AI-based tool provides grammar and style checking, ensuring the content is clear, correct, and stylistically consistent. Don't these AI tools simplify her team's workload? They streamline processes by producing impactful content and effectively engaging the audience online. Then, language learners and translators employ diverse AI tools to personalize their learning experiences and overcome language barriers. Meet James, an international business consultant who frequently travels and communicates with clients from diverse linguistic backgrounds. To excel in his role, James relies on a range of AI tools tailored for language learning and translation. James starts by refining his language skills using Duolingo's AI-driven platform. The personalized lessons cater to his needs, focusing on work-specific vocabulary and phrases essential for presentations. During client calls, James relies on Google Translate to accurately translate messages in real time. This AI tool ensures seamless communication across languages, allowing him to understand client requirements. By integrating these AI tools into his professional routine, James enhances his ability to communicate effectively with international clients. Customer support representatives utilize AI tools to enhance their efficiency and transform their workflow. Meet Bella, a customer support representative. During her shift, she handles a high volume of inquiries. AI-powered chatbots instantly generate accurate responses, resolving common issues like account inquiries or product troubleshooting. This not only saves time, but also ensures customer satisfaction. Bella also uses Zendesk's AI capabilities, which suggests pertinent knowledge base articles and solutions based on customer inquiries. This streamlines issue resolution, minimizes escalation needs, and enhances response times effectively. For more personalized interactions, Bella also uses LivePerson's AI-powered messaging with sentiment analysis. This tool analyzes customer messages to evaluate emotions and tailor responses accordingly. Data professionals can also use AI tools for data analysis and visualization. Emily is a data analyst who uses Tableau for intuitive data visualization. With natural language queries, she quickly creates interactive dashboards, empowering her team with actionable insights. David, a data scientist, uses Microsoft Power BI to analyze client data trends and create clear reports and models. These visualizations help him understand client demographics and resource needs. HR professionals use AI tools to streamline recruitment, automate tasks, and enhance employee engagement efficiently. Miranda is an HR manager in a tech company. Her organization is struggling with challenges like low employee engagement and recruitment pressures. She implements Culture Amp, an AI platform that provides insights into employee engagement, helping to address issues and improve workplace culture. Such AI platforms often automate the initial support process and alert management to intervene and provide personal interactions. For recruitment pressures, Miranda leverages IBM Watson X Orchestrate. Orchestrate handles interview scheduling and streamlines communications, working tirelessly to ensure that the recruitment process runs smoothly. These tools help Miranda and her team overcome the challenges and ease the pressure. In this video, you explored how professionals from different domains leverage AI tools and platforms to enhance productivity and efficiency. Microsoft Copilot and Gemini provide varied applications, while Synthesia, Grammarly, and Quillbot aid editors, marketers, and content creators. Duolingo and Google Translate enable language learning and translation. AI chatbots, Zendesk, and LivePerson enhance customer service. Tableau and Power BI are used for data analysis and visualization. AI tools like Culture Amp and IBM Watson X Orchestrate are used by HR professionals to improve employee engagement and streamline recruitment. Welcome to Career Opportunities with AI. After watching this video, you will be able to identify key AI-related roles across various industries and recognize the foundational skills necessary to pursue a career in AI. You will also explore how you can effectively switch your career to AI. Are you worried that AI might take away your job? While it's true that AI will change the job landscape by automating multiple tasks, it's also important to understand that it will also create new opportunities. Throughout history, technological advancements have transformed industries and the job market. Remember the Industrial Revolution, which did replace some manual labor jobs, but also created new industries that didn't exist before. Additionally, in the information age, people feared that computers would replace human jobs and lead to widespread unemployment. On the contrary, it created job opportunities like IT support and web development and opened new avenues. AI is also creating a plethora of career opportunities that were unimaginable a few years ago. From healthcare to finance, entertainment to education, the demand for AI professionals is increasing. Let us look at some of the most sought-after AI careers, such as AI engineer, data scientist, robotics engineer, NLP engineer, AI application developer, and AI research scientist. AI engineers specialize in the design and maintenance of AI systems, leveraging expertise in machine learning, neural networks, and programming languages like Python and Java. Similarly, Data scientists are essential for analyzing huge data sets using advanced mathematics, statistics, data visualization tools, and languages such as Python and SQL to develop AI models. Meanwhile, robotics engineers design and build robots. For this role, you need skills in robotics, machine learning, mechanical engineering, and programming. Then, there are NLP engineers who create AI systems that process human language. They possess expertise in machine learning, neural networks, and programming languages like Python and Java.
AI application developers are responsible for developing software applications that incorporate AI. They need expertise in programming languages, AI frameworks, data analysis, APIs, and software development.
AI research scientists advance AI through research by developing new algorithms and models. So if you're fascinated by machine learning, neural networks, and NLP, you can consider becoming an AI researcher. This role demands a strong research background. You can find these tech-savvy experts in industries like technology, finance, healthcare, automobile, research, and many more. Even if you don't have strong programming skills, there are plenty of emerging AI roles in various domains for you. For example, roles in the areas such as ethics, management, communication, and application of AI technologies. So, there is an array of dynamic and in-demand job roles across many industries that don't require highly technical or programming experience, making them accessible for those with varied backgrounds. For example, an AI ethicist needs to ensure that AI systems are developed and used ethically, considering social and moral implications. So if you're someone with a background in ethics, philosophy, or law, and have strong communication skills, this could be for you. AI product managers oversee the development and implementation of AI products, ensuring they meet market needs. You can consider this role if you are good at project management, business analysis, and understanding of AI technologies. AI strategists develop long-term strategies for implementing AI to achieve business goals. For this role, you need strategic planning, business acumen, and a good understanding of AI applications. AI marketing specialists utilize AI to analyze consumer data and optimize marketing strategies. If you're good at data analysis, have marketing knowledge, and know your way around AI tools, this could be your niche. You can find these experts working in industries like technology, marketing, media, consumer goods, healthcare, and consulting. Now, if you are thinking about switching your career to AI, first identify your existing skills that can be leveraged. For example, problem-solving and analytical thinking or programming experience if you have any. Then, gather a detailed understanding of core AI concepts, such as machine learning, deep learning, and natural language processing. Note that Python is the most widely used language in AI. You can then contribute to open-source AI projects on platforms like GitHub or develop small AI projects to solidify your learnings. Since the field of AI is constantly evolving, you need to stay updated. For that, you can get into a network with AI professionals, attend conferences, or read publications on the latest trends. As you gain experience, you can delve deeper into specialized areas of AI that align with your interests, like robotics or NLP. Let's explore the examples of inspiring individuals who successfully transitioned their careers into AI. Emma leveraged her research and analytical skills from law to switch to AI for the legal field. She now helps develop AI systems that can analyze legal documents to support lawyers in their work. Meet Sarah. She leveraged her strong communication and customer service skills from marketing to transition into AI. She also acquired expertise in NLP, machine learning, and Python from various courses, and now builds chatbots powered by AI that can answer customer queries and provide support on company websites. In this video, you learned about some of the most sought-after AI careers, which include AI engineer, data scientist, robotics engineer, NLP engineer,
AI application developer,
and AI research scientist. You also learned that some AI-related jobs do not require the knowledge of programming languages like AI ethicist, AI product manager, AI strategist, and AI marketing specialist. To switch to a career in an AI-related field, you should identify your existing skills that can be leveraged, learn core AI concepts, apply the skills practically, stay updated with the latest trends,
And finally, delve deeper into specialized areas of AI.
A decision needs to be made. But who should make it? Me? A human? Or an artificial intelligence, an AI? We've discussed before that humans can outperform AI at some tasks, but that statistically AI will make a better job of deciding for other tasks. So for one single decision, who should decide? Well, the answer is a fascinating combination of holistic curves and human bias. Let's get into it. So consider a fraud detection system. Fraud detection. The system generates the alerts of potentially fraudulent transactions. Financial analysts review each alert. Now, there's thousands of events generated each day, and the analysts are overwhelmed with 90% of those alerts being false positives. An AI system could help alleviate the workload, but which alerts should the AI handle, and which should be processed by a skilled financial analyst? Well, let's draw a graph to answer the question, is this a real alert? So let's draw a graph with an x and a y axis. The y axis tracks the success rate. So an alert comes in, we make a prediction as to if it is real or not, and we track if that prediction turned out to be right. Along the x-axis is the confidence score. So a confidence score of 0% says a prediction thinks that this is definitely not a real alert. It's a false positive. Confidence score of 100% means that a prediction is certain that it is a real alert. Now, a typical AI performance curve will look something like this. So we've got very low confidence scores. This is not a real alert, and very high confidence scores. This is a real alert. They're correlated to a high success rate. That's these areas up here. When the AI is not sure about a given prediction, then it's not such a case. Lower success rate when the AI is not sure. It's effectively the AI algorithm saying, I don't know. Now, human performance curves are typically a little bit flatter than that. So the human's performance curve might look something like this. Often not quite as accurate as a very confident AI algorithm, but a little better at making the right decision when the AI is unsure. At a 50% confidence level, a human is likely to do a better job than an AI. Now, why is that? Well, when an AI is certain of itself, it's highly performant and beats out humans who can lose consistency and focus and attention. AIs, they don't get distracted. But on the other hand, when an AI is unsure, often for cases that are complex or statistically rare, humans can outperform an AI prediction by bringing in additional information and context. They can look stuff up or ask a colleague, whereas the AI sticks to its same old decision logic and information. So when a new alert comes in, if the AI assigns a high or a low confidence level, then chances are that statistically speaking, it will do a better job of deriving if that alert is real or if false positive than a given financial analyst. But this is not a zero-sum game. It doesn't have to be AI or human. We have one more option, augmented. Augmented intelligence combines both a human decision aided by AI. And this performance curve falls somewhere between the two. And for somewhat low and for somewhat high confidence scores, which make up a significant number of predictions, it's augmented intelligence that will have the highest success rate. Except, for augmented intelligence to be most effective, we need to account for the messy business of human cognitive bias. We're not always great at doing what we're told. It turns out that how we present information from an AI algorithm to a human decision maker has a significant influence on how effectively that information is used. So to illustrate that, let's consider forced display versus optional display. A forced display simultaneously displays an AI recommendation along with a given decision case. So for every fraud decision alert that I need to make a decision about, I, as the analyst, also see the AI's recommendation. And this can lead to something called automation bias, which is the propensity for humans to favor suggestions from automated decision-making systems and to ignore contradictory information. Effectively, the human decision maker is saying, the AI knows best, and going with the AI prediction at the expense of their own judgment. Optional display means the AI recommendation is only shown to the human decision maker when they request it. So a person sees a decision case and can then ask the AI to reveal its recommendation. This overcomes automation bias by giving a person time to consider the case for themselves before consulting an AI recommendation. The human is not overwhelmingly influenced by what the AI thinks because they've had a chance to make up their own first impression. And then there's the whole issue of trust too. When an AI recommendation is accompanied by an accuracy percentage, which indicates how likely this prediction is to be correct, humans are less likely to incorporate the AI recommendation into their decision, regardless of the accuracy percentage being displayed. Basically, we don't like recommendations that openly tell us that they might be wrong. So we've seen that who should make a decision, a human, an AI, or a human assisted by an AI recommendation, is something that we can derive. We can move from subjective decisions to the quantifiable, that for a given decision, who the most effective decision maker is likely to be. And when the most effective decision maker is a combination of AI and human, that's augmented intelligence, we must consider presentation of that augmentation to minimize human cognitive bias in the decision-making process. Brought together, us humans and AI algorithms make a pretty powerful team. We can improve decision-making outcomes if we just know who to ask.
Welcome to the ethical considerations and responsible use of AI. After watching this video, you'll be able to explain key ethical principles in AI. You'll also be able to develop strategies for responsible AI implementation. Let's begin our journey by looking into this case study. In 2014, Amazon developed an AI tool to automate the shortlisting of job applicants, but the system exhibited gender bias by penalizing female-associated terms due to the predominance of male candidates in the training data. Despite efforts to correct the bias, Amazon discontinued the tool in 2015 to uphold its commitment to diversity and equality. This case study clearly indicates the needs for ethical considerations in AI development to ensure these powerful technologies benefit society while minimizing potential harm. AI has transformed industries by enhancing efficiency, innovation, and decision-making processes. From healthcare and education to finance and entertainment, AI systems can analyze vast amounts of data, identify patterns, and make predictions that can save lives, improve services, and drive economic growth. However, with great power comes great responsibility. So let's understand the key aspects of ethical AI and responsible use. One of the foremost ethical concerns is data privacy and security. AI systems rely heavily on data to function effectively. This data often includes sensitive personal information. Therefore, it is imperative to implement robust data protection measures to prevent unauthorized access and breaches. It is advisable for organizations to comply with data protection regulations, like the General Data Protection Regulation, or GDPR, and the California Consumer Privacy Act, or CCPA, ensuring that user content is obtained and data is anonymized where possible. According to a New York Times article in 2020, a facial recognition company, Clearview AI, was found to have collected billions of images from social media and other websites without users' consent. They provided facial recognition software to law enforcement agencies, causing concerns about privacy violations. This incident led to a big debate about the ethical use of AI and the need for stronger privacy protections. AI systems can accidentally make existing biases in their training data even worse. These biases can lead to unfair treatment and discrimination in various applications, such as hiring, lending, and law enforcement. To mitigate this, developers should use diverse datasets, implement fairness-aware algorithms, and continuously audit AI systems for biased outcomes. Ensuring fairness in AI is not just a technical challenge, but a societal imperative. Another important aspect is transparency and accountability. Transparency in AI operations is essential for building trust. Users should be informed about how AI systems make decisions, what data they use, and how their personal information is handled. Additionally, the clear lines of accountability are essential. If an AI system causes harm or makes an incorrect decision, it should be clear who is responsible and how the issue will be rectified. Establishing such accountability framework is crucial for ethical AI deployment. As AI systems become more autonomous, the need for human oversight remains paramount. Fully autonomous systems, especially in critical areas like healthcare, transportation, and the military, should be designed to include human-in-the-loop mechanisms. These mechanisms ensure that human judgment and ethical considerations are integral to decision-making processes, thereby preventing potentially dangerous or unethical outcomes. Access to AI technology and its benefits should be equitable. If access is limited to only a privileged few, AI could exacerbate existing inequalities. Efforts are required to democratize AI, ensuring that it is accessible and beneficial to all segments of society, including underserved and marginalized communities. This includes investing in education and infrastructure to bridge the digital divide. Different applications of AI pose unique ethical challenges. For example, in healthcare, it is essential that AI prioritizes patient welfare and confidentiality. In law enforcement, the use of AI for surveillance and predictive policing raises significant concerns about privacy and civil liberties. Each application area requires tailored ethical guidelines to address its specific challenges and ensure responsible use. Another critical consideration is AI's environmental impact. Training and running large AI models consumes substantial energy, contributing to carbon emissions. It is crucial for developers and organizations to create energy-efficient algorithms and adopt sustainable practices. This includes leveraging advancements in hardware, optimizing algorithms for energy efficiency, and utilizing renewable energy sources for data centers. Ethical AI is not a one-time achievement, but a continuous process. It is essential to monitor AI systems and their impacts regularly, and feedback mechanisms should be established to gather input from users and stakeholders. Continuous improvement practices should be in place to update AI systems based on new ethical insights, technological advancements, and societal needs. In this video, you learned about the ethical considerations of AI, like data privacy and security, bias and fairness, transparency and accountability, autonomous systems and human oversight, and access and equality. You also learned about how to responsibly use AI by using diverse datasets, designing fully autonomous systems that include human in-the-loop mechanisms, and ensuring AI's accessibility and benefits to all segments of society, optimizing algorithms for energy efficiency, and utilizing renewable energy sources for data centers.
Welcome to Considerations Around Generative AI. After watching this video, you will be able to identify the complexities of copyright and content ownership in generative AI. You will also be able to explain the importance of privacy and confidentiality of data while using AI models. Further, you will explore the accuracy of generative AI outputs and understand the potential for hallucinations. Lastly, you will identify ethical considerations when developing and using generative AI technologies. Generative AI is transforming industries, pushing the boundaries of creativity and innovation. However, as with any powerful tool, it comes with its own set of challenges and considerations. In 2018, a piece of artwork titled Edmund de Bellamy, created by an AI algorithm called GAN, Generative Adversarial Network, was sold at an auction for over $400,000. This raised questions about who owned the rights to the artwork, whether it was the developers who programmed the AI or the buyers of the artwork. The sale sparked debates and discussions around intellectual property rights in AI-generated creations. The question of intellectual property and ownership in AI is complex. Who owns the right to AI-generated content or innovations? As AI systems become more creative, this question will become increasingly pertinent. It is recommended to establish clear guidelines and policies to address these issues, balancing the interests of AI developers, users, and the broader society. Developing appropriate regulations to govern the use of AI while promoting innovation is a delicate balance that needs careful consideration. Clarifying intellectual property rights related to AI-generated content is a complex and evolving issue. It is important to ensure that AI systems comply with existing laws and regulations, such as those related to data protection and consumer rights. Another critical concern in generative AI is privacy and confidentiality. Generative AI models often require large amounts of data for training, and this data can sometimes include sensitive or personal information. Implementing strong data protection measures is essential to ensure that the information used to train AI models does not violate individual privacy. To address privacy concerns, organizations are increasingly turning to private AI. Private AI refers to an AI environment created specifically for a particular organization, intended for exclusive use by that organization. These are designed to keep data confidential and secure, preventing unauthorized access and misuse. Generative AI is incredibly powerful, but it still comes with its flaws. Sometimes, AI can produce outputs that are inaccurate or completely fabricated, a phenomenon known as hallucination. For instance, an attorney used ChatGPT to craft a legal motion filled with phony judicial opinions and legal citations. The attorney, unaware of ChatGPT's ability to fabricate cases, faced sanctions for submitting the document. The phenomenon of hallucination highlights the importance of critical thinking when using AI-generated content. It is crucial to always validate and fact-check the information generated by AI to avoid the spread of misinformation. It is essential for developers and users to implement strategies to minimize the risk of AI hallucinations. This might include improving the quality of training data, refining algorithms, and establishing robust validation processes. Organizations can use private GPT models to address hallucination concerns. For instance, CustomGPT.ai is an advanced AI platform that develops tailored GPT chatbots using your business content, delivering accurate and reliable GPT-4 responses based on that content without fabricating information. By leveraging private models, businesses can reduce hallucination in AI outputs by ensuring the training data is highly relevant and accurate, leading to more reliable and context-specific responses. High-quality, diverse datasets are necessary for training effective models, and the quantity and quality of data also play a significant role in the model's performance. More complex models can also achieve better performance, but also require more computational resources and may be harder to interpret.
The ability to scale the use of generative AI across different applications and environments is important for widespread adoption. AI models should be robust to various inputs and able to handle unexpected scenarios gracefully. Finally, let's consider the ethical implications of generative AI. From continuing biases to potential misuse, the ethical landscape of AI is complicated. AI systems can unintentionally continue biases from their training data, leading to unfair results. It is important for developers to prioritize fairness, accountability, and transparency. This involves actively working to find and fix biases and ensuring that AI systems are used responsibly. Generative AI can be misused to create deepfakes, which can have serious consequences. Deepfakes are videos, images, or audio recordings that have been manipulated using generative AI models to make them appear as if they are real. They can be very convincing, and they can be used for a variety of bad purposes, such as creating fake news and propaganda, spreading disinformation, harassing or blackmailing people, or committing fraud. Deepfakes can be used to create forged identity documents or photos for fraudulent purposes, such as opening bank accounts, obtaining loans, or gaining access to secure locations. This can lead to financial fraud and other security breaches. Ethics in AI extends beyond preventing harm. It's also about fostering positive outcomes and ensuring that AI technologies benefit society as a whole. This includes using AI to address social challenges, improve access to resources, and enhance quality of life. It is important for developers and organizations to create AI systems that support initiatives, promoting social justice, environmental sustainability, and human well-being. In this video, you learned about the copyright and ownership challenges faced with content created using generative AI, and how important it is for developers and users to familiarize themselves with legal frameworks and stay updated on evolving laws. You also learned how to maintain the privacy and confidentiality of user data using private AI models and a combination of technical and legal measures. Further, you learned why critical thinking is important in ensuring the accuracy of generative AI outputs and how it can mitigate AI flaws like hallucinations. Finally, you gained insights into the ethical considerations, urging developers to prioritize fairness, accountability, and social benefits in AI development.
I'm going to state 3 facts. Your challenge is to tell me how they're related. They're all space and aviation themed, but that's not it. So here we go. Number 1, the distance from the Earth to the Moon is 54 million kilometers. Number 2, before I worked at IBM, I worked at a major Australian airline. And number 3, the James Webb Telescope took the very first pictures of an exoplanet outside of our solar system. What's the common thread? Well, the answer is that all 3 facts are an example of an hallucination of a large language model, otherwise known as an LLM. Things like Chat, GPT, and Bing Chat. 54 million K, that's the distance to Mars, not the Moon. It's my brother that worked at the airline, not me. And infamously, at the announcement of Google's LLM, Bard, it hallucinated about the Webb telescope. The first picture of an exoplanet was actually taken in 2004. Now, while large language models can generate fluent and coherent text on various topics and domains, they are also prone to just make stuff up. Plausible sounding nonsense. So let's discuss, first of all, what a hallucination is. We'll discuss why they happen, and we'll take some steps to describe how you can minimize hallucinations with LLMs. Now, hallucinations are outputs of LLMs that deviate from facts or contextual logic, and they can range from minor inconsistencies to completely fabricated or contradictory statements. And we can categorize hallucinations across different levels of granularity. Now, at the lowest level of granularity, we could consider sentence contradiction. This is really the simplest type, and this is where an LLM generates a sentence that contradicts one of the previous sentences. So, the sky is blue today. The sky is green today. Another example would be prompt contradiction. And this is where the generated sentence contradicts with the prompt that was used to generate it. So if I ask an LLM to write a positive review of a restaurant, and it returns, the food was terrible and the service was rude, that would be in direct contradiction to what I asked. Now, we already gave some examples of another type here, which is factual contradictions. And these factual contradictions or factual error hallucinations are really just that, absolutely nailed on facts that it got wrong. Barack Obama was the first president of the United States, something like that. And then there are also nonsensical, or otherwise known as sort of irrelevant kind of information-based hallucinations, where it just puts in something that really has no place being there. Like, the capital of France is Paris. Paris is also the name of a famous singer. Okay, thanks. Now, with the question of what LLM hallucinations are answered, we really need to answer the question of why. And it's not an easy one to answer, because the way that they derive their output is something of a black box, even to the engineers of the LLM itself. But there are a number of common causes. So let's take a look at a few of those. One of those is data quality. Now, LLMs are trained on a large corpora of text that may contain noise, errors, biases, or inconsistencies. For example, some LLMs were trained by scraping all of Wikipedia and all of Reddit. Is everything on Reddit 100% accurate? Well, look, even if the training data was entirely reliable, that data may not cover all of the possible topics or domains that LLMs are expected to generate content about. So, LLMs may generalize from data without being able to verify its accuracy or relevance, and sometimes it just gets it wrong. As LLM reasoning capabilities improve, hallucinations tend to decline. Now, another reason why hallucinations can happen is based upon the generation method. Now, LLMs use various methods and objectives to generate text, such as beam search, sampling, maximum likelihood estimation, or reinforcement learning. And these methods and these objectives may introduce biases and trade-offs between things like fluency and diversity, between coherence and creativity, or between accuracy and novelty. So, for example, beam search may favor high probability but generic words over low probability but specific words. And another common cause for hallucinations is input context. And this is one we can do something directly about as users. Now, here context refers to the information that is given to the model as an input prompt. Context can help guide the model to produce the relevant and accurate outputs, but it can also confuse or mislead the model if it's unclear, or if it's inconsistent, or if it's contradictory. So, for example, if I ask an LLM chatbot, can cats speak English? I would expect the answer, no, and do you need to sit down for a moment? But perhaps I'd just forgotten to include a crucial little bit of information, a bit of context, that this conversation thread is talking about the Garfield cartoon strip, in which case the LLM should have answered, yes, cats can speak English, and that cat is probably going to ask for second helpings of lasagna. Context is important, and if we don't tell it we're looking for generated text suitable for an academic essay or a creative writing exercise, we can't expect it to respond within that context. Which brings us nicely to the third and final part. What can we do to reduce hallucinations in our own conversations with LLMs? So, yeah, one thing we can certainly do is provide clear and specific prompts to the system. Now, the more precise and the more detailed the input prompt, the more likely the LLM will generate relevant and most importantly here, accurate outputs. So for example, instead of asking what happened in World War II, that's not very clear, it's not very specific, we could say, can you summarize the major events of World War II, including the key countries involved and the primary causes of the conflict? Something like that that really gets at what we are trying to pull from this. And that gives the model a better understanding of what information is expected in the response. We can employ something called active mitigation strategies. And what these are using some of the settings of the LLM, such as settings that control the parameters of how the LLM works during generation. A good example of that is the temperature parameter, which can control the randomness of the output. So a lower temperature will produce more conservative and focused responses, while a higher temperature will generate more diverse and creative ones. But the higher the temperature, the more opportunity for hallucination. And then one more is multi-shot prompting. And in contrast to single-shot prompting, where we only give one prompt, multi-shot prompting provides the LLM with multiple examples of the desired output format or context, and that essentially primes the model, giving a clearer understanding of the user's expectations. By presenting the LLM with several examples, we help it recognize the pattern or the context more effectively, and this can be particularly useful in tasks that require a specific output format, so generating code, writing poetry, or answering questions in a specific style. So while large language models may sometimes hallucinate and take us on an unexpected journey 54 million kilometers off target, understanding the causes and employing the strategies to minimize those causes really allows us to harness the true potential of these models and reduce hallucinations.
Welcome to the perspective of key players around AI ethics. After watching this video, you'll be able to discuss the approaches and principles adopted by various organizations to ensure ethical AI adoption. You will also be able to explain IBM's pillars of trust, Microsoft's approach to ethical AI, and Google's AI principles. Ensuring AI ethics is a complex issue that organizations are addressing with different approaches. Organizations like IBM, Microsoft, and Google have created approaches and tools to handle ethical concerns in AI development and use. Let's look at how these organizations are making sure AI is ethical through their unique methods and initiatives. In its commitment to ethical AI, IBM has made significant progress in promoting AI ethics through its pillars of trust. IBM's pillars of trust are focus areas that help us take action to build and use AI ethically. These pillars are explainability, fairness, robustness, transparency, and privacy. AI is explainable when it can show how and why it arrived at a particular outcome or recommendation. AI is fair when it treats individuals or groups equitably. AI is robust when it can effectively handle exceptional conditions, like abnormal input or adversarial attacks. AI is transparent when appropriate information is shared with humans about how the AI system was designed and developed. Because AI ingests so much data, it is crucial to be designed to prioritize and safeguard humans' privacy and data rights. IBM has developed toolkits to support these pillars. AI Explainability 360 helps understand and interpret AI models to ensure transparency. AI Fairness 360 provides metrics and algorithms to detect and mitigate bias in AI systems. Adversarial Robustness 360 helps enhance AI systems' security against adversarial attacks. AI Fact Sheets 360 promotes transparency by documenting AI models' processes and performance. And AI Privacy 360 safeguards user data privacy within AI applications. These pillars form the foundation of IBM's approach to creating trustworthy AI that aligns with ethical principles and societal values. Let us now look at Microsoft's approach to ethical AI development and deployment. Microsoft emphasizes the involvement of designers, developers, data providers, and regulatory bodies in ensuring ethical AI. It has deployed human in-the-loop systems that incorporate human oversight to enable intervention when needed.
Microsoft practices continuous monitoring and improvement. It maintains ongoing evaluation of AI systems to address ethical concerns. Microsoft conducts regular audits to ensure compliance with ethical standards and regulations. It uses algorithmic impact assessments, or AIA, to identify and mitigate biases before deployment. It has established bodies like Microsoft's Aether Committee, whose primary responsibility is to provide guidance on issues, technologies, processes, and best practices for responsible AI. Lastly, Microsoft has developed a responsible AI standard that outlines accountability measures, including transparency, fairness, and human oversight. Moving on, let us now understand Google's principles of developing and deploying AI. These are: be socially beneficial, focusing on the fact that AI should benefit society and be aligned with widely accepted principles. Secondly, avoiding creating or reinforcing bias means ensuring fairness and avoiding unjust impacts. Then, ensuring AI is being built and tested for safety, which means maintaining safety and taking steps to mitigate risks. Further, being accountable to people that emphasizes allowing appropriate human direction and control. Incorporating privacy design principles means protecting user privacy and data. Upholding high standards of scientific excellence, that is, maintaining rigor and integrity in scientific research. And ensuring that AI is being made available for use that accords with these principles, which means restricting use to applications consistent with these guidelines. Furthermore, Google's AI governance includes a review process to assess AI projects for ethical risks and compliance with its AI principles. This process involves a multidisciplinary team of experts evaluating projects at multiple stages. In addition to following stringent principles, organizations are engaging with external stakeholders to ensure the ethical use of AI. For instance, the AI Alliance, co-launched by IBM and Meta alongside leading organizations from various sectors, is dedicated to fostering an open community aimed at accelerating responsible AI innovation. This initiative prioritizes scientific rigor, trust, safety, security, diversity, and economic competitiveness. By encompassing a broad range of organizations, the AI Alliance ensures that AI education, research, development, deployment, and governance are conducted responsibly and inclusively, benefiting everyone involved in the AI ecosystem. Apart from this, several consulting firms, like Deloitte, work with clients and external experts to develop ethical AI strategies. They provide consulting services to help organizations implement ethical AI practices. Another important aspect of developing ethical AI training and education programs is practiced by various organizations. For example, PwC offers training programs for employees on AI ethics. They focus on educating their workforce about the ethical implications of AI and how to implement ethical practices in their projects. Also, Deloitte provides workshops and resources to clients on AI ethics. They help organizations understand and address ethical challenges in AI deployment. Lastly, many organizations like Adobe engage in industry-wide initiatives like the Partnership on AI to collaborate on ethical AI standards. They contribute to developing guidelines and best practices for responsible AI use. In this video, you learned about IBM's pillars of trust. These pillars are central to IBM's approach, ensuring that AI systems are explainable, fair, robust, transparent, and privacy-preserving. You also learned about Microsoft's approach to ethical AI, which involves human in-the-loop systems, continuous monitoring and improvement, regular audits, using AIA, internal review bodies, and responsible AI standards. You explored Google's principles focused on benefiting society, ensuring fairness, holding accountability, and upholding high standards of scientific excellence.
If you have been following the news in artificial intelligence, you probably already know that this field is growing at an exponential pace. Each day, we are hearing about new use cases in AI, use cases and applications that we haven't even dreamt of in the past few years. But in the same news, you probably are also hearing about AI systems that have been deployed to production that are not yielding the expected outcomes. we are hearing about chatbots that have been misdirecting customers and employees into making the wrong decisions. We also heard about chatbots that are hallucinating responses to the customers. And we also heard about models that have been generating biased outcomes. There is no denying that there is huge potential in artificial intelligence. But premature deployment and adoption of AI systems could put the companies at a huge risk of reputational and financial loss. And this exactly is the reason why artificial intelligence governance has become one of the most relevant and important topics today. So let's dive in and understand a bit more about AI governance. Let's start off by defining what it means. AI governance refers to a set of rules, standards, and processes that have been set in place in order to ensure the responsible and ethical development and deployment of artificial intelligence systems. Think of it as a set of guardrails that ensure the ethical use of these artificial intelligence systems so that we minimize the risk in the systems while maximizing the potential benefit. Now, we all know what the benefits are of artificial intelligence. It leads to reduced costs, improved efficiency, and leads to automation of repetitive and manual tasks. While these benefits make artificial intelligence a highly important topic and most sought-after technology today, it is the risk in artificial intelligence that is making AI governance an even more important topic to be discussed. In order to understand what these risks are, let's, in a very broad sense, understand what constitutes an AI system. Now, an AI system is a system that is designed to take in inputs and produce outputs that in some way mimic, augment, or aid human decision-making. At the heart of the system is what we call the AI model. Now, the goal of this model is to look at the input and generate an output that a human would normally do. So how does an AI model do that? And in order for this model to do exactly that, we need to supply it with data. Because we want it to mimic or augment or aid human decision-making, we need to supply it data that is human-generated. And this data could be in any format. It could be structured data with columns and values, or it could be semi-structured data, such as XML files, or unstructured data, such as PDF documents, text documents, audio files, video files, etc. Now, this AI model, which you can think of as highly engineered code that uses complex mathematical algorithms, looks at the data, derives patterns from data, and learns how to mimic the human behavior that is expected from it. Now, since we are talking about data, right, and this data is human-generated, and we humans, unfortunately, are not devoid of bias. We have several cognitive biases within us. An example of one such bias is some of us tend to put undue importance on certain factors while making decisions, while completely ignoring another set of factors. Now, that can cause biases in the data. Yes, the biases are not patently visible. You cannot look at the data and say, yes, I see biases. But these are latent and hidden. And this highly engineered mathematical code has a tendency to pick up on these biases. And in worst-case scenarios, it reflects those biases in the outcomes. So that makes your AI systems susceptible to bias. Secondly, we are talking about data here. The data is being sent as input, data is being used for training the model, and if there is no proper oversight, this data could contain private and sensitive information. And when there is no proper oversight, this data can seep into the model and seep into the output of the model, leading to privacy infringement. Or, in other cases, in cases of unstructured data, it could also contain copyright information, and that can also be reflected in your model's output. So privacy or copyright infringement. Some of the models that we use are black box models. So the reason we use these black box models as opposed to the glass box models is that black box models tend to provide a higher level of accuracy in the outcomes. So when we use black box models, what it means is that the people who are creating these models and systems have little control over the inner workings of the algorithms. So when you ask them why their model is making a certain decision, they won't be able to give you an explanation. So in that case, your system is not transparent. So that puts you at a risk of lack of transparency or trust. So how would you trust a system that is not able to explain why and how it made a certain decision? And that is the third risk in artificial intelligence systems. Now, these AI models are not something that you once create and they continue to generate high-quality outcomes. These models can deteriorate, and the deterioration can happen because the incoming data could be very different from the data that the models have been trained on. And because this deterioration happens, there is a need for continuously monitoring these models. So that is another factor that can put your models at risk, because if you're not continuously monitoring them, then your model is not producing consistently high-quality outcomes. So because of risks like these, there are organizations across the world that are coming up with regulations and guidelines on how to manage these systems. Now, the guidelines, you can think of something like the NIST AI regulation, AI risk management framework. And as for regulations, we all heard about the EU AI Act. And these regulations are much more serious because these are not just guidance for AI system deployment, but can actually penalize companies for non-compliance. So when your company or when your AI systems are not complying with the guidelines stipulated by the regulation, then you will be at a risk of reputational loss and financial loss as well, and several ethical dilemmas as well. So due to factors such as these, bias, privacy or copyright infringement, lack of trust or transparency, and lack of continuous monitoring, and the presence of regulations, it is extremely important that we govern our artificial intelligence systems. I think we can all agree that the promise of AI is undeniable, but the risks it poses are very much real, and a properly governed AI system is extremely important for organizations to fully realize the potential of artificial intelligence. I hope you found this video helpful.
AI ethics are something that's on everyone's mind these days. So how do enterprises determine if their AI solution is at risk of crossing some sort of ethical boundary? The first thing we want to do is come up with a set of guidelines or rules that we're going to follow whenever we are creating or interacting with AI systems. Number one, artificial intelligence is meant to augment human intelligence. It's not here to replace us. 2, data and insights belong to their creator. So if we are using customers' data for anything, it's still their data, not ours. Number 3, solutions have to be transparent and explainable. And what this means is that we need visibility into who is training the system, what data they're using to train the system, and then also how all of this is going to affect an algorithm's recommendations to the end user. So now we have our rules. How do we determine if we are actually following them or breaking any sort of guidelines? So there are a few different design thinking activities that you could try. One of them is called dichotomy mapping. And basically what this means is that first, we're going to list all of the features of our solution. And then we're going to list the benefits and what they're meant to be used for. So I'll give you an example. Let's say a hotel has a recommendation system for their users that will determine maybe what room they get, or if we leave any kind of treats for them in their room. If someone's going skydiving, maybe we give them a room on a higher floor. We list all of these benefits out, and obviously these things are great for the customer, right? They're getting a great experience. But then the next thing we need to do is actually look at these features and determine, can this cause harm in any way? So in this case, we would want to look at, is this data being sold to advertisers? Is it secure? Something else, if we have differently abled users, are they able to use the interface? Are they being included in the algorithm? Once we've got our rules, we've got our activities, we've defined some issues that maybe we need to work on, what do we do next? We fix it. The first thing we're going to do is implement a set of guardrails. And these are basically just rules that your AI system has to follow. In this case, it's going to be, we do not sell to advertisers. That is a guardrail. Next, let's talk about the data that we're using to train this AI system. As I mentioned before, if we're not using a diverse set of data, then we're actually not going to be able to accommodate all of our users. The next thing we could do is look at some open source tooling. So IBM actually has one called AI Fairness 360, and it's actually going to help you mitigate and detect bias in your machine learning models. There may be other tools that help you with adhering to privacy regulations or even detecting uncertainty in your models. So now that we have our rules, we know how to identify problems and then how to fix them. AI is all of our responsibility. We have to make sure that the AI that we're creating and using is safe, secure, and built by humans with humans in mind.
Congratulations on completing this introductory course on AI. Now that you thoroughly understand AI and its transformative potential, you are well equipped to apply your skills to boost your career. Let's review some of the key aspects of what you learned throughout the course. Artificial intelligence, or AI, is a technology that performs tasks typically requiring human intelligence, such as problem-solving, decision-making, and recognizing speech or images. And generative AI is a branch of artificial intelligence that creates new content in different formats. It uses large language models for generating texts and advanced algorithms for creating images, voices, and videos. AI affects your daily life by personalizing recommendations on services like Netflix and Spotify, and improving efficiency with smart home devices such as thermostats and security systems. Additionally, AI-powered chatbots have evolved from simple, rule-based systems to advanced personal assistants that are now capable of natural conversations. They even offer benefits like 24/7 availability, scalability, personalized services, and multilingual capabilities. AI applications span across various industries, including manufacturing, healthcare, finance, retail, and so on. Some of the core concepts of AI include machine learning, deep learning, and neural networks. Machine learning is a subset of AI that uses algorithms to analyze data and make decisions. Deep learning, a specialized subset of machine learning, takes a step further and uses layered algorithms to create neural networks. This enables tasks like natural language understanding and image recognition. And neural networks are inspired by the structure of the human brain and consist of an input layer, one or more hidden layers, and an output layer. Remember generative AI models? They are deep learning models that employ algorithms to generate fresh content. The types of architectures that generative AI models include are variational autoencoders, or VAEs, generative adversarial networks, or GANs, autoregressive models, and transformers. The development of AI in diverse domains, including natural language processing, computer vision, and robotics, has brought innovation. Natural language processing allows machines to interpret and produce human language, while computer vision enables them to understand visual data by analyzing images or videos and drawing meaningful insights. Robotics involves creating and using robots to perform tasks, either with or without human help. These robots have sensors to observe, actuators to move, and controllers to make decisions,
often using AI, machine learning, and NLP for automation. Artificial intelligence, AI, including generative AI, boosts business operations and opens up various career paths. Businesses use AI to create content, analyze data for patterns, enhance customer service, and improve product development. Popular AI-related careers include AI engineer, data scientist, robotics engineer, AI strategist, AI application developer, and AI marketing specialist. To move into an AI career, build on your current skills, learn key AI concepts, gain practical experience, stay updated on trends, and specialize in emerging AI fields. Adopting AI in your business offers many benefits, but it's important to consider ethical issues to ensure responsible use. Some essential ethical considerations are data privacy and security, bias and fairness, transparency and accountability, autonomous systems and human oversight, and access and equity. Now that you've reviewed the essential concepts in this course, check out the course glossary to reinforce your understanding of key AI terms. It's a handy, quick reference for all the terminology used throughout the course. The course also includes multiple interactive labs and activities that will help you practice your skills and solidify your understanding of the concepts. Thank you for sharing this learning journey with us. As a next step, we encourage you to continue learning by exploring other AI and generative AI courses from IBM and applying your new skills. All the best!
Let's get started with an introduction to generative AI. Imagine a world in which AI is going to make us work more productively, live longer, and have cleaner energy. Well, that world is already here. Generative AI has made a big impact on the way we go through life. Generative AI models can mimic human thinking and creativity to create novel content and perform complex tasks, just like you and me. Organizations can leverage generative AI to become more productive and profitable. Individuals can use generative AI tools to increase their efficiency, add tangible value to their work, save money, and maximize their brand value. If you're not there yet, this course is for you. Inviting all professionals, enthusiasts, practitioners, and students with a genuine interest in the rapidly developing field of generative AI. Regardless of your background or experience, this is a course for everyone. This course is designed to give you a solid understanding of the capabilities, applications, and common models and tools of generative AI. By the end of this course, you'll be able to describe the capabilities of generative AI and its use cases in the real world, identify the applications of generative AI in different sectors and industries, and explore common generative AI models and tools. As this is a focused course comprising 3 modules, you're expected to spend 1 to 2 hours to complete each module. In Module 1 of the course, you'll learn about the core concepts of generative AI, view use cases of how it is applied across different domains, and understand its capabilities for generating text, images, code, audio, and video. In Module 2, you'll discover how different sectors and industries such as information technology, entertainment, education, finance, and healthcare leverage generative AI. Further in this module, you'll learn about the capabilities and features of common models and tools for generating text, images, code, audio, and video, such as ChatGPT, DALL-E, and Synthesia. Module 3 requests your participation in a final project and presents a graded quiz to test your understanding of course concepts. You can also visit the course glossary and receive guidance on the next steps in your learning journey. The course is curated with a mix of concept videos and supporting readings. Watch all the videos to capture the full potential of the learning material. You'll enjoy hands-on labs and a final project that demonstrates the common use cases of generative AI across multiple domains. There are practice quizzes at the end of each lesson to help you reinforce your learning. At the end of the course, you'll also attempt a graded quiz. The course also offers discussion forums to connect with the course staff and interact with your peers. Most interestingly, through the expert viewpoint videos, you'll hear from experienced practitioners who will share their perspectives on different aspects of generative AI. Well, don't just stand by. As generative AI strengthens the creative expression and professional capabilities of individuals, organizations, and communities across the world, this course presents an opportunity for you to create new experiences.
Generative AI is on the minds of every leader in every organization, businesses, or governments, and with interest comes opportunity. Organizations are looking for people who understand the technology and, most importantly, have the skills to apply it. Unlike many of the previous trending technologies, generative AI touches almost every role and every profession. Generative AI skills are expected to become important, not just for computer scientists, for everybody, which is why they will be essential as word processing, spreadsheets, even basic business literacy. This is why these programs are generative AI for everyone. There's a lot of new interest happening right now in AI, and businesses are looking beyond consumer AI. A chatbot interface is a great way to demonstrate generative AI potential. Real-life use cases are embedding generative AI into existing processes and making it an integral function of nearly every business workflow. IBM is proud to be helping businesses integrate generative AI into their operations. These are skills you will gain as part of these programs that should help you with your career and be very applicable to your job instantly. Businesses are excited by the potential of generative AI, but they're also apprehensive of potential dangers.
This mission is too important for me to allow you to jeopardize it.
These programs will give you the skills to deal with AI ethics that are grounded in a responsible approach, really started at IBM.
Did you know that marketers across the world are already using generative AI to create content, write copy, inspire creative thinking, analyze market data, and generate images? According to Bloomberg, the generative AI market is estimated to reach $1.3 trillion by 2032. In that case, you definitely want to get better acquainted with generative AI. However, is generative AI for everyone? Yeah, it is. And you can leverage its potential to create a better career and life for yourself. This specialization is for anyone who's passionate about discovering the power of generative AI. Prior technical knowledge or background in AI is not required. Even beginners can benefit from this specialization, as it provides a comprehensive understanding of the fundamental concepts, models, tools, and applications of generative AI. By the end of this specialization, you'll be able to explain the fundamental concepts, capabilities, models, tools, applications, and platforms of generative AI foundation models. Describe prompt engineering and apply powerful prompt engineering techniques to write effective prompts and generate desired outcomes from AI models. Discuss the limitations of generative AI and explain the ethical concerns and considerations for the responsible use of generative AI, and recognize the ability of generative AI to enhance your career and help implement improvements at your workplace. Spread across 5 focused, self-paced courses, each requiring 3 to 5 hours to complete. Course 1 is your first step toward understanding the capabilities of generative AI, which span different domains such as text, image, audio, video, virtual worlds, code, and data. You'll understand how different sectors and industries apply common generative AI models and tools, such as GPT, DALL-E, Stable Diffusion, IBM Granite, and Synthesia. Course 2 introduces the concept of prompt engineering and how it can help you unlock the full potential of generative AI tools like ChatGPT. You'll explore the techniques, approaches, and best practices for developing effective prompts and work with commonly used tools such as IBM Watson X, Prompt Lab, Spellbook, and Dust. Course 3 focuses on the core concepts and building blocks of generative AI, such as deep learning, transformer-based large language models, diffusion models, and foundation models. You'll also learn about the different generative AI platforms like IBM Watson X.AI and Hugging Face. In Course 4, you'll explore ethical considerations related to generative AI, How does it impact data privacy and security, copyright infringement, the workforce, and the environment? You'll also describe limitations such as data bias, lack of explainability, transparency, and interpretability, and identify common misuses of generative AI such as deepfakes and hallucinations. Lastly, Course 5 discusses the future of generative AI. Don't you want to know what your career opportunities are in that future? You'll learn how generative AI can impact and enhance existing functions, skills, and job roles in different sectors and industries, and how you can use generative AI to build your own applications to create new business opportunities. The content in this specialization is designed to engage and empower you. By viewing curated concept videos, hearing AI experts share their insights and tips, and practicing techniques in hands-on labs and projects, you'll feel more confident in using generative AI tools and applications in your daily life. Currently, 65% of generative AI users are millennials or Gen Z, and 72% are employed. With this specialization, you'll be ready to join the generative AI changemakers. Generative AI is for everyone. Welcome to Introduction to Generative AI. After watching this video, you'll be able to describe generative AI and its evolution. You'll also be able to explain how generative AI differs from discriminative AI. Artificial intelligence, or AI, has been around for years, shaping almost every sphere of our lives and revolutionizing how we live and work. At its core, AI can be defined as the simulation of human intelligence by machines. AI models learn from vast amounts of existing data. The process of learning from data is called training. There are two fundamental approaches to AI: discriminative AI and generative AI. Discriminative AI is an approach that learns to distinguish between different classes of data. A discriminative AI model is given a set of training data, where each data point is labeled with its class. The model then predicts the class of a new data point by finding the side of the decision boundary that the data point falls on. Discriminative AI models use advanced algorithms to differentiate, classify, identify patterns, and draw conclusions based on training data. An example of how a discriminative AI model works can be seen in how email spam filters can differentiate between spam and non-spam emails. Discriminative AI models are best applied to classification tasks. They cannot, however, understand context or generate new content based on a contextual understanding of the training data. And this is where generative artificial intelligence, or generative AI, comes in. Generative AI models learn to generate new content based on the training data. They can capture the underlying distribution of the training data and generate novel data instances. Generative AI starts with a prompt. This can be text, an image, video, or any other input that the model can process. As an output, the model generates new content, including text, images, audio, video, code, and data. Generative AI can produce output in the same form in which the prompt is provided. For example, text to text, or in a different form from the prompt, such as text to image or image to video. Here is a simple example to understand the difference between discriminative or traditional AI and generative AI. Discriminative AI would be best suited to answer questions such as, is this image a drawing of a nest or an egg? Generative AI would respond to prompts such as, draw an image of a nest with 3 eggs in it. While discriminative AI mimics our analytical and predictive skills, generative AI goes a step further to mimic our creative skills. As implied by this comment from the Harvard Business Review, AI can not only boost our analytic and decision-making abilities, but also heighten creativity. Generative models can take what they have learned and create entirely new content based on that information. Both discriminative and generative models are created using deep learning techniques. Deep learning involves training artificial neural networks to learn from vast amounts of data. An artificial neural network is a collection of smaller computing units called neurons. which are modeled in a manner that is similar to how a human brain processes information. The creative skills of generative AI come from generative AI models such as generative adversarial networks or GANs, variational autoencoders or VAEs, transformers, and diffusion models. These models can be considered as the building blocks of generative AI. Generative AI is not a new concept. Its roots trace back to the origins of machine learning. In the late 1950s, when scientists proposed machine learning, they explored using algorithms to create new data. During the 1990s, the rise of neural networks infused advancements in generative AI. Further, during the early 2010s, deep learning, supported by the availability of large data sets and enhanced computing power, further advanced the development of generative AI. In 2014, generative AI was transformed with the introduction of GANs by Ian Goodfellow and his colleagues. GANs and other models such as VAEs and transformers set the stage for generative AI's growth and the development of foundational models and tools. Foundation models are AI models with broad capabilities that can be adapted to create more specialized models or tools for specific use cases. A specific category of foundation models called large language models, or LLMs, are trained to understand human language and can process and generate text. In 2018, OpenAI introduced a transformer-based LLM called Generative Pre-trained Transformer, or GPT. Over the years, different LLMs such as GPT-3 and GPT-4 in the GPT series, Google's Pathways Language Model, or PaLM, and Meta's Large Language Model Meta AI, or Llama, have significantly enhanced generative AI to generate coherent and relevant text. There have been similar developments in models for other use cases. For example, Stable Diffusion and DALL-E are models for image generation. The development of a variety of generative models has led to a growing market for generative AI tools for diverse use cases. For instance, you have ChatGPT and Bard for text generation, DALL-E 2 and Midjourney for image generation, Synthesia for video generation, and Copilot and AlphaCode for code generation. The rapidly emerging models and tools have generated a wide scope for generative AI applications across domains. To quote from McKinsey's report on the economic potential of generative AI has the potential to change the anatomy of work, augmenting the capabilities of individual workers by automating some of their individual activities. The report also predicts that generative AI's impact on productivity could add trillions of dollars in value to the global economy. In this video, you learned that generative AI models can generate new content based on the data they are trained on. Further, you learned that the creative skills of generative AI are built from models such as GANs, VAEs, transformers, and diffusion models. Foundation models can be adapted to create specialized models or tools tailored to specific use cases. Finally, you learned that generative AI models and tools have a wide scope for applications across different domains and industries. Welcome to the capabilities of generative AI. After watching this video, you'll be able to describe some of the capabilities of generative AI and explore their use in the real world. Let's start with a high-level overview of some of the capabilities of generative AI that we'll discuss. First is the text generation capability of generative AI, that is, its ability to generate clear, lucid, and contextually relevant textual responses. The second capability is image generation, that is, synthesizing artistic and realistic images that are very similar to real ones. The third capability is audio generation. Generative AI enables music composition and synthetic audio generation. The fourth capability we'll discuss is video generation. Generative AI enables the generation of dynamic films and small videos based on textual descriptions and even images. The fifth capability is the code generation capability of generative AI. Generative models can generate code, functions, and programs. We'll also discuss the data generation and augmentation capability of generative AI. This helps generate synthetic data to create and augment data sets. Finally, we'll explore generative AI's capability to create real and immersive virtual worlds. These are just some of the capabilities of generative AI. Essentially, whatever the human mind is capable of conceiving is a potential use case for the application of generative AI. Now, let's delve deeper into some of these capabilities. Let's begin with the text generation capabilities of generative AI. At the core of generative AI's text generation capability are advanced AI-powered large language models, or LLMs. LLMs are trained on large data sets and can generate human-like text in various contexts. These models learn patterns and structures within the data to generate coherent and contextually relevant responses. These models generate text, converse, and provide explanations, summaries, and more. Some popular LLMs are OpenAI's Generative Pre-trained Transformer, or GPT, and Google's Pathways Language Model, or PaLM. These models can perform various language-related tasks such as text completion, summarization, question answering, translation, code generation, and image and text pairing. Conversational interactions with chatbots and virtual assistants are powered by LLMs. Let's look at the image generation capabilities of generative AI. Generative models can generate high-quality, convincing images based on deep learning techniques such as generative adversarial networks, or GANs, and variational autoencoders, or VAEs. These generated images exhibit realistic textures, natural colors, and fine-grained details, giving the impression of a real camera capture. StyleGAN, for example, can generate high-quality, high-resolution new images of imaginary faces, animals, or nature, while DeepArt can create comprehensive artwork from a simple sketch. DALL-E can generate entirely new images as described by the users. Apart from applications in art, design, entertainment, gaming, and research domains, generated images can augment training data and aid medical imaging and scientific visualization. In the context of audio generation, generative models can generate new musical compositions, convert text into audio using text-to-speech, or TTS, and create synthetic voices and natural-sounding speech. Generative models can convert, modify, and transform and clean up voices, also reduce noise and enhance audio quality. These models also have the capability to mimic human voice to a fair amount of likeness. WaveGAN, for example, can create new and realistic raw audio waveforms, including speech, music, and natural sounds. MuseNet from OpenAI can combine various instruments, styles, and genres to generate novel musical compositions. Google's Tachytron 2 and Mozilla TTS use advanced TTS systems to create synthetic speech resembling human tone, pitch, modulation, pronunciation, rhythm, and expressions. Audio generated by generative models has applications in media, creativity, entertainment, training, education, gaming, virtual reality, and several other domains. Now, let's look at the video generation capabilities of generative AI. Generative AI models can create dynamic and lucid videos ranging from basic animations to complex scenes. These models transform images into dynamic videos by incorporating temporal coherence. In natural language processing, temporal coherence refers to the consistency and continuity of meaning or context over time. This enables these models to exhibit smooth motion and plausible transitions in videos. For instance, a popular AI model, Video GPT, follows textual prompts users provide to generate new videos. Users can specify the desired content and guide the video generation process, including completion, editing, synthesis, prediction, and style transfer. These generated videos can be used in domains such as art, entertainment, education, gaming, medicine, and research. Now, let's talk about generative AI's code generation capabilities. Generative models can generate new code snippets, functions, or complete programs based on desired functionality. Trained on existing code repositories, these models can complete or create code, synthesize or refactor code, identify and fix bugs in code, test software, and create documentation, including comments, function descriptions, and usage examples. For instance, GitHub Copilot and IBM Watson Code Assistant are AI-based programming assistants that help autocomplete code, accelerate hard tasks, and generate code for provided input. AI-generated code can be used in software and web development, machine learning and natural language processing, data science and analytics, robotics and automation, virtual game and AR/VR environment development, and audio, video, and speech processing. Software developers can benefit from leveraging code generation capabilities to write, debug, and test their code. Now, let's explore the data generation and augmentation capabilities of generative AI. Generative models can generate new data and augment existing data sets. Generating synthetic data sets helps increase the diversity and variability of the data, leading to more robust and effective performance. These models can generate new samples and augment data sets for images, text, speech, tabular data, and statistical distribution time series data, finance, and more. The data generation and augmentation capabilities of generative AI have applications in medicine, healthcare, gaming, education and training, art and creativity, self-driving automobiles, and many more. Another powerful capability of generative AI models is their ability to create highly realistic and complex virtual worlds. You can create avatars that simulate realistic behavior, expressions, conversations, and even decisions. You can also create complex virtual environments with realistic textures, sounds, and objects that follow the principles of the physical world. Metaverse platforms use generative models to create unique and personalized experiences for individual users. Generative AI also makes it possible to create virtual identities with unique personalities, avatars that can be fitted with specific personality traits that reflect in their behaviors and conversations. The virtual world capability of generative AI has applications in gaming, entertainment, education, augmented and virtual reality, metaverse platforms, and also virtual influencers and digital personalities. In this video, you learned about some of the capabilities of generative AI models and their use in the real world. Generative AI can create coherent and contextually relevant content and generate realistic, high-quality images, synthetic voices, new audio, and dynamic videos. And generative AI models can generate and complete code and synthesize new data to augment the existing data sets. Generative AI models are also capable of creating highly realistic and complex virtual worlds, including virtual avatars and digital personalities. Welcome to Applications of Generative AI. After watching this video, you'll be able to identify some of the applications of generative AI in different domains, specifically the domains of IT and DevOps, entertainment, education, banking and finance, healthcare, human resources, and on-working professionals in general. In IT and DevOps, generative AI helps improve software delivery processes and infrastructure management. The code generation capabilities of generative AI reduce manual coding effort and time spent on repetitive tasks. Generative AI-powered code review tools such as GitHub Copilot and Sync's Deep Code examine code repositories and coding standards to enhance code quality and maintainability. Generative models generate synthetic test cases and test data that simulate user behavior. Variations in test cases impact software efficiency, reliability, and robustness. Tools such as Applitools and Testim guarantee adequate testing coverage by increasing the depth and diversity of data sets. To monitor and detect anomalies in code, tools such as IBM's Watson AI Ops and Mugosoft AI Ops analyze system logs, metrics, and other data. This helps with proactive maintenance and troubleshooting, reducing downtime and preventing critical failures. GitLab Duo supports the continuous integration and deployment, or CI/CD, pipelines by automatically creating release notes, changing logs, and updating deployment templates and scripts. Other applications in IT and DevOps include natural language interfaces, automated infrastructure management, and predictive maintenance. Now let's look at the entertainment domain. Generative AI tools can generate a variety of synthetic content, such as music, scripts, stories, videos, movies, and video games. They can also translate, localize, and personalize content. Game development tools such as Houdini by SideFX leverage the power of generative AI to create games, animations, augmented and virtual reality experiences, and unique characters with unique behavior. Recently, generative AI-powered virtual influencers and avatars have also gained popularity that interact with users, creating engaging experiences. Another next big area of impact of generative AI is education. From content generation to personalized and adaptive learning experiences and simulated experiential learning, the impact of generative AI is huge. With their language capabilities, they can provide language translations, making content accessible in different languages. They can grade assignments to provide instant feedback and create learning journeys and assessment strategies that support the pace and strengths of individual learners. Taxonomies can be generated based on learner performance and preferences. Generative algorithms can detect special needs and learning disabilities to help learners and educators create specific lesson plans. Generative algorithms are also being used to track learner progress over time. Known as knowledge tracing, this helps provide the right pacing and content for individual needs. Tutoring support, virtual and simulated environments, and inclusive education are also benefited. Knoll.J, for example, offers an AI-generated e-learning within minutes, including interactive videos, glossary, practice questions, and summary for the targeted topic. Duolingo is a language learning platform that uses GPT-3 to correct French grammar and create test items for English. Banking and financial institutions greatly benefit from generative AI's capability to auto-detect risks, generate insights, and make financially literate recommendations. KAI-GPT is the first banking industry-specific LLM that helps banking applications provide human-like financially literate responses. In risk assessment, Data Robot, for example, can generate synthetic use cases by simulating potential fraud scenarios to detect credit risk, fraud risk, and market volatility. For credit scoring, Personetics and AIO Logic leverage generative models to detect risks, determine rates, and structure custom loans. They automate the assessment of customer creditworthiness and set credit limits or insurance premiums. NLP-powered generative AI, such as Bloomberg GPT, can analyze news, articles, social media, and other classified textual data to perform market sentiment analysis and manage investment portfolios more effectively. In customer services, generative AI tools have established conversational systems and assist in financial planning using robo-advisors, chatbots, and virtual assistants. Regulatory compliance and reporting, financial forecasting and prediction, portfolio optimization, anti-money laundering, and algorithmic trading are some of the areas that are greatly benefited. It's important to note that some of these applications and tools harness both generative and discriminative AI models. Now, let's discuss some of the applications in medicine and healthcare research, drug discovery, diagnostics, and patient care. With their ability to generate synthetic images that resemble patient data, generative models improve the robustness of deep learning models used for medical image analysis. These models can synthesize data for rare medical conditions for which very limited data is available. This helps facilitate research, train AI models, and develop new diagnostic tools for rare cases. In drug discovery, these models help by generating new molecules and speeding up the drug discovery process and lowering the development cost. Telemedicine and telemonitoring are also benefited from generative AI-driven conversational tools. RASA, for example, can establish a medically literate conversation with patients to provide immediate medical advice, health-related support, and personalized treatment plans. Other areas in this domain include electronic health record, or EHR management, healthcare fraud detection, and medical simulation and training. Let's look at how generative AI can empower human resources, or HR, to automate repetitive tasks, provide valuable insights, and streamline HR processes. Watson X Orchestrate, for example, helps automate HR tasks such as creating job requisitions, screening and shortlisting relevant profiles, scheduling interviews, candidate onboarding, and more. Talenteria focuses on talent acquisition. Lena AI uses conversational AI systems to automate HR tasks and employee engagement. Macorva focuses on workplace and performance management by automatically generating performance documents and reviews. Other applications of generative AI in HR include training and development, analytics and decision-making, and compliance and policy implementation. While we have spoken of just a couple of domains today, generative AI is ultimately believed to have a significant impact on all industries. Another big area of impact is on how we work. As per the McKinsey report on the economic potential of generative AI, current generative AI and other technologies have the potential to automate work activities that absorb 60 to 70% of employees' time today. Half of today's work activities could be automated between 2030 and 2060. Generative AI's increasing ability to understand natural language will ultimately impact even knowledge-based work, typically associated with higher education and acquired skills. In this video, you learned about some of the popular applications of generative AI across domains. However, it's important to note that the potential applications of generative AI are virtually limitless across all industries and all walks of life. In IT and DevOps, applications include code generation, code reviews, automated testing, monitoring and anomaly detection, automated documentation, and the continuous integration and deployment process. In entertainment, generative AI offers exciting possibilities by generating a variety of synthetic content and translating, localizing, and personalizing content. In education, generative AI transforms the reach and quality of education, affecting learners, educators, and educational technologies. In finance, areas of application include risk assessment, credit scoring, sentiment analysis, portfolio management, compliance, forecasting, trading, and customer care. In medicine and healthcare, we see application in medical research, diagnostics, medicine, medical training, and patient care. In HR, applications are in the areas of talent acquisition, employee engagement, performance management, training and development, HR analytics, and policy implementation. And in the workplace, the application of generative AI is changing how we work, making us more efficient and successful. Welcome to Tools for Text Generation. After watching this video, you'll be able to describe the basics of text generation through generative AI, explain the key capabilities of common models and tools for text generation. At the core of the text generation capabilities of generative AI are large language models, or LLMs. Based on patterns and structures learned during training, LLMs interpret context, grammar, and semantics to generate coherent and contextually appropriate text. Drawing statistical relationships between words and phrases allows LLMs to adapt creative writing styles for any given context. LLMs are the basis for many text generation models. Two such examples are Generative Pre-trained Transformer, or GPT, and PaLM. These models have evolved into multimodal models, offering multiple capabilities. Let's learn about the capabilities of these models through two popular tools, ChatGPT and BARD. ChatGPT is based on GPT as the large language model and uses advanced natural language processing, or NLP. While originally ChatGPT only took text prompts as input to generate new contents, with the newer versions it can take both image and text inputs. ChatGPT offers diverse capabilities for text generation. It is capable of smooth and context-based conversations. Let's start a conversation with ChatGPT to learn a concept. Input a prompt that says, "I've heard about generative AI and want to learn more." ChatGPT responds with some basic information based on the context. When you take the conversation forward to refine the research by asking, "How can I use generative AI to improve my storytelling skills?" as a prompt, ChatGPT provides the response based on the context and question provided by you. Feel free to experiment and guide the conversation further. ChatGPT will build an informative and interesting conversational flow. It can also help you with varied creative tasks. Let's enter the prompt, "Help me to create slides to demonstrate the features of a learning platform." And ChatGPT comes with suggestions about the title, content, and visuals for specific slides. Although ChatGPT is most proficient in English, it can understand and respond to several other languages. Let's prompt it to write hello in French and Spanish, and it generates the desired output. ChatGPT can also be a useful tool to assist you in learning a new language, or any subject for that matter. Another popular text generation tool is Google Bard. It is based on Google's advanced language models, PaLM, short for Pathways Language Model. PaLM is a combination of Transformer model and Google's Pathways AI platform. Path AI is based on Pathways, which are specialized modules responsible for a particular task, such as NLP or machine translation. In addition to the massive training data set of text and code, it also pulls information from sources on the internet to respond to prompts. Try experimenting with different prompts to explore the capabilities of Bard. Let's try Bard with a prompt to get a summary of the latest news on a topic, such as "Provide a summary of the latest news on the war in Ukraine." It provides you with multiple drafts as the response. You can select one of these or regenerate. Next, let's try Bard to generate ideas or solve a problem. Let's prompt it to provide a strategy for a digital marketing campaign for promoting a fashion brand. It provides a step-by-step approach to the marketing campaign. ChatGPT and Bard offer capabilities for other valuable use cases. For example, they can help you with basic mathematics, statistics, and problem solving through these subjects. They are also proficient in financial analysis, investment, research, budgeting, and more. Furthermore, ChatGPT and Bard can generate code and perform code-related tasks across various programming languages and frameworks. Having interacted with both ChatGPT and Bard, you'll notice that ChatGPT is more effective in generating dynamic responses and maintaining conversational flow, while Bard may be a better choice for researching the latest news or information on a topic, as it has access to web sources through Google Search and Google Scholar. It's important to realize that generative AI models, including GPT and PaLM, are evolving, so their capabilities and features may change. Apart from ChatGPT and Bard, there are other text generators as well. Jasper, for example, generates high-quality marketing content of any length, tailored to a brand's voice. Writer is a valuable tool for creating high-quality content for blogs, emails, SEO metadata, and ads on social media. Also, Copy.ai is great for creating content for social media, marketing, and product descriptions. Another tool, WriteSonic, offers specific templates for different types of text, such as articles and blogs, ads, and marketing. There are also tools available for specific use cases. For example, tools like Resumer can generate a summary of a text by extracting key ideas or concepts. Next, tools like uClassify are used for classification to assign one or more categories to a snippet of text. Tools for sentiment analysis understand and generate text that reflects the underlying emotions expressed in human language. Examples include Brand24 and Repustate. For multilingual language translation, you can use Language Weaver and Yandex. It is important to note that many of the open-source generative AI tools collect and review the data shared with them to improve their systems. This is an important consideration for interacting with these tools to avoid sharing any confidential or sensitive information. So, do we have open-source privacy-preserving alternatives? The answer is yes. GPT for All, for example, can be installed on your machines to run as a privacy-aware chatbot without internet or a graphics processing unit. Further, chatbots like H2O AI and Private GPT are designed to protect user privacy by running on local machines without any internet connection using the power of LLMs. Not only that, you can customize these tools for use within a specific organization by linking them to your organization's documents and databases. Generative AI-based text generators offer several benefits. These tools are good learning aids as they provide step-by-step explanations. They can generate different forms of text quickly, enabling efficiency for writers and creators. These tools enhance creativity and inspire new ideas. By enabling engaging and interactive conversations, they're useful as virtual assistants and chatbots. By automating repetitive writing tasks, they can increase productivity for organizations. With multilingual support, they enable communication and content localization for global audiences. In this video, you learned that LLMs interpret context, grammar, and semantics to generate coherent and contextually appropriate text. LLMs are the basis for many text generation tools. Two popular text generation tools are OpenAI's ChatGPT and Google Bard. ChatGPT is based on GPT, and Bard is based on PaLM. Both ChatGPT and Bard can generate different kinds of text, translate languages, and answer your questions in an interactive and informative way. Some of the other tools we talked about include Jasper, Copy.ai, WriteSonic. Open-source privacy-preserving text generators include GPT for All, H2O AI, and Private GPT. Welcome to Tools for Image Generation. After watching this video, you'll be able to describe the basic capabilities of generative AI models for image generation and explain the key capabilities of common models and tools for image generation. Generative AI image generation models can generate new images and customize real and generated images to give you the desired output. For example, you may want to generate an image of a child with a book in her hand. Further, you may want to change the color of the book cover in the generated image. Let's generate a new image using a free AI image generator, FreePic. You need to enter a text prompt describing the image you want to create. Let's say you enter the following prompt: a boat sailing on a calm lake at sunset surrounded by lush greenery and a serene sky. Remember, how you describe your image and the words you include in the prompt determine the accuracy and quality of the image that gets generated. Let's select the style and generate the image. Here we have multiple images generated. You can select and download an image, or you may want to generate other images by modifying the prompt. Let's look at some more possibilities of image generation models. Image-to-image translation refers to transforming an image from one domain to another while preserving the original matter and style. For example, converting sketches to realistic images, converting satellite images to maps, converting security camera images to higher resolution images, and enhancing detail in medical imaging. Style transfer and fusion involve extracting the style from one image and applying it to another, creating hybrid or fusion images, for example, converting a painting to a photograph. In-painting refers to reconstructing missing or damaged parts of an image to make it complete. You can use this for art restoration, forensics, removing unwanted objects and images while preserving continuity and context, and blending virtual objects into real-world scenes in augmented reality. Outpainting involves extending the original image by generating new parts to it that are like extensions of the original. This can be used for generating larger images, enhancing resolution, and creating panoramic views. The image generation and modifications capabilities of generative models and tools have evolved with the evolution of models that power them. OpenAI's DALL-E is based on the GPT model. Trained on larger data sets of images and their textual descriptions, DALL-E can generate high-resolution images in multiple styles, including photorealistic images and paintings. DALL-E has evolved, and the new versions of DALL-E provide capabilities for generating multiple image variations and image transformation through in-painting and outpainting. Stable Diffusion is an open-source text-to-image diffusion model. Diffusion models are generative models that can create high-resolution images. Stable Diffusion is primarily used to generate images based on text prompts, though it can also be used for image-to-image translation, in-painting, and outpainting. NVIDIA's Style GAN model separates the modeling of image content and image style, enabling precise control over style for manipulating specific features like pose or facial expression. Style GAN has evolved to generate higher resolution images with more realistic details. You can explore generative AI's text-to-image generation capabilities using free tools like Crayon, FreePic, and PixArt. These tools can generate images in different forms and styles. Photor and Deep Art Effects offer a variety of pre-trained styles, allowing you to create your own custom styles. DeepArt.io is an online platform that turns photos into artwork of different styles. Midjourney is a platform that enables image generator communities that help artists and designers to create images using AI and explore each other's creations. Many generative AI image generators can also be integrated as APIs to embed their functionality and capabilities into different software programs and tools. Some popular image generators that offer APIs include DALL-E, Midjourney, and Crayon. Technology giants such as Microsoft and Adobe have also stepped into the world of AI image generators. Microsoft Bing Image Creator is based on the DALL-E model. You can access this tool by navigating to bing.com/create or through Microsoft Edge. This makes Microsoft Edge the first browser with an integrated AI image generator. Adobe Firefly is a family of generative AI tools designed to integrate with Adobe's Creative Cloud applications, such as Photoshop and Illustrator. Firefly is trained on Adobe stock photos, openly licensed content, and public domain content. Firefly can take text prompts in over 100 languages and include tools that allow you to manipulate color, tone, lighting, composition, generative fill, text effects, generative recolor, 3D to image, and extend image. In this video, you learned that generative AI-based models and tools can generate new images through both text and image prompts. They also offer capabilities for image-to-image translation, style transfer, in-painting, or outpainting. A few prominent image generation models include DALL-E, Stable Diffusion, and Style GAN. There are several image generating tools available that offer diverse capabilities for image generation and transformation. A few image generators can also be integrated as APIs. You also learn that Adobe Firefly is a family of generative AI tools designed to integrate with Adobe's Creative Cloud applications. Welcome to Tools for Audio and Video Generation. After watching this video, you'll be able to describe how generative AI audio and video tools create impactful media content. Explain the key capabilities of generative AI audio and video tools. Explore generative AI's ability to reimagine virtual worlds. Market.us estimates that the generative AI music market, valued at $229 million in 2022, will register a high CAGR of 28.6% to reach $2,660 million by 2032. Generative AI music is created using generative AI audio capabilities. Over the past few years, these capabilities are helping companies and individuals, novice or experienced, simplify their processes to bring their complicated visions to life. Think about this. Suppose you've been putting off starting your podcast or adding some sound effects to your remixes. In that case, you'll love what generative AI audio tools can do for you. They come in 3 categories: speech generation tools, music creation tools, and tools that enhance audio quality. Speech generation tools are mostly text-to-speech or TTS tools that convert text into audio. While read-aloud technology is not new, generative AI architecture has upgraded how this technology works. Deep learning algorithms are repeatedly trained on vast data sets of human speech. This allows them to break down and efficiently replicate vocal characteristics, such as pronunciation, speed, emotion, and intonation. As a result, generative AI TTS tools create more accurate, natural-sounding speech, which is especially helpful to those who struggle with visual impairment, language barriers, and other reading disabilities. On the fun side, these tools can help you listen to essays, feedback, and notes, which might be easier than reading them. They can also help you communicate better. What if you wish to narrate your presentation in a standout manner? You could log into LOVO, Synthesia, Merv.ai, or Listener and choose from vast libraries of AI voices, languages, or emotions. You could even create a unique voice or clone your voice. Some tools will also let you edit your vocal track's pronunciation, tone, and speed to create a professionally sounding final product. What about music? Let's say one sunny afternoon, the amateur musician in you is feeling motivated. You could try Meta's AudioCraft, a generative AI tool pre-trained on sound effects and 20,000 hours of Meta-owned or licensed music. There's also Shutterstock's Amper Music, AI VA, Soundful, Google's Magenta, and the GPT-4-powered Wave tool. These tools let you choose from extensive music banks, different music genres, instrumental styles, and melodies. All you need to do is enter a text prompt. Based on your request, the tool will write short melodies or riffs, suggest or add instruments, compose a new song, or create a soundtrack for your next YouTube or Instagram video. Generative AI can also help you mix, master, and publish your final musical output on popular streaming platforms. You can even use audio-enhancing tools. These are pre-trained to identify specific sounds and can add fun sounds to your audio or remove unwanted ones. For example, Descript can help you remove background noise, enhance low-quality recordings, and add the desired sound effects. Auto AI cleans your files of unwanted noise. Many music generation tools also possess audio editing and enhancement capabilities. However, some projects need more than eclectic sound effects. In 2022, Runway AI used generative AI capabilities to produce the Oscar-winning movie Everything Everywhere All at Once. Even if you're not making big cinema, you can use generative AI video tools in your everyday life. Let's say you're making a documentary on the lack of trees in your city. You could log into Runway's Gen 1 tool, which transforms existing video clips into different styles, or use Runway's Gen 2 tool to create a video using text, image, or video inputs. Alternatively, you can use the EaseUS Video Toolkit or the Synthesia app. These tools will allow you to upload photos. If you don't have any, use text prompts to generate the images you need. Additionally, you can use these tools to record a narration, enhance your audio, convert your video file format, and publish your video. Synthesia even allows you to create custom avatars to increase your brand recall. Generative AI can enhance your virtual world experience. You can create unique, imaginative virtual worlds with hybrid characteristics and exotic landscapes. Generative models can also respond in real time, improving the accuracy of simulations. Metaverse platforms employ generative AI to create a more personalized and engaging user experience. Gaming metaverses allow you to rapidly generate 3D objects and even create avatars fitted with specific personality traits that reflect in their expressions, behaviors, conversations, and decisions. The Sandbox, for example, is a metaverse where users can instantly build, own, and market their games globally. Scenario AI helps create and connect customized mobile gaming assets. In this video, you learned how generative AI audio and video tools can make an impact. With a simple text prompt, you can produce human-sounding speech in multiple languages, record songs, add sound effects, or remove unwanted noise. publish professional videos and animations, build enhanced and exotic virtual worlds. Welcome to Tools for Code Generation. After watching this video, you'll be able to describe the basic capabilities of generative AI for code generation, discuss the strengths and limitations of text-generating tools for code generation, and explain the key capabilities of common models and tools for code generation. Generative AI models and tools for code generation can generate code based on natural language input. Based on deep learning and natural language processing, or NLP, these models comprehend the context and produce contextually appropriate code. Code generators can generate a new code snippet or a program from a text prompt. They can predict lines of code to complete a partial code snippet. They can also produce optimized versions of existing code. Further, these code generators can convert code from one programming language to another. They can also generate summaries and comments for code to improve documentation. Code generators can also recommend a complete programming solution. Describe a problem you're trying to solve, and code generators will suggest algorithms, data structures, and the right programming approaches. Let's explore the capabilities of GPT for code generation. OpenAI's GPT excels in human-like text generation and demonstrates impressive capabilities in code creation. Here's an example of generating simple Python code through ChatGPT, a tool based on GPT. When you enter a text prompt, write a Python code to generate a message to greet a person. ChatGPT generates the Python code for it. Interestingly, it also provides guidelines about how to run this code. For generating code, it's important that you provide a clear prompt, specify the programming language, and provide other relevant requirements and constraints. To demonstrate how GPT helps debug code, enter an incorrect code as a text prompt in ChatGPT. An incorrect code and text are prompted to ChatGPT. ChatGPT provides the correct code and explanations of the corrections made. GPT also enables translating code from one programming language to another. It can also generate code documentation and comments to improve readability. GPT-based models and tools have evolved to generate longer and more accurate codes. This enables using these models and tools for coding to develop apps, websites, and plugins. Furthermore, the evolution of GPT makes it possible to generate code from images. For example, you can input the image of a course outline to generate code for a fully functional app. Google Bard also offers code generation and debugging capabilities in more than 20 programming languages. ChatGPT and Bard are valuable tools for coding or a new programming language because they provide a step-by-step and detailed explanation for better understanding. ChatGPT and Bard excel at generating code with basic logic and programming concepts. They may not, however, be able to generate large or complex code from scratch. And while these tools understand programming concepts and syntax, they may not completely understand semantics. So, while the generated code is technically accurate, it may still not function as required. It's important to note that the knowledge of these models is limited to the data they're trained on. A specific version of GPT may not be aware of programming frameworks and libraries released after its training. For example, the knowledge of GPT 3.5 is limited to September 2021. So, if you want a more dated code generator, consider using models and tools designed specifically for code generation. GitHub Copilot, an AI code generator, can generate code based on various programming languages and frameworks. GitHub Copilot is powered by OpenAI Codex, which is a generative pre-trained language model. It helps developers generate solution-based code. Copilot is trained on natural language text and source code from publicly available sources, including GitHub repositories. Copilot can be integrated as an extension with popular code editors, such as Visual Studio. It can produce code snippets that adhere to best practices and industry standards. Polycoder is an open-source AI code generator. It's based on GPT and trained on data from various GitHub repositories written in 12 programming languages. It's particularly accurate for writing C codes. Polycoder offers an extensive library of predefined templates that can be used as blueprints for code generation for various use cases. Polycoder can help create, review, and refine code snippets precisely customized to requirements. Different code generators offer specific functionality and features. However, when the requirement is to enable hybrid cloud developers to write code for diverse needs, IBM Watson Code Assistant is an option. It's built on IBM Watson X.AI foundation models for developers of any skill level. You can integrate Watson Code Assistant with a code editor. It enables developers to write code accurately and efficiently with real-time recommendations, autocomplete features, and code restructuring assistance. Moreover, you can input code or project files into Watson Code Assistant for analysis. It identifies patterns, suggests improvements, and generates code snippets or templates. Developers can customize this generated code for specific project needs. Many other AI-driven code generators and code assistant tools are available to help developers write accurate code faster. Amazon Code Whisperer can be integrated with code editors and offers real-time code recommendations. Tab 9 can be helpful for accurate code completions. Replit is a platform that provides an interactive space for users to code, learn, and collaborate. With automatic code writing and optimization capabilities, AI-based code generators help developers increase their productivity and quality of code. They enable rapid prototyping to iterate on design ideas. These tools also help with cross-platform compatibility and migration by enabling multi-language code translation. AI-based code generators follow consistent patterns and coding standards. They can suggest refactoring patterns to adhere to best practices. However, these tools should be used with caution to ensure that the AI-generated code does not lead to ethical issues. For example, security vulnerabilities, as these tools may be used for generating malicious data or data biases based on training. In this video, you learned that generative AI-based models and tools can generate new code from text and image prompts, optimize existing code, and produce solution-based code. ChatGPT and BART are useful for simple code generation, debugging, and learning programming. Prominent code generators like GitHub Copilot, Polycoder, and IBM Watson Code Assistant offer varied features such as real-time recommendations, code restructuring, and solution templates. In general, code generators improve productivity, accelerate development cycles, promote coding best practices, and foster consistent coding standards. Let's get started with the basics of prompt engineering. An expert knows all the answers if you ask the right questions. Interestingly, this is the same principle on which we design prompts for generative AI models. Prompts that we use to query and question AI applications such as chatbots, image, audio, or video generation tools, and even virtual worlds. Prompts optimize the response of generative AI models. The power lies in the questions that you ask. Knowing how to write a prompt that is effective and direct will allow you to generate more precise and relevant content. A good question to ask right now is, what will I be able to do after completing this course? This course invites all beginners, whether professionals, enthusiasts, practitioners, or students who have a genuine interest in learning how to write effective prompts. A course for everyone, regardless of your background or experience. By the end of this course, you'll be able to explain the concept and relevance of prompt engineering in generative AI models. Apply the best practices for creating prompts. Assess commonly used tools for prompt engineering and apply common prompt engineering techniques and approaches for writing effective prompts. This is a focused course comprising 3 modules, each of which requires 1 to 2 hours to complete. In Module 1 of the course, you'll learn about the concept of prompt engineering, starting with how to define a prompt and its elements. You'll learn to apply the best practices for writing effective prompts and assess common prompt engineering tools, such as IBM Watson X Prompt Lab, Spellbook, and Dust. In Module 2, you'll study various prompt engineering approaches like interview pattern, chain of thought, and tree of thought. You'll discover techniques for skillfully crafting prompts, such as zero shot and few shot, to produce precise and relevant responses. Module 3 requests your participation in a final project and presents a graded quiz to test your understanding of course concepts. You can also visit the course glossary and receive guidance on the next steps in your learning journey. The course is curated with a mix of concept videos and supported readings. Watch all the videos to capture the full potential of the learning material. You'll enjoy hands-on labs and a final project that demonstrates how to optimize results by creating effective prompts in the IBM Generative AI classroom. The course includes practice quizzes to help you reinforce your learning. At the end of the course, you'll also attempt a graded quiz. The course also offers discussion forums to connect with the course staff and interact with your peers. Most interestingly, through the Expert Viewpoint videos, you'll hear from experienced practitioners who will share their perspectives on the tools and approaches used in prompt engineering and the art of writing effective prompts. Are you ready to learn everything you can about writing prompts to unlock the full potential of generative AI? Let's get started. Welcome to What is a Prompt? After watching this video, you will be able to define a prompt and its elements. You will also be able to explain the relevance of writing effective prompts to guide generative AI models to produce the desired results. One of the significant capabilities of generative AI models is that their output closely resembles what a human can produce: relevant, contextual, imaginative, nuanced, and linguistically accurate. And one of the critical factors in generating this output is prompt. So what is a prompt? A prompt is any input you provide to a generative model to produce a desired output. You can think of it as an instruction you provide to the model. For example, write a small paragraph describing your favorite holiday destination. Write HTML code to generate a drop-down selection of cities within an online form. These are straightforward prompts used to produce a specific output. Prompts can also be a series of instructions that refine the output step by step to achieve the desired result. For example, write a short story about a scientist studying life on Mars. What were some of the challenges he faced during his research? With these examples, it is clear that prompts contain questions, contextual text, guiding patterns or examples, and partial input for the model. Based on these natural language requests submitted as prompts, generative AI models collect information, derive inferences, and provide creative solutions. These instructions help the model produce relevant and logical responses or output based on provided inputs. Let's look at some more examples to help us understand this better. Suppose you want the model to write a short story about the struggles and achievements of a farmer who became a successful businessman in 10 years. If your prompt is "Rich Man's Story from a Small Town, His Struggles and Achievements," it'll produce a generic output, as this is what we call naive prompting. It means asking queries from the model in the simplest possible manner. To convey your intentions to the model, you can make simple adjustments that can radically improve the result, like your prompt must have context, a proper structure, and can be comprehensible. So you can rewrite the prompt as, write a short story about the struggles and achievements of a farmer who became a rich and influential businessman in 10 years. Let's look at another example where you want the model to generate an image of a sunset scenery you have in mind. Writing the prompt as "sunset image between mountains" may not give you the desired output. The prompt is too brief and lacks a detailed outline of the image you have in mind. You can rewrite the prompt as "generate an image depicting a calm sunset about a river valley that rests amidst the mountains." To master the art of writing effective prompts, let's understand the building blocks of a well-constructed prompt one by one. Instructions. Give the model distinct guidelines regarding the task you wish to execute, steering the actions of the generative AI model to influence the formation of its response. Like write an essay in 600 words analyzing the effects of global warming on marine life is one example. Context helps establish the circumstances that form the setting of the instruction and provides a framework for generating relevant content. To understand this, let's add some context to the prompt discussed in the previous example. In recent decades, global warming has undergone significant shifts, leading to rising sea levels, increased storm intensity, and changing weather patterns. These changes have had a severe impact on marine life. Write an essay in 600 words analyzing the effects of global warming on marine life. This prompt will help the model generate output aligned with the context. Input data is any piece of information provided by you as part of the prompt. This can be used as a reference for the generative model to attain responses with a specific set of details or ideas. To provide input data, the same prompt can be reconstructed in the following manner. You have been provided with a data set containing temperature records and measurements of sea levels in the Pacific Ocean. Write an essay in 600 words analyzing the effects of global warming on marine life in the Pacific Ocean. Output indicator offers benchmarks for assessing the attributes of the output generated by the model. It can outline the tone, style, length, and other qualities you desire from the output. In the prompt, write an essay in 600 words analyzing the effects of global warming on marine life. The output indicator specifies that the output generated should be an essay of 600 words. It will be evaluated based on the clarity of the analysis and the incorporation of relevant data or case studies. Each of these elements plays a role in helping the generative AI model comprehend your requirements and give you the desired output. In this video, you learned that a prompt is any input or series of instructions you provide to a generative model to produce a desired output. These instructions help in directing the creativity of the model and assist it in producing relevant and logical responses. The building blocks of a well-structured prompt include instruction, context, input data, and output indicators. These elements help the model comprehend our necessities and generate relevant responses. Welcome to What is Prompt Engineering? After watching this video, you'll be able to define what prompt engineering is and explain the relevance and importance of prompt engineering with respect to generative AI models. You'll also be able to explain the process involved in formulating effective prompts through prompt engineering to guide these models to produce relevant responses. The process of designing effective prompts to generate better and desired responses is called prompt engineering. Although generative AI models have the potential to supplement human creativity, if you fail to provide precise prompts, these models may produce inadequate results and even false and misleading information. Prompt engineering is a blend of critical analysis, creativity, and technical acumen. It is not limited to asking the right question. It includes framing the question in the right context, with the right information and your expectation of desired outcomes to elicit the most appropriate response. Let's understand this through an example. A ship is sailing through the Atlantic Ocean. To plan his voyage, the ship's captain wants to know the precise weather forecast for a specific location at a specific time. In this case, providing the model with a simple prompt such as weather forecast of the Atlantic Ocean may not get the desired results. To get the most accurate results, the captain will have to engineer the prompts. When designing the prompt, the captain needs to define the context to include details such as the intended location for the weather forecast, in latitude and longitude, and the time range for prediction. For example, the captain of a ship is planning a strategic voyage in the Atlantic Ocean. To help the captain navigate effectively, provide weather forecasts for the upcoming week from 28th August 2023 to 1st September 2023. The coordinates of the target location are between 20 degrees north and 30 degrees north latitude, and 40 degrees west and 20 degrees west longitude. The captain must also indicate whether he requires specific output, like should the model return information on other weather elements that could affect the voyage. For example, to help plan an effective navigation in the Atlantic Ocean, provide detailed information about expected wind patterns, wave heights, precipitation probabilities, cloud cover, and any potential storms that might affect the voyage during a specified time frame and location. It's important to recognize that prompt engineering is a well-structured iterative process that involves refining the prompts and experimenting with various factors that could influence the output from the model. Let's understand the step-by-step process involved in creating effective prompts through prompt engineering. Define the goal. The initial step in the process involves establishing a distinct goal. You must know what exactly you want the model to generate. For example, form a brief overview of the benefits and risks associated with artificial intelligence in automobiles. Craft initial prompt. Having defined the goal, it's now time to create an initial prompt. This might manifest as a question, a directive, or even a situation depending on the goal. For example, write an article that presents a well-rounded analysis of the benefits and drawbacks associated with the incorporation of artificial intelligence in the field of automobile industry. Test the prompt. The prompt you created should now be tested and analyzed for its response. While the response might be relevant, it could lack the distinct perspective you are aiming for. For example, the response to the initial prompt directly lays out the benefits and drawbacks of integrating artificial intelligence in the automobile industry. It does not highlight any ethical concerns that might arise. Further, there's no discussion on the positive and negative implications of the same. Analyze the response. You must carefully review the response and examine whether it aligns with your goals. If not, make a note of the areas where it fell short. For example, the initial prompt used fails to cover a comprehensive range of benefits and risks associated with artificial intelligence in the automobile industry. Refine the prompt. Using the knowledge acquired through testing and analysis, it's now appropriate to modify the prompt. This might include enhancing its specificity, incorporating additional context, or rephrasing. The initial prompt can be refined as follows. Write an informative article discussing the role of artificial intelligence in revolutionizing the automobile industry. Address key aspects such as benefits, drawbacks, ethical considerations, and both positive and negative implications. Cover specific domains like autonomous driving and real-time traffic analysis, while also examining potential challenges such as technical complexity and cybersecurity concerns. Iterate the process. The last 3 steps are repeated until you're satisfied with the response. Consequently, following several cycles of refinement, the final prompt shall take this form. Write an article highlighting how artificial intelligence is reshaping the automobile industry, focusing on the positive advancements, particularly in autonomous driving and real-time traffic analysis, while thoroughly exploring concerns related to intricate technical aspects, such as decision-making algorithms and potential cybersecurity breaches. Emphasize the implications these concerns may have on vehicle safety. Ensure that the analysis is thorough, backed with examples, and encourages critical thinking. Now, let's summarize the importance and relevance of prompt engineering and generative AI models. Optimizing model efficiency. Prompt engineering helps design intelligent prompts that allow the users to harness the full capabilities of these models without requiring extensive retraining. Boosting performance for specific tasks. Prompt engineering empowers generative AI models to deliver responses that are nuanced and have a context, rendering them more effective for specific tasks. Understanding model constraints. Refining prompts through each iteration and studying the corresponding responses of the model can help us understand its strengths and weaknesses. This knowledge can further guide feature enhancement or complete development of the model in the future. Enhancing model security. Skilled prompt engineering can prevent issues of harmful content generation due to poorly designed prompts, thereby enhancing safe utilization of the model. In this video, you learned that prompt engineering is the process of designing effective prompts to leverage the full capabilities of generative AI models in producing optimal responses. You also learned the process of refining a prompt via prompt engineering. At last, you learned the importance of prompt engineering and optimizing model efficiency, boosting performance, understanding model constraints, and enhancing its security. Welcome to Best Practices for Prompt Creation. After watching this video, you will learn to apply the best practices for creating effective prompts and explain the process of drafting and refining prompts through various examples. Writing effective prompts is crucial for utilizing the full potential of generative AI models to produce relevant and accurate responses. By applying the best practices for creating effective prompts, you can supervise the style, tone, and content of the output generated. You can apply the best practices for crafting effective prompts across 4 essential dimensions: clarity, context, precision, and role-play or persona pattern. Let's explore each of these aspects individually. To have clarity in your prompt, keep the following points in mind. Simple and straightforward language can convey instructions easily. So write prompts that are unambiguous and easy to comprehend. Specialized terminologies can potentially puzzle the model or the users. So write prompts using simple terms that can be understood by a broad range of audiences. Vague prompts could lead to responses that do not align with your intentions. Therefore, you must provide a clear description of the task that the model must perform. Let's understand this through an example. Discuss culinary processes that take place on foliaceous stipules of plants with the help of sunlight. Also mention a green thing and how light, air, and water are important for aerial parts of the plant. This prompt has much ambiguity. Nowhere does it explicitly mention the process you want to discuss. The prompt contains complex terminologies, which make it difficult to comprehend. It's also vague and does not clearly describe the task at hand. To ensure clarity, you can rewrite this prompt as, explain the process of photosynthesis in plants, detailing the role of chlorophyll and how sunlight, carbon dioxide, and water contribute to this biological function. The revised prompt has simple, clear, and concise language and explicitly states that you want to discuss the process of photosynthesis in plants. Moving on to the next essential dimension, which is the context. Context always helps the model understand the situation or the subject. This could involve giving a brief introduction or explanation of the circumstances in which the response is required. Relevant information or specific details like people, places, events, or concepts help guide the understanding of the model. So it's important to incorporate such details while writing prompts. For example, the prompt, "Write what happened during the outbreak of the Revolutionary War in 1775, does not contain adequate context and specific details to guide the understanding of the model. To establish the right context and include the relevant information, You can rewrite this prompt as, describe the historical events leading to the American Revolutionary War, focusing on key incidents like the Boston Tea Party, Battle of Saratoga, and so on. Highlight the tensions between the American colonies and the British government, and explain how these events led to the outbreak of the Revolutionary War in 1775. Another important dimension for creating effective prompts is precision. Precision helps outline your request in the prompt. If you're searching for a particular kind of response, express that with clarity. Examples incorporated within your prompts can help the model understand what kind of response you're looking for and direct its thought process. For example, in the prompt, talk about supply and demand and how it is affected in economics, there's no precise outline of a particular kind of response and no examples. To ensure precision, you can rewrite this prompt as, explain the concept of supply and demand in economics. Describe how an increase in demand can influence pricing with the help of an illustrative example, like the smartphone market. Similarly, explain the repercussions of reduced supply on pricing by drawing parallels with situations like disruptions in oil production. This prompt clearly expresses that you want to explain a concept with the help of examples. Finally, let's discuss the last dimension, which is roleplay or persona pattern. Prompts written from the perspective of a specific character or persona can help the model generate responses aligned with that perspective. Essential contextual details enable the model to effectively assume a particular role. So if you're requesting the model to reply from the standpoint of a historical figure, a fictional character, or a specific profession, then provide contextual details. Let's look at this example here. Write a log entry describing the strange flora and fauna of an uncharted alien planet. This prompt will simply give scientific details about the alien planet and will not explain its answer from the perspective of a professional. You can rewrite the prompt as, pretend you are an astronaut who has just landed on an uncharted alien planet. Write a log entry describing the strange flora and fauna you've encountered, like the color of the sky and the unfamiliar sounds echoing through the alien landscape. Express your feelings of excitement, curiosity, and a hint of apprehension as you document this extraordinary journey. In this example, you explicitly gave contextual details and assumed yourself to be an astronaut, so this prompt will generate a response aligned with the perspective of an astronaut. In this video, you learn that writing effective prompts for generative AI models is essential for supervising the style, tone, and content of the output. Best practices for writing effective prompts can be implemented across 4 dimensions: clarity, context, precision, and roleplay. Clarity includes using simple and concise language. Context provides background and required details. Precision means being specific and providing examples. And roleplay can enhance responses by assuming a persona and offering relevant context. These practices can be adapted to specific needs for optimal results.